Hi guys, am I audible? Hello? Hello? Audible? Hi everyone, am I audible to you all? Yes? Hi everyone, am I audible to you? Do let me know in the chat section. Am I perfectly audible and visible? Hi everyone, hi. Welcome to Unacademy NEET English and I'm your biology educator Ambika Sharma, and today the session is going to be very amazing because we are going to revise the entire biology with the help of diagrams. So are you people ready for the session? Yes guys, I'm very sorry for starting it late. Actually the studio was locked. So that is why I was not able to start it on time. I'm very sorry for that. So how are you? Did you check that video in which we have shared the plan for the upcoming 4 days? That plan is really very amazing. And if you are going to follow that, definitely from 300 you will reach to the 600 marks, guys. You are going to reach there, right? You people are going to reach there. Yes, with the help of diagrams, we are going to revise the entire syllabus. This is the plan for today because it is the fastest way to revise the topic. है ना? Do you agree? It is the fastest way to revise the topic, guys. Yes? So do share the session link with your friends as well. Let them know that there is going to be a very amazing session in which ma'am is going to complete the entire biology revision with the help of diagrams. And I am going to teach you or you can say that I will help you in the revision as well in the upcoming days, bache, where we are going to revise biology again and again because it is a theoretical subject. And you know that when it is the theory, right, when it is the theory, we need to mug up the facts, we need to revise the things again and again. Okay, so, right, so we will have more and more revision sessions. Don't you people worry, and definitely questions are going to come from that sessions. Only 100 questions are there, bache. And if we are going to practice 1000 questions, so definitely 100 question will for sure come. Isn't it? Isn't it? And thank you so much for making us, 25k subscriber family. We are about to. I know some students are new here, so do subscribe our channel and please make us the 25k family. Okay? Okay? Yes. So let's start the session. Do like the video, do share the video, guys. And here we have the first diagram which we need to revise. So the first chapter that we are going to start is sexual reproduction in flowering plants. What are we going to start? The first chapter that we are going to start is sexual reproduction in flowering plant, and it is the most important diagram. It is the most important diagram. That is why I am starting the session from this particular diagram. So what we can revise from this particular part, just have a look, guys. It is the TS of anther. Right, write down the points as well. Actually, there is no need to write down the points. I'll share the PDF. Just focus here. TS of anther, the transverse section of anther. And what is anther? What is anther? Can you tell me? What is the anther? Anyone? See, I'll brief you. See here. The anther, the filament. Together it is forming the stamen. Right, and stamen is the microsporophyll, male part in the case of flower. It is equivalent to microsporophyll. Now when you talk about the anther, you take the cross section. So you see this part, this is the microsporangium, isn't it? This pollen sac, right? This is the microsporangium. It is the microsporangium. What is it? It is the microsporangium. Again a PYQ. Guys, whatever points I'm going to tell you, they all are PYQs. They all are PYQs. Right? So I will mention that points only. So please take a note of that. Please take a note of that. Right? Okay. And one more thing is there. If you are new to our channel, just subscribe our channel. I want to see that number. It should be 25k family. Right? It should be 25k family. It's still 24.9k family. Let's make it 25k family, guys. Let's make it 25k family in this session only. All of you. Okay. So here you can see this part is the microsporangium. Here we know that this section is very important. Here the question can come from these layers. So if you see here, outermost layer is epidermis, followed by endothecium. Then comes the middle layer, and then we have the tapetum. So question on tapetum used to come in the paper. So what is tapetum? You know that it is nutritive also, it is secretory also. It is nutritive also, it is secretory also. Right, bache? It will provide nourishment to the developing microspores here, plus it is going to secrete many things. Like one example is of the callus enzyme, one example is of the sporopollenin here. right? Sporopollen in here. So one of the most important, right? One of the most important topic, one of the most important diagram it is, right? Please revise it. Within 2 or 3 hours, we are going to finish the session, right? Maximum 3 hours. So please focus here, right? Right? Okay, so this is the point, right? So this is the diagram that you need to remember. So what do you have to remember? The sequence of layer. So sequence of layer, role of tapetum can be asked in the paper. So what is the sequence of layer? What is the sequence of layer, guys? What is the sequence of layer from outside to inside? Quick! What is the sequence of layer from outside to inside, guys? Epidermis, endothelium, middle layer, tapetum. Epidermis, endothelium, middle layer, tapetum. This is what you need to remember. A very important question. This stamen equivalent to microsporophyle. This part is microsporangium. This pollen sac is microsporangium. These words are also important, guys. Now, the next section here. Here we are having the tricks, right? We have the tricks here. What do we have here? We have the tricks here. The trick is ma'am PMS. All of you, just repeat this trick in the chat section, bache. A very important question is going to come from this part. The trick is ma'am PMS. Ma'am PMS. Just type the trick in the chat section. There should be the bombardment of trick in the chat section, guys. All of you, quick, all of you, and do like the video. Number of students are too many, but likes are quite less. Do like the video as well. Okay, so what is the trick here? The trick is ma'am PMS. Now from this question, from this part, question used to come. Here we are talking about the female part, kids, right? We are talking about the female part. So you know that in the case of female, the stigma, style and ovary will be there. The stigma, style and ovary will be there, and we used to call it as, it is equivalent to, this pistil is equivalent to megasporophyll, isn't it? Stigma, style, ovary, pistil or carpel it is, and it is basically the megasporophyll. What is it? It is the megasporophyll, equivalent to megasporophyll. So now here, where do you need to focus? See, this part is the ovary. Within the ovary, you know that there will be the ovule. So this ovule is the megasporangium. Remember this, bache. This ovule is the megasporangium, and within ovule, the embryo sac is going to form, and that is the female gametophyte. Like pollen grain is the male gametophyte, here it is the female gametophyte. Are you getting it, guys? Are you getting it, everyone? Are you getting it? Now here in this diagram, what we need to remember, bache, in a flower, there can be, many, more than one carpels can be there, more than one pistil can be there. So we have the 2 words here. How many words do we have? We have the 2 words here, but you will not even feel like it is a diagram based session. We are going to revise the entire syllabus. So don't you people worry, just focus here. So there are 2 words, you know that. One is the monocarpellary flower. One is monocarpellary, single carpel is there, and another is the multicarpellary. Right. So when there are so many carpels in a flower, so 2 situations can be there. Let's say in a family, so many members are living. Let's say there is a joint family, kids. Let's say there is a joint family. So in a joint family, you know that 2 scenarios are there. Right? 2 scenarios are there. Either all of them are having love, they are staying connected, or they are living together but they are not have that bond. These 2 possibilities can be there, yes or no, guys? These 2 possibilities can be there, yes or no, guys? Tell me in the chat section. Of course. So if we have multicarpellary, right? If we have multicarpellary flower, if so many carpels are there, so 2 possibilities are going to be there. Either it will be apocarpus, A for apo, A for alone. Type it in the chat section. A for apo, A for alone. Syncarpus. Another is syncarpus. Syn means fused. All are fused. Syn means fused. All are fused. So what is the trick that we have here? The question will definitely come from this part. One is apocarpus. Another is syncarpus. So what is the trick that we have here, bache? So A for alone means so many carpels are there but they are not fused. Syn means fused. So as I said, the trick is MAM and PMS. The trick is MAM and PMS. So M stands for multicarpellary, A stands for apocarpus, that is, it is not fused, it is alone, and M stands for mycelia. M stands for mycelia, and here P stands for papaver, this is the example here. M stands for again multicarpillary and S stands for syncarpus. Done with the trick? Yes, yes, bache. Done with the trick? Done with the trick. So, ma'am, PMS. Ma'am, multicarpillary, apocarpus, mycelia, PMS. Papaver, multicarpillary and the syncarpus is here. So, here you just need to look here. Right, bache? So, you can see the examples. The question has been asked from this particular part. This is the hibiscus. We know it very well. And here it is the papaver. It is fused. And here it is the mycelia. Done, bache? Sorted. Done with the trick? Yes, all of you, done with the trick? You have started annoying me a lot.
No, I have just something to announce.
Why? Why you always choose my session?
I'm really sorry.
You should be. Say sorry in front of
I'm
them.
really sorry, guys, to disturb all of you.
Yes, you are breaking the flow, yaar.
I'm really sorry.
You should say sorry like this.
I'm sorry.
No, to me.
Okay, sorry.
Okay, now
I'm
it's
really
fine.
sorry. Ambika ma'am, are you only going to do what are you planning? Class 12 diagrams? There are a lot of texts I'm getting students.
What?
Tell Ambika ma'am to do class 11 diagrams in this session only.
Okay.
So can you extend the session? If you can take it, for 4 hours, 5 hours, take it, then I can maybe cancel my today's session. Guys, are you cool with that? Do you want complete class 11th as well as class 12 diagrams? Say yes or no in the chats. I want the chat box to go up as soon as possible. Quickly.
Unacademy NEET English, please take a poll.
Quickly, guys. Quickly. Give me some thumbs ups if you want all the class 11th as well as class 12 diagrams. Otherwise, Ambika ma'am has planned only class 12. But I got, a lot of texts from the students saying that we want class 11 diagrams as well. So if you really want that, then I'll be cancelling my today's session and Ambika ma'am will be continuing, right? Because we know biology is high weightage. So
50% of the syllabus.
50% of the syllabus. So by somehow you have to be benefited.
Biology teacher, our biology teacher is best. Tell them.
Achha, our biology teacher is best.
It is not convincing at all. You have to convince them.
Dude, she's awesome.
One more. Now it is
she's
natural.
wonderful. Perfect. Wonderful.
Right.
So guys, little change in the plan. So tonight I had planned my one session for complete chemistry formula revision, right? But since biology is
high weightage.
Too
good.
Unfortunately. So I'm going to give her my slot. Let her take all the class 11th, class 12th, right? Because it's all about you should get benefited a lot basically.
So you will take your session tomorrow or day after tomorrow?
We'll see that. I'll see that.
Okay.
And wait. And a lot of students have been asking me about the inorganic marathon, right? So inorganic marathon will happen tomorrow. I think I'll shift it in the morning only. Let's start the inorganic marathon at 11. Let's do complete inorganic in 5-6 hours tomorrow.
No, you will not
okay?
want to disturb me.
No, I want the likes to be yaar. There are more than 850 students watching and there are only 540 likes. This is not done, first of all, right? We are doing a lot for you people and you should we are not asking you for the money, yaar.
Guys, show some support.
Yes? I'm not asking some money.
Even if I have to ask for money, I'll be like, I just need 1 cup of tea, that's all.
Oh my god. No, she's my best friend. She's my best friend. Thank you so much for the 25k subscribers. Thank you so much. Thanks a lot. Keep on supporting. And again, I'm telling you, the ones who are not subscribed to this channel yet, this is your channel, right? Whatever you say, and we are going to be always at your service, right? So do share this particular channel. Let's make it the best across the country. And at the same time, if you have not subscribed the channel yet, please do subscribe the channel, right? And take the likes count till 900 because there are more than 900 people watching, okay? Chalo, ma'am.
Okay, thanks. Now,
again, I'm telling you, she's my best friend, okay?
Shut up. So, you see, ask them to switch on the AC.
AC is not working.
AC
I'll
not
switch on the
working.
AC also. Everything will be done. Guys, continue with the same Josh, right? I am continuously watching your chats, I swear. See, it's open on my phone. So I want the Josh to be high completely, right? Because few days are left. Just let's give the best, right? Let's try to get benefited in very short time.
Sorry.
Okay? So let's give our best.
One student is saying, "Sir, are you married? Who's
No,
going
I'm
to
not
marry?
married.
Who's going to marry him? Who's going to marry you? Now leave. Now
लाइनें लग जाती हैं.
ऐसी कोई लाइनें नहीं लगती हैं.
So,
Please,
guys.
please. Okay, now don't disturb.
Okay.
For the AC, please. AC. Okay. So we were talking about what? We were talking about this, the multicarpellary flower. So many carpels are there. So when they are fused, it is the syncarpus. So the trick here is PMS. So type this trick in the chat section. All of you, be quick. Ma'am, PMS. This is the trick that you need to remember. And for sure, in NEET 2023, question will come from this part. Because in previous year papers, NEET NTA is just asking the question on embryo sac. So this year might be they'll change the trend. Right, this is my guess. Might be they'll change the trend. Okay, if you have noticed, they are just asking embryo sac. So this year they are going to ask a different question. So this is the most expected question. Okay, most expected question. Now come to the diagram of ovule, which we are going to draw in a very simple way. So stigma style ovary. That is what we have. Stigma style ovary. Guys, it is going to be a one short revision for your entire syllabus, right? You can revise the biology with the help of diagrams, and it is the best way. Short notes, diagram, best way, right? At this time, if you think that I will just read NCERT, not possible, because so many things are there. Physics, chemistry, biology is there. Now it's the time for the short notes. It's the time for the tricks. It's the time for the flow charts. It's the time for the diagrams. And biology is going to make 50% part of our NEET. Right? We cannot afford to make mistake in the biology. Okay, we cannot afford the mistake to be there in biology. So guys, it's a humble request. Please watch this session till the end, because I have prepared the session in this way that we are going to revise the biology, and after this just question revision will be there. Question revision will be there. Okay, so here you guys can see that this is the ovarian locule. This is the ovarian locule, that space here, and here we are going to have the ovule. You know that it can vary, it can be bilocular, it can be multilocular. So right now we are talking about the unilocular ovary. Only one locule is there, only one cavity is present there. Here we have the ovule. Now how to draw the diagram of ovule? Let's say this is the ovary. First of all, there is going to be one stalk like structure. Can you name that stalk like structure in the chart section? All of you, can you name that in the chart section? Yes, kids, this is the diagram. Can you name that stalk in the chat section? All of you, this is the hilum. What is it? This is the funicle rather. This is the funicle. The stalk like structure is what, bache? It is the funicle, right? So now here we are having the ovule. So the junction here, it is also a PYQ, guys. It is also a PYQ. So the junction here, right, where the funicle is touching the ovule, what is it? It is the hilum. What is it? It is the hilum. So what is this stalk like structure? It is the funicle. What is this part? It is the junction of funicle and the ovule. Here what do we have? We call it as hilum. Now this is the ovule. So in the case of ovule, there are two outer coverings, and what we used to call that coverings as, these are the integuments. And these integuments will make the seed coat after fertilization. After fertilization, ovule is going to form seed. Ovary is going to form fruit. So this seed is having the outer coverings, the testa and tegumen. So here if you will notice, we are having the outer integument as well, and we are also having the inner integument. We are having the outer integument as well. We are having the inner integument. Outer inner. Right, that is the point. So outer integument after fertilization will form testa. Inner integument will after fertilization will form tegumen. Another important question from this part. Mark my words, you will get these questions in the NEET 2023. Let me tell you honestly. So here you can see, here the integument is not covering this entire ovule. So this part is the micropyle. It is the micropyle. Now always remember, opposite to micropyle is going to be the chalazial end. Always remember that. Opposite to micropyle is going to be the chalazial end. Opposite to micropyle is going to be the chalazial end. Always remember that. And here we are having the parenchymatous tissue, and this is the nucellus. This is the nucellus, kids, right? So nucellus, diploid it is, parenchymatous it is. So whatever points I am mentioning, all are PYQs, right? And they will be CYQs soon. Do you know what is CYQ? CYQ means current year question. It is going to be the current year question. So what we have to remember here, opposite to micropyle chalazial, wherever funicle will touch the ovule, that is going to be the hilum. Here we have the nucellus. Now when you look at this particular diagram which is given in your NCERT, only one example is considered, that is of anatropous ovule. Which ovule is it? It is the anatropous ovule. It is the inverted ovule. It is the inverted ovule. What is it? It is the inverted ovule. So now just look at the diagram. See, micropyle, opposite to it chalazial end will be there, outer and inner, and here in nucellus only one cell will grow and it is going to form the embryo sac. Female gametophyte it is. Is that clear, bache? Now here if you will look at this diagram, it is the development, right? Here we are talking about the pollen grains and the maturation of these microspores. So this is what we need to revise, right? Students were asking for a one shot from this chapter now, so that is how I am going to cover. So now you all have seen that diagram. You all have seen that diagram if I am not wrong. Epidermis is there, endothecium is there, middle layers are there, and then comes the tapetum. Within tapetum, sporogenous tissue. Within tapetum, sporogenous tissue is there. Do you remember it, guys? Tell me in the chat section. It's a complete revision of your entire syllabus, right? In less time we are going to cover our entire syllabus. So tell me quickly in the chat section, all of you. Tell me quickly in the chat section, what is it? Epidermis, endothecium, middle layer, then comes the tapetum, and here we are having the sporogenous tissue. Here we are having the sporogenous tissue. Do you remember it? Because I am going to cover a very important topic, all of you. Quickly tell me in the chat section, guys. Quickly tell me in the chat section. Right? So now here all the cells are having the potential that they can undergo the meiosis and they can form the pollen grains. You know that in nature male gametes are too much in number, but the female gametes are less, right? So here what is going to happen? Let's say we are picking up one cell, right? It is going to be the microspore mother cell. It is going to be the microspore mother cell, and whenever you people use the word mother cell, always remember it is diploid and it will undergo meiosis. It is diploid, it will undergo meiosis. It is diploid, it will undergo meiosis. So there will be the meiosis 1, yes or no, kids? There will be the meiosis 1. So meiosis 1 will form 2 haploid microspores, right? Meiosis 1 will form 2 haploid microspores, and then we are going to have meiosis 2. That meiosis 2 will form 4 haploid microspore. So in the paper they can ask you the question, after meiosis 1 how many cells you will get, after meiosis 2 how many cells you will get. This is what you need to remember here. Okay, so microspore mother cell, then meiosis 1 microspores, meiosis 2 4 microspores are there. So it is the linear arrangement. But which arrangement is the most common one? Which arrangement is the most common one? See, in the case of monocots, bilateral arrangement, and in the case of dicots, it is going to be the, yes everyone, I want to see the answer in the chat section, all of you. It is going to be the tetrahedral. Right, in the case of monocots, it is going to be bilateral. In the case of dicots, it is going to be the tetrahedral. This is how your spores are arranged. Now, what is going to happen? How these spores are connected to each other? They are connected with the help of a polysaccharide callose. Do you know it? Do you know about it? These microspores are connected together with the help of a polysaccharide, that is callose. Guys, are you okay with the speed? Are you okay with the speed? I know I am speaking too fast. But all of them are the PYQs, and I want to make sure that we cover entire syllabus in less time. Yes, guys. Tell me, quickly tell me. Quickly tell me, guys. Be quick. Guys, are you okay with the speed? All the important questions I am covering here. I want to see the answer in the chat section, guys. Be quick. Yes, it's a 20K family, but you have to grow this family, right? Then only we'll be able to guide NEET 2024 aspirants, NEET 2025 aspirants. Okay. So now here what do we have? We have the callose. Callose is connecting all the microspores together. So tapetum is going to play the role. So with the help of enzyme callose polysaccharide, callase enzyme, callose polysaccharide, callase enzyme. So tapetum, that tapetum releases the callase, and that is going to separate the microspores, right? So microspores are what? They are haploid. Microspores are what? They are haploid. Now these microspores will further grow. They will grow into the pollen grain, and it is the pollen grain which is the male gametophyte, guys. It is the pollen grain which is the male gametophyte. Now this is the haploid cell that we have, right? This is the haploid cell kits that we have. What do we have here? We have the haploid cell here, and it is what? It is the microspore. So now we are talking about the development of your male gametophyte. What is going to happen here? The unequal division will be there. It will result in the formation of 2 nuclei, and you know that 2 cells will form. The larger one is the vegetative cell. Asymmetrical division is there. The larger one is the vegetative. The small spindle shaped is the, yes everyone, it is the generative cell. What is it? It is the generative cell. So even the vegetative cell, it is haploid. Even the generative cell, it is the haploid. It is the spindle shaped cell. So this is the cell which will further, right? This is the cell which is going to further form the 2 male gametes. Right. So this is the cell which will undergo mitosis, and it will form 2 male gametes. What will it do? It will form 2 male gametes. And what about this vegetative cell? It is the tube cell. It will form the pollen tube. That is what my kids need to remember. And one quick information for all of you: in 60% of the angiospermic family, pollen grains will be released in 2-celled stage, that is generative and vegetative, and in 40% of the angiospermic families, it will be released in the 3-celled stage. So at that time, vegetative cell and 2 male gametes will be there. Is that clear, everyone? Is that clear? So just look at the diagram here. Just look at the diagram. So here you are having the microspore, vacuoles are there, asymmetrical division will be there. Large cell is the generative, it is the vegetative cell, small one is the generative. Up to this part all clear, guys? Up to this part all clear? We have revised many topics here, right? Up to this part all clear? I hope it is clear to you guys. So now let's move to the next diagram. Where is it? Okay, done? Done. Now come to the female part. You all are already aware of the structure of the ovule. I told you about the structure of the ovule, right? I told you what exactly the ovule looks like. So now what is going to happen here? Female gametes are less in nature. So here only one cell from nucellus will become large, and we are going to call this cell as megaspore mother cell. Only one cell here, right here in nucellus, near to the micropylar end, it will start increasing its size. Now we are calling this cell as megaspore mother cell, which is diploid. Megaspore mother cell which is diploid. Now within this nucellus, within this ovule, the next stages will be done. Let me show you that. Okay, within this ovule only. So first of all, this megaspore mother cell will undergo meiosis 1. You people will get 2 megaspore. Then there will be the meiosis 2. You people will get 4 haploid megaspores. Now you know that in the case of females, these 3 cells, because of some unknown mechanism, these 3 cells will get degenerated. These 3 cells will get degenerated. These 3 cells, right? 3 cells will get degenerated, and then after that, what is going to happen, bache? Only single megaspore will become functional, right? Only single megaspore will become functional. So we will have only one functional megaspore. We will have only one functional megaspore. Are you getting my point here? Are you getting my point here? 3 will get degenerated. Now this functional megaspore, obviously it will grow. It is going to increase its size. So this functional megaspore is going to form the future female gametophyte, and that female gametophyte is your embryo sac. Right, it is your embryo sac. What is it, bache? It is your embryo sac. Are you getting it, guys? Guys, if you will attend this session, you are going to master your entire syllabus. You people are literally going to master your entire syllabus. So please be focused, guys. Please be focused. And if you are new to our channel, do subscribe our channel. Right? I think that much we deserve, isn't it? Isn't it? I think that much we deserve. isn't it? So here ultimately 4 megaspores will form, without any doubt 4 megaspores will form, but my dear kids, only one will be functional and it is a PYQ. So to this functional megaspore, what is going to happen? Let's say this is the functional megaspore, it will undergo mitosis. How many mitoses will be there? 3. Again a PYQ, again a PYQ, right? It's a previous year question. How many mitoses will be done here? How many mitoses will be done here? Right? Arey, Wazeem sir is again there in the session. Oh my God, he's so obsessed with my sessions. Isn't it? He's so obsessed with my sessions. I know I'm a very good biology teacher, yaar. But now go and focus on chemistry. Wazeem, just go and focus on chemistry. There is no need to teach biology. There is no need to learn biology. Hai na? I taught some good tricks of chemistry to you, na? Go and check that. Go, revise that. No need to attend my session now. Don't waste your time. Go, revise chemistry. Chalo. So, focus here, guys. Okay, focus here. Okay, so this megaspore will undergo 3 mitosis. 3 mitosis means how many nuclei? Total 8 nuclei. How the structure that we will be getting then? This is the structure that we will be getting. So from last 2 years, this question is coming in the NEET examination. From last 2 years, right? From last 2 years, the question is coming. This question is coming in the NEET exam. So this year, I'm hoping this question will not come. Literally this year, I'm hoping this question is not going to come. But PMS and MAM wala question will definitely come. Okay. So this is the embryo sac. So here you are having the egg, haploid. These two cells, synergids. Here they are having filiform apparatus. Here they are having filiform apparatus. And then what do we have here? We are having the, yes, antipodal cells. Antipodal cells. Okay, bache. And this large cell is the central cell having 2 polar nuclei. Right? Having 2 polar nuclei. Guys, any doubt? Yes, any doubt? Any doubt? All of you guys, do you have any doubt here in this session? In this particular topic, because it is again the most important one. So let's have a look from this particular diagram. Here you are having that nucellus. Here this is the large megaspore mother cell. It will undergo the meiosis 1. It is the meiosis. So you will get two haploid megaspore. So 2 megaspores are there. That is why we are using the word diid. That is why we are using the word diid. And then meiosis 2, it will result in the formation of 4 megaspore. Yes, you are right. Only one spore is growing. So it is monosporic development, Ibrahim. You are very right. Okay. Okay. Then after that, what is happening? This is the one functional megaspore. So 3 mitosis will occur. Right? How many mitoses will occur here? 3. One mitosis will result in the formation of 2 nuclei. Second mitosis will form 4 nuclei. Third mitosis will form 8 nuclei. And that is how they will arrange. Okay. So near to the chalazial end, antipodal cells. Near to the micropylar end, egg apparatus is there. So synergids and egg is present in the egg apparatus. And here you can see it. Right. So this is the micropylar end. So what you have to remember for the exam, what you have to remember for your NEET examination, you just need to, right, you just need to remember one thing, guys. You just need to remember one thing here, and that is near to the micropylar end, you will find the egg apparatus. Am I clear? Near to the micropylar end, there is the egg apparatus. Near to the micropylar end, there is the egg apparatus. Is that clear? If it is a yes, type yes in the chat section. Type yes in the chat section, guys. Quick. Quick, 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 quick. Go for it. So embryo sac, female gametophyte. Near to the micropylar end, there will be the egg apparatus. Near to the chalazial end, there will be the antipodal cells. The largest cell of the embryo sac is the central cell having 2 nuclei, polar. 2 haploid nuclei, polar. So you have to denote it in n plus n way. Right? N plus n, n plus n, n plus n. This is how you need to denote it. N plus n, n plus n. And with time, this polar nuclei will also fuse. It will form diploid secondary nuclei. So to that secondary nuclei, the male gamete will fuse and the formation of endosperm, triploid endosperm will be there. Okay, guys? Okay? Okay? So this is it. This is it. So here you can see, you know that pollen pistil interaction, you know that pollen tube will come, it will send its one tubal cell nucleus, 2 male gametes. Out of that, 1 male gamete will fuse with the egg, 1 male gamete will fuse with the polar nuclei. So we will have one zygote, we will have one triploid endosperm, we will have one triploid endosperm, we will have one triploid endosperm. Yes, bache, you are right. 7 cells, 8 nuclei in the embryo sac, and then this is how the double fertilization will occur. So up to this part, if there is any doubt, do let me know in the chat section, guys. If there is any doubt up to this part, do let me know in the chat section, guys. Clear? Clear? So after the double fertilization, here we have the zygote. The central cell will become primary endosperm cell now. Again, one more previous year question it is. It's a one more previous year question. After the double fertilization, guys, your central cell will be converted to the primary endosperm cell. Mention it in the chat section. Mention it in the chat section. Right? Right, I know Wasim sir is here in the chat section, but he doesn't know anything related to that. Even after class, if I'll ask, no, central cell will be converted to, he'll be like, what he used to do? Something like that. Hai na? Right? Right? Okay. So, central cell will become primary endosperm cell, and this nuclei, they will become primary endosperm nucleus, that is pen, and it is going to be triploid. So you can add a note here. In the case of gymnosperms, right, in the case of gymnosperms, the endosperm is haploid, right, endosperm is haploid. But in the case of angiosperms, the endosperm is triploid. Endosperm is triploid. This is what you should mention in your notes. This is something important. Now come to this part, this zygote. You know that when we talk about the further development, when we talk about the post-fertilization changes, the primary endosperm will grow first. Do you remember that? It is the primary endosperm which will grow first. Why is it so? What is the need behind it? Because endosperm is nutritive. Endosperm is nutritive. Endosperm is nutritive. So first of all, the endosperm development will be there, because when endosperm development will start, then the zygote will grow ahead. Why? Because we know that endosperm is going to nourish the developing zygote. That is why. Now here, this is the zygote that we have. This is the zygote that we have. So now this zygote will undergo one transverse division, right? It will undergo what? It will undergo one transverse division, right? It will undergo what? One transverse division, one transverse division, one transverse division. Focus here, focus. Question can be framed from the diagram part, and this time NTA is going to show you that, right? Mark my words. In the paper you will find it out. Surely you guys will find it out. Okay, so here what you people need to focus. See, zygote will undergo which division? Transverse. What is the word here? Transverse. Guys, mention it in few minutes. We will finish this chapter with the complete revision. So that is why I took a diagram session, because it is very important for kids to revise it. Right? Transverse. Done. Okay, so zygote, it will undergo transverse division. Now after this transverse division, what is going to happen? Right, see, we will be having two cells, 1 and 2. This cell will divide again and again. You can see here, this cell will divide again and again, and it will form this large cell and this suspensor part, right? Can you see this? Again and again transverse division will be there in this particular cell, right bache, and it is going to form this structure. You can see so many cells are there, right? It is the suspensor and the haustoria and the suspensor, and the cell which is present here at the base. This cell is going to form what? This cell is going to form the embryo. Right, this cell is going to form the embryo. So in zygote, after transverse division, we will be having the two cells. The upper one is going to form this haustoria, it is going to form the suspensor. The lower one is going to form the embryo. Lower one is going to form the embryo. So this lower one, it will undergo many vertical divisions also, bache, and it will form different type of embryo. So initially for monocots and dicots, the development is same, and then it will change. So I would like to highlight here one more thing, and that is PGHM. One more trick. One more trick. PGHM. PGHM. P stands for proembryo. G stands for globular. H stands for heart-shaped embryo. M stands for mature embryo. M stands for mature embryo. This is what you need to remember. So, what is the trick here? Post-graduation in hospital management. What is the trick here? It is post-graduation in hospital management. What is the trick here? Type it in the chat section, all of you. It is a post-graduation in hospital management. Post-graduation in hospital management. So, initially there will be the proembryo, that basic structure, right? Then comes the globular embryo, then comes the heart-shaped embryo, and finally there will be the mature embryo. So, these are the stages that you need to remember. If you are practicing the PYQs, right, those who are practicing the PYQs, they know that how important this session is, because whatever I have taught so far, everything has been asked in your NEET examination, right? Right? Every question has been asked in your NEET examination. So, you know that how important this session is. How important this session is. Okay, guys? So, take it like a final revision for the biology. Take it like you are going to kill your biology today, because from tomorrow we are going to practice the questions only. We are going to practice the questions only. Okay? Okay. So, focus here, guys. Hannah, focus. Otherwise, you will be cocus. Do you know what is the meaning of cocus? Do you know what is the meaning of cocus? Cocus. Ma'am, what is the difference in mitosis and meiosis? Dazzling Queen, you should check my first session on this particular channel. You'll get to know about it. Cocus, you know na? Cocus, spherical shaped bacteria. Spherical shaped bacteria. Right? Spherical shaped bacteria. So, focus, otherwise you guys will become cocus. Round. Zero. Okay? So, focus. Done? So, this is the trick. PGHM. Proembryo, globular embryo, heart-shaped embryo, mature embryo is there. Then comes the mature embryo. So, this is the stages. These are the stages that you need to remember. Here we have the suspensor. Why suspensor is growing in such a way? Because it wants to push this developing embryo towards the endosperm. It is pushing this developing embryo towards the endosperm. Are you getting my point? So, here you can see the cotyledon here. It is basically the example of dicot. Right? Now it's the yoga time. If you were following my sessions, then I think you guys know about it. Right? Now it's the time for yoga. It's the time for yoga. Are you guys ready for the yoga? Are you people ready for the yoga? The yoga which will tell you how to remember the diagrams here. Guys, are you ready for it? Okay, are you people ready for it? So, you know that angiosperms too advanced, they are in the angiosperms. What do we have? We have two classes, monocots, dicots, dicots. So, what is the meaning of di? Di means two, cot means cotyledon, di means two, cot means cotyledon, mono means single, cot means cotyledon, right? Having one cotyledon, monocots. Having two cotyledon, dicots. Now, why am I telling you all this? Because their embryos are also different. Because in the embryo, in dicots, two cotyledons will be there. In monocots, one cotyledon is there. Now, it's the time for yoga. What type of yoga are we going to do? I think you might have seen this diagram in your class 11th also. In your 11th morphology also. So, just have a look. Have a look of this diagram. Do you know about this diagram? Do you know about this diagram? What are we talking? We are talking about the dicots. What are we talking? We are talking about the dicots. Dicots having two cotyledons. Dicots having two cotyledons. So, just have a look here, guys. This is the embryonal axis. Now, here, the point to which these are the two cotyledons. What are they? These are the two cotyledons. Two cotyledons. Right. Now, just, so this is the cotyledonary node here. This is the cotyledonary node here. To this cotyledonary node, two cotyledons are attached. Now, just above this cotyledonary node, above, what is the word? Above. So, it is epicotyle. Epi means above. Cotyle word is related to cotyledon. Epi means above. Cotyle Cotyle word is related to cotyledon. Wasim sir, OP in chat. Let's distract ma'am. Sorry, it is not going to happen because they are my lovely students. Okay, they know biology is very important. It doesn't matter, you know, how much you teach chemistry, but in biology, all of you know that you have to score 360 out of 360. Biology is the game changer. Okay. So Mr. Wasim, it is not going to happen. They are going to focus here only. Hannah, he's spamming, he's distracting you. This is what you need to learn in these last 4 days. Many people in your surrounding, your loved ones are going to distract you. But what you have to do, you have to be very strong. There is no need to get distracted. And this man is now checking that emotion. Are you getting distracted or are you focused here? He is basically checking it. Right? Literally, he is checking it. So guys, focus. Or else you will become cocus. Right? Or else you will become cocus. Okay? Now come here. So just above the cotyledon, above means epi, below means hypo. So naming is so simple. Above epicotyle, below hypocotyle. Now this epicotyle will terminate. It will terminate here in plumule. It will terminate here in radicle. Radicle forms the root, the tap root. Plumule forms the future shoot. Radicle form the future root. Plumule form the future shoot. So this diagram clear, guys? This diagram clear? Haan bachche Vinod, this diagram clear? If it is clear, now just listen to me. We will do yoga. Wasim sir, you should try it. We will do yoga, right? We will do yoga. Just imagine these two arms are cotyledons. Just imagine these two arms are cotyledon. Above the cotyledon, epicotyle. Here we have the plumule. This part clear? If it is clear, then please send me the thumbs up in the chat section. Kindly send me the thumbs up in the chat section. Cotyledon, epicotyle, plumule, hypocotyle, radicle. Now, why am I saying it is the yoga session? Just imagine if these two are the cotyledons and I am going to do like that, right? I am going to bend, right? I am going to bend like this. So, means I am putting my cotyledons like that and this part will go down, it is the plumule. This part will go down, it is the plumule. Same is the case here. Many times you students get confused in this particular diagram, but it is not like that, guys. These two arms are the cotyledons. I am going to do like that. So, ye dekho, look at it, cotyledons. So, now my head will go down, my head will go down, my head will go down. So, obviously, this part is going to be the plumule. Here it is going to be the hypocotyle. Here it is going to be the radicle. This is the root cap. Any doubt in this diagram? Any doubt in this diagram? Any doubt in this diagram? Oi, hoi, Rexonite, I like it. Wasim sir, you should read this comment. You are too old to do yoga. You will break your bones otherwise. Huh? See, that's a lovely comment that you got. You are too old to do yoga, otherwise you will break your bones.
Students wanted me to come here. No?
Oh please. I don't know.
Yo guys, yoga.
Let's do it. I'll show them.
I was not there. I was not in the chats. Okay.
Do it. Bend yourself like that. Bend yourself like this.
Yeah.
So see. You have to bend yourself. So these are the cotyledons. These two are the cotyledons. This part is the plumule. Same as the case here. Okay.
And
this is the hypocotyle. That's all.
That's you. That's what you call yoga. Yeah, I thought there is something good.
Oh please.
Go teach.
You were about to say. I know what were you saying? I know that.
Yo. Wasim are in the chats quickly.
No. They know biology is important. So guys, we
Finally,
know.
my mission is accomplished.
Oh,
I
please.
distracted you through chats. Okay.
See. The point is, we know that you people are preparing. You people are stressed. So it is a kind of chilling element for you, and plus you will have a very good revision.
Some water?
I'm already having it.
Pure.
I want tea. I want tea.
You want tea?
Yes.
I'm really sorry. Give me 50 rupees.
You can take it from my wallet. You can take it from my wallet. Okay. Now focus here. Okay. Hannah, he disturbs the session always. Oh, please, now leave. And next time,
Guys,
come
I
up.
want the live watching to cross 1K. Yaar. It's stuck at 963. I mean, call up all your friends, increase the chat speed, everything. It'll automatically go up. Of course.
And you should go
See.
downstairs and you
See.
should bring. No, you should bring the
Wasim
cup
sir
of
OP
tea.
in the chats. No
Dekh-
Ambika ma'am. Wasim sir OP in the chats. Quickly.
Oh, dekho. Ambika.
Wasim sir, OP in the chats.
Ambika. I'll
Wasim
start.
sir's army, get up.
No.
Get up quickly,
no.
get up.
Biology, 50%,
Get up.
90 questions,
Get
90
up.
questions, 90 questions.
I'm going to make the channel private otherwise.
You're so bad. Hannah, for locomotion and movement, we can use him. You're right. See, now leave.
See the
Oh,
chat.
please.
Guys, continue. I want the spam in the chats.
Now you
Spam,
should
spam,
leave. You
yes,
should leave.
spam.
We want to
Wait,
learn.
spam. No. See,
And
Ambika.
see, teacup is just
Ambika,
for
see,
10
yeah.
rupees. It's Ambika also.
Where?
It's Ambika.
I've not seen There's no Ambika.
Ambika.
See, look at the chat. Look at the chats.
I think you should leave now. I think you should
No,
leave.
wait,
Otherwise,
wait,
I'm
wait,
going to
wait.
punch you today.
No, wait. It's
See,
996.
Ambika. Acha, we are going to witness
Yes.
this together. 4 more.
Spam.
Four more.
जलवा है हमारा, right?
कोई जलवा नहीं है.
Yo, killed it.
कोई जलवा नहीं है.
The ones who
कोई
have not
जलवा
subscribed
नहीं
the
है.
channel
Very
yet, do
good.
Subscribe it right now. Take care. See you. Continue.
Come up with a cup of tea.
Okay, I'll get it.
Okay, so now focus here, guys. He is actually a very distracting element, but you have to focus here, right? You will find such people in your day-to-day life, but you really need to be focused. And he's listening to me. He'll come up again. So this is the monocot embryo. Monocot embryo. So here you guys can see, just look at the diagram here. What you have to remember here is this scutellum. What is the scutellum? It is shield shaped embryo. Shield shaped embryo like this. Right, now it's the time for another yoga move. This part is the scutellum. It is the shield shaped embryo. Now just look at this bache. Again, everything is same. Everything is same, but in monocots, what you have to remember? That, let's say this is the plumule, this is the radicle. So P for plumule, see, coleoptile, P is there na, coleoptile, P, and here, this is the radicle, see here, it is coleorhiza. R, radicle. So P for plumule. Plumule is covered by coleoptile, a kind of sheath which is covering that future shoot, and this is the radicle which is covered by the coleorhiza. This is what you people need to remember, guys, and just look at it. This is the shield shaped embryo, the scutellum, and here you can see the epiblast. So what is the epiblast? It is the reduced cotyledon. What is the epiblast? It is the reduced cotyledon. Type it in the chat section, all of you. It is the reduced cotyledon, guys. What is the epiblast? It is the reduced cotyledon. And you can see here, radicle, then root cap, then coleorhiza. Radicle, then root cap, then coleorhiza. This is what you need to remember. For sure, question will come from this part, guys. Question will come from this part. Okay? Okay? Done? So now, here you can see the cotyledons. You know the meaning of micropyle as well. Do you know the meaning of micropyle? In a case of seed, remember micropyle, it's an open kind of aperture by which the gaseous exchange will be done. Right? And here you people can focus. See, this is the example of castor. Castor is an exception. Castor is a dicot, but still have albuminous seed. Another example, still have albuminous seed. So this is the example of castor, right, bache? There is one very important topic from this part, and that is the difference in the seeds. Albuminous seed, also known as endospermic seed, and albuminous seed. That is non-endospermic seed it is. Are you getting my point? So, majority of time, yes, your monocots used to have these endospermic seeds. Why? Because they are having just one cotyledon. They are having just one cotyledon. And when you talk about the X-albuminous seeds, the non-endospermic seeds, then you know that it is in the case of dicots. It is in the case of dicots. But we have the exceptions here. And which exceptions do we need to remember? Exception is your orchid. Orchids are orchid. They are monocots, but still have non-endospermic seed. Okay, non-endospermic seed. And another example is of castor, which is a dicot but still having the endospermic seed. It is very important. It is very important. Now, bache, when you look at this particular diagram, see the same thing, coluptile, plumule, radical, coleorhiza. So here, you just need to focus on this layer, that is alluron. That is alluron. And remember, alluron is proteinaceous in nature. One more PYQ. Right, one more PYQ. Now, here, they are talking about the fruit. So, after fertilization, ovule and ovary. Right, direct question, direct answers. Ovule, after fertilization, see, after fertilization, ovule will form seed. After fertilization, ovary will form fruit. Just keep it in your head. Right, bache? Fruit. So, fruit, if ovary is forming the fruit, then it is going to be the true fruit. Then it is going to be the true fruit. But if any other part, right, other than ovary, if any other part is forming the fruit, then it is the false fruit. Then it is the false fruit, right? So, we have the examples in the NCERT. And what is the example? We have the example of false fruit in the NCERT. So, what are the examples? It's Ambika Sharma cute, right? Ambika Sharma cute. This is what you need to remember. What is the trick that we have? The trick is Ambika Sharma cute. Okay, Ambika Sharma cute. A stands for apple, S stands for strawberry, C stands for cashew. C stands for cashew. C stands for cashew. C stands for cashew. Example of false fruits. So, we have the parthenocarpic fruit also, where you know the fruit will form without fertilization. So, seeds are not there. Seeds are the result of fertilization. Okay. That's all. So, now bache, this is the homework time as well. You know na, these diagrams are from the chapter reproduction in organism. Reproduction in organism chapter it is. These diagrams are from this chapter. So, guys, are you enjoying the session? Because in less than 1 hour, we have completed one chapter and we have completed all the important aspects of that chapter. Tell me. Yeah, I deserve the praise. You should focus on trick na. Ambika Sharma cute, apple, strawberry, cashew, false fruits. Hai na? So, in less than 1 hour, we have revised a very important chapter with the help of diagrams. So, diagrams are important. That's why I kept a session like that, right? But I will only take the class 11th diagrams if you guys are going to support me. If you people will stay till the end, I'll start the revision of class 11th diagrams also. Okay. So, now focus here, reproduction in organism. Right, bache? So, it is your homework. I am not going to tell you this, right? You have to consider yourself as the student of kindergarten. You should consider yourself as the student of kindergarten and this is what you need to fill up. This is what you need to fill up. Okay? Okay, that is your homework. Butterfly, 1 to 2 weeks. Crow, 15 years. Parrot, 140 years. Right? So, these are the blanks that you need to fill. Okay, later on, not now, later on you have to fill. Now, just look at this part. Crocodile is for the 60 years, tortoise for 100 and 150 years. So, this is This is it. So this is your homework. This is your homework. Done, bache? Now, this is the part. Bache, I used to repeat it multiple times. Multiple times. Whenever students ask me, ma'am, which examples are important from algae, which examples are important from bryophytes, I always mention this. I always mention this, bache. Whatever, you know, in NCERT, whatever is repeated, like there is any point, any concept which is related to some other concept also, na, when two interlinked concepts are there, definitely question come from that part. You can check the previous year paper, you will find it, right? You will find it, right? That type of things are there in the NCERT. Okay, that type of things are there in the NCERT. So this is my advice, that do not leave this particular part of reproduction in organism. Do not leave it at any cost. So here you can see, what are we seeing here? These are the zoospores. These are the zoospores. What are they? These are the zoospores. Why do we call it as zoospore? Because they are having flagella and they are motile, right? So they are present in this structure, that structure in the zoosporangium, right? Zoosporangium. So these spores are the result of asexual reproduction. These spores are the result of asexual reproduction. It is mentioned in your diagram. That is why I am telling you, asexual reproduction will result in the formation of zoospores. Not always, but mostly. So in the paper they can ask you, this particular spore is the result of asexual reproduction or sexual. So zoospore, result of asexual reproduction. This is the zoosporangium. Here you are having the zoospore. So chlamydomonas, it is the example. Right? It is the example. We have many more examples also. You will even find it in green algae. You will even find it in brown algae, but not in red algae, because red algae is not having any of the motile structure. Then look at it. It is again conidia. And conidia, you know that again the result of asexual reproduction. So conidia, they are exogenous. They will form outside. They are not formed inside a structure. And this arm, this is the conidiophore. This branch over which they will form, it is what? It is the conidiophore. It is what? It is the conidiophore. Is that clear, everyone? Is that clear, everyone? Guys, energy should be there in the chat section. How much marks can we expect from this video? 250 plus marks. If you are able to recall the things with me. Okay. So again, it is also the result of asexual reproduction. Now, this is also the example of asexual reproduction, budding in hydra. So right now, so it is in the form of an example, in the form of a diagram, but in the paper they directly ask you question. If you will check PYQs, the question based on hydra is definitely there. Okay, so that is how you have to link it. So whatever topics are repeated in 11th or 12th, na, do pick that up. Question will come from that part. And this, my dear friends, gemmules, isn't it? Gemmules, endogenous they are. They form inside. Again, asexual reproduction. Example is sponges. Is that clear? Very good, bache. Is that clear? Right. So now come to this part. Another type of question that was even there in NEET 2022. Have you checked the paper of NEET 2022, guys? Yes? Have you checked the paper of NEET 2022? Tell me. The paper of NEET 2022? Right, I think you all have checked that. So question used to come from this particular part. So here we are having the example of earthworm. So what you have to conclude from this part, earthworm, the annelida, the ferritima, it is hermaphrodite. What is it? It is hermaphrodite. It is monoecious. Remember my another trick? BMH instead of BMW, just keep it BMH. Instead of BMW, just keep it BMH. So B stands for bisexual, M stands for monoecious, H stands for hermaphrodite. So it comes under the example of hermaphrodite animals. And when you talk about the cockroach, we know that the male and female is different, right? So it is sexual dimorphism is there. Dioecious it is. Question will come for sure. Because in NEET 2022, they asked the question from this part. This is Kara. Remember my trick video? Have you checked my trick video, trick wala video on plant kingdom? I posted the video I think few days back. Plant kingdom in less than 10 minutes. I gave you the trick there. Right, I gave you the trick there for this particular part also. SUV, Chal Kara. So Kara is the green algae. Kara is the green algae. I have given you the trick there. Okay, so question was there in NEET 2022. Right, they even ask you the question. They will give you the diagram. They can ask you the naming. They can even ask you whether Oogonium is up or Anthridium is up. They can even ask you Kara is monoecious or dioecious. And question was there from this particular part in NEET 2022. It's a PYQ, guys. It's a PYQ. It's a PYQ. So question like this will definitely come up in your paper. So this is Kara, the example of green algae. So Oogonium, which is the female sex organ, it is upper, it is present on upper side, and here you have the Anthridium, the male sex organ, which is present like that. So this is what you people need to remember. Even focus on these diagram. Cockroach is also there in class 11. So you should know this part is testes, right? This part is ovary. You should know about these diagrams, guys. You should know about these diagrams. Is that clear? Is that clear? So finally your captor is also there in the chart. Now he is trying to distract us, but we will not get distracted, right? We will not get distracted, right? Right? So now here what do we have? Mr. Markensia. What is Markensia? Again a bryophyte. Again a bryophyte. Do check my 10 minutes wala video, plant kingdom in less than 10 minutes. That is the video that I have shared with you all. Okay. Okay, so it will help you to revise plant kingdom in less than 10 minutes. The video is just for 8 minutes. Keep it at a speed of 2x and revise plant kingdom. I'll put some videos on the tricks of morphology as well. You were asking me for the morphology. You were asking morphology, right? Ki ma'am, morphology tricks we want. You'll get it. Okay, you people will get it for sure. Okay, so just look at it. Markensia, bryophyte. Again, they are also monoecious. Sorry, they are also dioecious. Male and female is on different thallus. Archegoniophore and Anthridiophore. And here we have the example of what? The bisexual flower, the sweet potato. Right, yes, bisexual flower, the sweet potato. So now, bache, what is your homework? Sweet potato. You have to tell me the botanical name. Very easy it is. You have to tell me the botanical name. Very easy it is. Very easy it is. Very easy it is. That is your homework. Now, the male reproductive system. I have already taken a session on that. I have explained everything, but still diagrams are important. So you know that the scrotum is what? It acts like a thermoregulator. Will maintain the temperature 2 to 2.5 degree Celsius less than the body temperature. Is that clear? Is that clear, everyone? Is that clear? Now, here we have the testes. What are testes? The primary sex organ in the case of males. The primary sex organ where the spermatogenesis will occur and the part which will release the hormones, right? Then comes the bulbourethral gland. The naming should be very clear to you. Bulbourethral gland, also known as Copper's gland. What is the role of this particular gland? The role of this particular gland is to lubricate the penis. Lubrication of penis during sexual intercourse. This is the role here, right, bache? And here you know glans penis, the sensitive area, right? And this glans penis is covered with the foreskin and it is also known as prepuce, right? So urethra, penis. So prostate gland, you know that it is single, it is not in pair, right, bache? Vast difference, that duct, right? Right, seminal vesicle, it contributes maximum for the semen production. So that is what you need to remember. That is what you need to remember. So if you remember it, then very good. Otherwise, let's have a quick revision. Within the testis, seminiferous tubules are there. Within the testis, seminiferous tubule are there. So in the testis, you know that we will be having the testicular lobules. We will be having the testicular lobules, right? So near about 200 to 250 compartments are there. Remember that example of mine, bache? Remember that example of mine. There is a building. A building is having 250 floors. Each floor is having 1 to 3 apartments. That is the trick here. That is the story trick here. That is the story trick here, right? So in the testis, 250 testicular lobules are present, which are lined with your tunica vasculosa, right? And here 1 to 3 seminiferous tubules are there. 1 to 3 seminiferous tubules are there. So all the seminiferous tubule here will form a network, that is retitestis. So from this part, the accessory ducts will start in the case of male reproductive system. Then comes the vasa efferentia, then comes the epididymis, then comes the vas deferens, and then comes the ejaculatory duct, and finally it will open up in the urethra by receiving the secretion from all the glands. So any doubt here, guys? Any doubt here? Any doubt here? Yes. Yes, so there are 3 glands, the seminal vesicle, the prostate and the bulbourethral. Only prostate is single, rest all are paired, right? Only prostate is single, rest all are paired. Done, bache? So here we can see the diagram. So naming should be clear to you. Okay, the naming should be clear to you. Clear, bache? Now, the next part is the female part. So in the case of female part, we know it very well. The ovaries are going to get connected to the uterus with the help of ovarian ligament. Right. So question here used to come from this part, the ovarian duct, the fallopian tube. The fallopian tube. So here you can see this finger-like fimbriae, infundibulum, the funnel-shaped, fimbriae, finger-like, ampulla, the widest part where the fertilization will occur. Here in ampulla, isthmus is going to link it here. It is going to link it here. Right, bache? Right, bache? So these are the parts that you need to remember. And one question that I have repeated, right? Infundibulum is closest to ovary, right? It is the infundibulum which is closest to ovary. It is the infundibulum which is closest to ovary. Are you getting my point? It is the infundibulum which is closest to ovary. A very important question, the funnel shaped area it is. Right, bache? So here in uterus 3 layers are there, perimetrium, outermost, myometrium having smooth muscles, okay? Right, then comes the endometrium, the glandular, the secretory, the innermost, and here it is the layer where implantation can occur. Where implantation can occur. Where what is going to happen, bache? Where implantation can occur. Right, bache? Where implantation can occur. So any doubt? Any doubt? Here you can see the cervix. This is the inner sphincter, outer sphincter, the cervical canal. Here comes the vagina. So cervical canal plus vagina together they makes the birth canal. So still, guys, if there is any doubt from this particular part, do let me know in the chat section, guys. Do let me know in the chat section. So the session is helping you out. Is the session helping you out? Are you enjoying the session? Yes. Are you enjoying the session? Tell me in the chat section, all of you. Just tell me in the chat section. Be quick. Just tell me in the chat section. Quick. Sure? Sure. So, bache, I have taken the same session for the plant physiology in which I have completed, the most important concept. Do check that video at 2x speed. Okay, that will be a very good video for your revision. Okay, and the strategy that you need to follow also, I have made a video on that. Do check it before going to the examination hall. This is also my advice. So this is the diagram that we have discussed. Okay, so the next part is the mammary glands. Okay, so yes, in this year, I'm expecting that question can come from this particular part, mammary glands. So mammary glands in the case of females, you know that it is the secondary sexual organ. What is it? It is the secondary sexual organ. What is it? It is the secondary sex organ or sexual organ in the case of female. So you know that it is meant for the what? It will basically help in nourishment of that baby, na? It will help in the nourishment of that baby. This is what we know. So here you can see the nipple, the areola part, the darkly pigmented part is there. So here what we need to remember, right? We just need to focus on this part, that there will be the mammary lobe, right? 15 to 20 mammary lobes are there, and that lobes are having the alveoli. Right? It is basically the cluster of alveoli. Right? It is basically the cluster of alveoli. So what is the point that you need to understand here, kids? So you just need to understand one thing, that it is the prolactin. prolactin released from anterior lobe of pituitary. Right, it is the prolactin that will release from anterior lobe of pituitary. Prolactin will act on the alveoli. So in response to that, alveoli will release, it will secrete the milk. Okay, so milk producing hormone is prolactin. So along with progesterone also, even progesterone helps in that. Okay, even the progesterone helps in that. Is that clear? Is that clear? Yes or no? Tell me. Okay, okay. Done? Done? So alveoli, prolactin will act on it, milk will be produced. Then next to this, so these alveoli are together making the mammary lobes. 15 to 20 mammary lobes are there. Then you guys can see the mammary duct, the one large funnel shaped ampulla, then the lactiferous duct is there. 1 in number it is. 1 in number it is. So this is what you need to remember. Is that clear? This is what you need to remember. Now come to the next part, that is basically the spermatogenesis. So this diagram is important. Are you ready for that? Are you ready for that? Right? This diagram is very important. You know that in the case of the very first thing that we need to remember in spermatogenesis, diploid spermatogonia, the flow, primary spermatocyte again diploid. It is the one which will undergo meiosis. Again, PYQ. Spermatogonia, with the help of mitosis, it will divide its number, it will differentiate, it will increase its number. Now when it will increase its size, it is going to form the primary spermatocyte, the large cell having the diploid, which is diploid, the large cell which is diploid. Then comes the first meiotic division. So first meiotic division, it will form secondary spermatocyte, haploid it is. Secondary spermatocyte which is haploid. So primary spermatocyte diploid, secondary spermatocyte haploid. Then second meiotic division will be there, spermatid haploid, which will differentiate into spermatozoa haploid. So spermatid to spermatozoa is spermiation, also known as spermatomeiosis. Spermatomeiosis, also known as spermatomeiosis. Is that clear, everyone? Guys, is that clear? The energy should be there in the chat section. Right? So diploid, diploid, haploid, haploid and haploid. So spermatid to spermatozoa, spermiation and spermatomeiosis. Spermiation and spermatomeiosis. Is that clear? I hope it is clear to you. I hope it is clear to you. Now focus here, the female part. The female part, how the oogenesis is different from the spermatogenesis. Spermatogenesis will start when the male will attain the puberty. And if you want to understand this topic in depth, you can check my video. I have made one short video on the reproduction part as well. You guys can check it. So in the case of females, in the case of oogenesis, what is the different thing that we have, bache? It will start before birth. It is the oogenesis that start before birth. It is the oogenesis that start before birth. Are you getting my point? So in the fetal life, what is going to happen, my dear kids? See, I don't know whether you know the concept or not. If you want to know the concept, just check my video on this channel, right? The reproduction one shot, you guys can check. Or if you don't know the concept, you just need to know the important things, then focus here. This diagram is important. So just have a look, guys. So oogonia, diploid. Mitosis, differentiation. Right, so they can just give you this part only. So here they can miss this word, whether there is mitosis or meiosis. Mitosis or meiosis. So you need to tell it is the mitosis. It is the mitosis, not the meiosis. So primary oocyte again diploid, which will undergo first meiotic division, secondary oocyte, but along with that we will be having the first polar body. We will be having the first polar body. Then the secondary oocyte will form ovum, again haploid. The second polar body will be there. The second polar body will be there. Are you getting my point? So this birth, then childhood, then puberty. So ultimately you know that in the oogenesis, in the fetal stage, there will be an arrest in the diplotein stage. There will be an arrest in the diplotein stage. We even call that as dictate block, right? So from birth to puberty, many follicles will degenerate. We use the word follicular atresia for that. At the time of puberty, every month from one ovary, the egg will be taken, and that egg will further grow, right, bache? That block, meiosis arrest will not be there because of hormones. Then again the development will start, the growth will start, and you know that it will go till metaphase to arrest. Okay, it will go till metaphase 2 arrest, and after that metaphase 2 arrest, my dear kids, you know that the egg will be released. In the ovulation, it is the secondary oocyte which will be released, right? It is the secondary oocyte which will be released. Okay, okay, okay. So you can relate all the hormones part here. Okay, okay. So here you know that this is the most important topic, that is the menstrual cycle. So in the menstrual cycle, there is the periodic shed off of endometrial lining, right? So you know that initially what is going to happen, the pituitary hormone FSH will release, act on follicle cells. Follicle cells will proliferate, will divide, will increase in number, right? They will proliferate, and then slowly when FSH will act on follicle cells, so follicle cells in response to that will start releasing what? Estrogen. What is estrogen? The female sex hormone. So if you know all that things, then this diagram is going to be very easy. See, initially FSH, LH. So the first thing that you need to remember is which hormones are pituitary hormones, FSH and LH. When FSH is slowly increasing, you will see the increase in the estrogen concentration also. You will see the increase in the estrogen concentration also. Slowly even estrogen will increase. So when FSH is at peak, even estrogen is at peak. So along with that, what is happening when estrogen is the amount of estrogen is increasing, it is also acting on this endometrial lining. So if you compare here, when this estrogen amount is increasing, even the thickness of estrogen is also thickness of endometrium is also increasing. Even the endometrial proliferation is increasing. Can you see that? And initially when FSH is at low level, estrogen and progesterone is also at low level, menses are there, periods are there, bleeding phase is there. Very important, bleeding phase is there. So slowly when the amount of FSH will increase, the amount of estrogen will increase, even the endometrial lining thickening will increase. But for the ovulation, LH is very important. Luteinizing hormone is very important. It is required for the ovulation. So here you people can see, because of FSH, follicles are growing. Because of this LH surge, ovulation is there. At the time of ovulation, even your estrogen is at peak, and thickness of endometrium you can also notice, right? You have to remember these days as well. Then after that, what is going to happen? There will be a kind of dip, right? Your LH will come down, your FSH will come down. And when they both will come down, you know that this mature follicle will turns into the Graafian follicle. So when we have the Graafian follicle, the amount of progesterone will be there. It is the secretory phase. The amount of progesterone will be high, which is a pregnancy hormone, right? And then when corpus luteum will degenerate, the level of progesterone will come down, and then it will result in the menstrual cycle. So up to this part, all clear? Thickening of endometrium is directly linked with FSH. Abhinav, FSH will act on follicles. In response to that, follicles are going to release estrogen. That estrogen is helping in the proliferation of the cells of endometrium. Is that clear? Yes, bache, you can score 200 plus marks if you attend this session till the end and you revise too, right? Right, so these are the different stages. Zygote, oh sorry, it is the secondary oocyte having metaphase 2 arrest. Sperm will approach it. You know that fertilization will occur, the zygote will form, and after that you know that, right, there will be the cleavage. So mammalian cleavage is very slow. So first division will occur after 30 hours of fertilization. 2 blastomere, then 4, then morula, 8 to 16 celled stage. Right, so you can see the morula. Here. So yes, this question has been asked in the NEET exam. It's a PYQ. Remember the stages. Secondary oocyte, sperm is going to approach this. Here you have the zygote. The zygote will undergo the cleavage after 30 hours of fertilization. Here you are having the another 4 blastomere stage, and this part is the morula. So yes, they can ask you the question in the NEET paper, right? They can just put this diagram, they can just miss out this ABCD, they can ask you what is A, what is B, what is C, what is D. Okay, then after that this morula, you can see here F, then G bache. So morula is going to form blastula, 32 celled stage. right? And then comes the blastocyst. So the diagram of blastocyst is also very important. So here in blastocyst bache, there is going to be the outer layer, and here you are having the cell mass. Here you are having the cell mass. Can you see it here? Cell mass will be there. Okay, cell mass will be there. So this layer is known as trophoblast. This is blastocyst. So here you have the cavity known as blastocele. Here you have the inner cell mass, which will form future embryo. It will form bilaminar disc. It will form epiblast, hypoblast. The future embryo will be formed by it. So this diagram is very important. Is that clear? So this is the trophoblast layer. Cells of Robber are there. They will help in the implantation. They will release the proteolytic enzyme. So when blastocyst will form, it will get implanted here in the endometrial lining. If there is any doubt from this part, do let me know. Yes, bache, internal cell mass. The cells will arrange themselves. Now, outer layer is trophoblast. Here the mass of cell is the inner cell mass. So this is the inner cell mass. This is the inner cell mass which is going to form the future embryo. Any doubt? Any doubt? But gastrula is the one having that germ layers, na? Okay. So here the surgical ways. We are talking about the contraceptive method, the surgical ways, right? So here you can see this is the vasectomy. This is the tubectomy. This is the tubectomy. Vasectomy, tubectomy. Vasectomy, tubectomy. Vasectomy, tubectomy. Is that clear? Is that clear? Now you can see these contraceptive methods, right? The diagrams are given in your NCERT. So here we are talking about the barrier methods. So in the barrier method, the most commonly used is the male condom. In the case of females, the diaphragms, the volts, the cervical caps are there. The cervical caps are there. So condom, cervical caps, diaphragm, volt. So these three methods in the case of males, in the case of females, right, they are going to block that vagina, the cervical canal. Basically, the condoms most commonly used in the case of males, right? Even female condoms are also there, bache, and they are known as femidoms, right? They are known as femidoms. So femidoms are nothing but they are the female condoms. Okay, so condom is a barrier method made up of latex or polyurethane sheath. It will not allow that ejaculated semen to pass in the female genital tract, right, bache? So condoms, they even protect from STIs like HIV and all. Okay, HIV and all. And here the another important diagram, it is of IUD, intrauterine device. What is it? Intrauterine device. So this topic is very important. IUDs, intrauterine device, very important topic it is, bache. So here in IUDs, I am going to write down the examples here only. Okay? The speed is fine. Guys, tell me, the speed is fine, yes or no? The speed is fine, yes or no? Tell me in the chat section. You are not allowed to, right, you are not allowed to leave the session. We have to revise the entire biology. Take it as a last marathon, take it as a last session, because from tomorrow we are going to practice the questions. Tomorrow we are going to revise the biology with the help of PYQs. Day after tomorrow, top 1000 questions, and then after that, with our experience, basically all of us are going to give you sure shots, 180 questions, 180 questions. Okay. Okay, so how's the energy, how's the Josh, guys? Good, 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 speed up. See, now you can see how bad your Wazeem sir is, even your Capto, even your HSP sir. I asked for a cup of tea, I think 20-30 minutes before, but they didn't get it. See, go slow. Arre, now we do not have the time to go slow, na. STIs, sexually transmitted infection, they even affect the sex organ. Hai na? So now you should spam in the chat section. Chai, chai, chai means tea, tea, tea. So here let's now come to this topic, that is IUDs, intrauterine devices. So we have the three things here. We have non-medicated IUD. We have copper releasing IUD. And last one, hormonal IUD. Guys, type the examples in the chat section quick. Type the example in the chat section. Type the examples in the chat section, all of you. Just speed up. Just speed up. Type the examples in the chat section. So remember, lips loop, non-medicated IUD. It is non-medicated IUD. Then copper releasing, copper T, copper 7, multi-load 375, right? And what is the third one? Hormonal. Hormone releasing. The example is Progesta Cert. Right? Progesta Cert. Is that clear? Sure, everyone? Is that clear? Now come to your genetics, the most awaited topic. Okay? Genetics. The principle of, oh my bad, principle of inheritance and variation. So I am going to start this chapter. So see, so I hope you all are okay with the speed. Arey wah, give coffee to me. Arey, you are seriously spamming. Okay, now leave it. Now come to this topic. Ah, very good, Kumar, very good. Even LNG 20 is there. Excellent. LNG 20 is there when we talk about the hormone releasing IUDs. Excellent, bacho. Sudarshan, Sashikala, very good. Very good. Now come to the next topic, that is the principle of inheritance and variation. The crosses and all of things, all the things are here. But okay, we are going to revise it in a wonderful way. Don't worry about that. We will cover our genetics with the help of these diagrams only. Even the molecular basis of inheritance, even that transcription, translation and all we are going to cover in this session. So excited kids, excited, and thank you so much for making us 25K subscriber family. But yes, we need more support, right? I know I'm sounding like your parents, है ना? I'm sounding like your parents. Like if you score 80% marks, then parents used to say, no, you should improve more, you should score 85, you should score 90, like this. I know initially we were saying, make us 20K family, make us 25K family. Actually, why do we need your support? Because see, if we will get that subscriber base, so we'll be able to, you know, sustain for a longer time. We will be able to guide them, another NEET aspirant. So that is why we used to tell you this. Okay, that is why we used to tell you this. Okay, so if you really like our content, if you really like our enthusiasm, if you really like our energy now, and you believe that yes, this team is going to help us in NEET 2025, we want this team to help us in NEET 2025, do promote our channel. It is genetics, I'll go little slow. Okay, do promote our channel. I'll give you break, but not after this, later. I'll give you break, don't worry. Okay. Yes. Done. So can we start the genetics part now? What can you interpret from this particular thing? Tell me from this diagram what you people can interpret. Tell me quickly. Tell me quickly. Speed is not enough. What is the problem with the speed? Guys, this is the best I can do. This is the best I can do. Very good. So question used to come from this part. Actually, this is the Mendelian genetics. We are talking about the Mendel. Who's Mendel? Mendel is the father of genetics. Gregor John Mendel. Gregor John Mendel, the father of genetics. But he didn't get the recognition when he worked on this pea plant. No. You know that he worked on pea plant for near about 7 years. Remember? 7 years. And he was the one who for the first time used mathematics in the biology. right, who first time used the mathematics in the biology, right? He didn't get recognition. After his death, that is posthumously, he get the recognition for his work. So 3 scientists, do you know the name of these, and do you know the name of that 3 scientists? Hugo de Vries, Carl Correns, Eric von Schemack, right? These 3 scientists, right? With the basically they were the one who republished his work, right? Right? So these 3 scientists. So he worked on pea plant for near about 7 years. So why did he choose pea plant? Because you know that alternative characters are there. The lifespan is quite less. The number of seed production is too much. So I'm not going to touch that part, but I think you all remember that. So in the case of pea plants, he chose 7 characters. Guys, listen to me very carefully. Many times you people get confused here. 7 characters. Subramaniam, 7 characters. 7 characters, but he chose alternate characters, right? Alternate they were. Alternate. Like let's say height is a character. I'll quote one example here. All of you please listen to me very carefully. Height is a character. That height is having 2 alternate form. Tall, dwarf. Tall, dwarf. So these 2 alternate form, these are the alternate form of the character height, right? So we are going to consider it as trait. What we used to call it? We will call it as trait. What is it? Trait. So height is a character and these 2 alternate forms, they are trait. These 2 alternate forms, they are trait. So gene is going to control the character, right? And the mutated form of gene, that is allele. That is allele is going to, alleles are responsible for these traits. Is that clear? Is that clear? So we consider na gene is a pair of allele. Gene is a pair of allele. This is what you need to keep in your head. So P, 7 characters are there. 7 character means 14 traits, or you can say that 14 alternate characters. Got it? Got it? It's a PYQ. It's a PYQ, right, bache? It's a PYQ. So now you have to focus here, bache. See, seed shape, seed color, flower color, pod shape, pod color, flower position, stem height. These are the characters. So you should know which one is dominant, which one is recessive, which one is dominant, which one is recessive. So once there was a question that how many characters are based on the color. So what do we have? Seed shape, pod shape. This is very easy. Height, flower position. These 2 are very easy. Then seed shape, seed shape, pod shape. Seed color, flower color, and then pod color. Isn't it? Isn't it? Isn't it? These are the 7 characters. These are the 7 characters, right? So in the case of height, you know that tallness, dwarfness, dominant, and here it is the recessive one, right? Recessive one. Done. So flower position here, it is what? Terminal or axial? Which character? Which character is the dominant one? Which character is the recessive one in the flower position? In the flower position, which character is the dominant one? Which character is the recessive one? All of you just tell me very quickly. Guys, please be quick. Please be quick. Guys, be quick. Yes. Flower position, which character is dominant in the case of flower position? Which character is recessive in the case of flower position? You have to tell. Axial position is the excellent. Axial position is the dominant one and terminal is the recessive one. Seed shape, you know that, round, and the constricted here, and the constricted here. This is what you need to remember. Is that clear? So you can see this, bache. Seed color is yellow, seed shape is round, recessive is wrinkled and green. This is what you need to remember. Do not underestimate this question. You will get a question from this particular part. Now, bache, here the test cross. I think many students are having problem in the test cross, right? So, I am going to explain that particular box, test cross, right? So, you want me to explain it? You want me to explain it, the test cross, because in genetics, very important it is, right? So, with the help of these diagram and tables, I will complete your genetics part today. Okay, ma'am, homogeneous means the two alleles are present on same loci, on different loci. But a homogeneous, it should not be homogeneous, it should be homozygous. So, when it is homozygous, same alleles are there, let's say A and A. So, you know that in our case, we have the pair of chromosome. So, one is present on mother wala chromosome, another on papa wala chromosome. So, the loci, the chromosome is going to different in that homologous pair, but the loci is going to be same, no? Same loci on different chromosome. That is what you need to remember, okay? So, now the question is test cross. But a test cross is a type of back cross. Test cross is what? It's a type of back cross. Test cross is what? It's a type of back cross. It's a type of back cross. Actually, in the test cross, what is happening? One F1 individual, simply let me write it in this way, F1 individual, we are going to cross F1 individual with the homozygous recessive parent. We are going to cross it with the homozygous recessive parent. This is what you need to remember, right? It is used, right? This test cross, it is used, remember this, to find out the unknown genotype. The word is genotype here, bache, not the phenotype. The word is genotype here, not the phenotype. Remember, genotype it is. Genotype it is. Are you getting my point? So, here you can see F1 individual, we are going to cross it with homozygous recessive parent. So, it is the key word here, homozygous recessive parent. Homozygous recessive parent, right, bache? So, after that test cross, right, no doubt the genotype is unknown, without any doubt the genotype is unknown, but you can guess it from the phenotype. Now, let's say here I am having a tree. Let's say here I am having a tree. I know that tree is tall, right? I can just look at the phenotype. I can just look at the physical appearance. I can comment on that, isn't it? So, tree is tall, tree is tall, tree is tall. So, in the case of tall, two scenarios are possible, right? Either it will be homozygous tall or it will be heterozygous tall. Homozygous tall, heterozygous tall, homozygous tall, heterozygous tall. So, how can I confirm this? How can I confirm this? I can confirm it with the help of test cross. Right, by just looking at the phenotype, I can judge that this flower is the yellow colored flower, this flower is the red colored flower. But I cannot tell whether it is homozygous dominant or heterozygous dominant. Homozygous dominant and heterozygous dominant, I cannot tell you that. Okay, bache? Okay. So, to figure out the unknown genotype, we need to go for the test cross. Right. So, F1 individual we are going to take, let's say it is TT, homozygous dominant. Another is homozygous recessive parent. So, the ratio here is going to be all tall, all tall. So, if in the F1 all tall, they are indicating unknown genotype as homozygous dominant. And if it is TT and TT, the ratio is going to be 1:1. That is indicating that unknown genotype is what? It is the heterozygous dominant. So, it is the case of monohybrid cross. This is what you people need to remember, right? So, if you have any doubt from this particular part, do let me know in the chat section, guys. Do let me know in the chat section if you guys are having any doubt from this particular part. You can just say all the flowers are violet and violet color is dominant trait. So, if dominant trait is there in the next generation, so it is showing that unknown genotype is the homozygous dominant. Is that clear? Is that clear? Right, it is the homozygous dominant. And if it is heterozygous in monohybrid, the ratio is going to be 1:1. 50% tall, 50% off, like 50% violet, 50% white. Is that clear? Is that clear? Very good. If it is a dihybrid cross and it is a test cross, it is going to be 1:1:1:1:1. And here, this is what we are talking. is monohybrid, na? Just a minute, bache. Yes, this is what we are discussing here. Okay, okay. So if this is the genotype and this is the genotype, the ratio is going to be 1:1, 1:1. Okay. So next here is, bache, this is the example of, you know that. Here it is the example of incomplete dominance. Can you quote 2 examples of incomplete dominance? All of you, can you quote 2 examples of incomplete dominance? Can you quote 2 examples of incomplete dominance here? But incomplete dominance means dominance is not completed here. Here you can see the 2 examples are taken. One, the flower is red colored. Another, the flower is white colored. Right? So it is basically the example of intragenic inheritance. Right? It is the example of intragenic inheritance. Within the gene, inheritance is there. Like, you can also call it as allelic inheritance. You can also call it as allelic inheritance. Done? Done. So one flower is red colored. Okay, RR. Another flower is white colored, smaller. So now when we cross them, this is what we are going to get in F1, individual. This is what we are going to get in F1. But here instead of red, it is showing pink color. So it is neither red nor white. Red is not there. Red is not able to express itself completely. So obviously the dominance is incomplete here. So pink is the, right, we are getting the pink flower. Now when you will again do the selfing, so obviously you will get the progeny having 1:2:1 ratio. 1:2:1 ratio for the phenotype as well, for the genotype as well. So here it is indicating the red, here it is indicating the pink, here it is indicating the white. Right? So whenever here the genotype is RR, red color. Whenever the genotype is RR, pink, small r, white it is. Okay? So you have to remember the example. So this is the example of snapdragon antirrhinum. Right? Even the 4 o'clock plant, Mirabilis jalape is also the example. So you guys can get a question from the examples. You people can get a question from the example. So my next favorite question is blood group. Right? My next favorite question is blood group. In the blood group, what do we study? You know, na, blood group, RBC. RBC is having the antigen. That antigen will decide the blood group. Right? That antigen will decide the blood group of that person, and in the plasma, antibody against another blood group will be there. This is what we know. So now when you talk about the blood group, it is gene I is going to control this. Gene I is going to control this. Now in the blood group, we see different examples like multiple allelism we can see. Right? In the case of blood group, what do we see? We see the multiple allelism. What do we see? We see the multiple allelism. Many alleles are there. Right? Basically 3 alleles are there for the blood group. Right? So we have IA, we have IB, we have this I. This I also for the O blood group. For the O blood group. Right, bache? So 3 alleles are there. So what you have to remember, that these 3 alleles are present in the population. If you will see the population, these 3 alleles are there in population. But in single individual, Sheikh bache, Kunal bache, but in single individual only 2 alleles are there. Like let's say there is a question that how many alleles of blood group are present in a population. When it is the population, 3 alleles are there. But if they are asking how many alleles of blood group are present in a single individual, 2 alleles are going to be there. How many alleles are there? 2 alleles are going to be there. Right, bache? Right, bache? So you know that one example is in the blood group, one is the multiple allelism. Secondly, even we see codominance in the blood group. Codominance in the blood group. Even in the case of blood group, dominant recessive relationship is also there. Dominant recessive relationship is also there. So this is what you need to mark here from this particular table. Right? 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 So in the case of codominance and incomplete dominance, ratio is same, 1:2:1 for the phenotype also, for the genotype also. So if in the paper the question is, that in which inheritance the phenotypic and genotypic ratio is same. So there are 2 answers, incomplete dominance, codominance. Incomplete dominance, codominance. And what is the ratio? What is the ratio, bache? What is the ratio? Guys, be quick. What is the ratio? What is the ratio? No, Bombay blood group and H type not important. H is for the rhesus antigen that I have covered in human physiology session. 1:2:1. 1:2:1. Now, the next here is, it is the example of linkage. This particular flow chart is, this particular cross is from the linkage. But you know that. Although chromosomal theory of linkage, it was given by T.H. Morgan. Do you remember that? T.H. Morgan was the one who gave the chromosomal theory of linkage. Remember? He was the one who gave the chromosomal theory of linkage, T.H. Morgan. Right? But he is not the one who reported the linkage for the first time. No, it is not like that. Actually, Drosophila, Morgan was the first scientist who tried to apply the laws of inheritance on the animals. Mendel's laws were there on the plants. Morgan tried to put that laws on the animals. He selected the Drosophila for that. Story is very interesting, huh? He selected the Drosophila for that, fruit fly for that, right? He selected what? Drosophila for that. Now, when he applied all that laws on the Drosophila, he was expecting the different result, but he get the different result. Why? Why is it so? Why? Because of linkage. In the case of Drosophila, especially in the case of male Drosophila, 100% linkage is there. Example is very important. Example is very important. 100% linkage is there in the case of male Drosophila. He tried to apply the concepts of Mendel on the Drosophila. This is the first thing that I am telling you. Now, what is the second point that I need to tell you? What is the second point here in linkage? See, in the case of linkage, actually what is happening? See, law of independent assortment is saying at the time of gamete formation, right, at the time of gamete formation, the genes, the alleles, right, they will segregate independently, right, they will segregate independently. But here in the case of linkage, it is just opposite to the independent assortment. In the linkage, we are saying the genes which are present on same chromosome and which are close to each other, the genes which are present on same chromosome and those which are close to each other, they will inherit together as a unit in the next generation. They will inherit together in the next generation, right? They will not get separated if they are present on same chromosome, plus if they have less distance in between. So now here in this cross, we have two examples, cross A, cross B. This is the sign for female, this is for the male, right, bache? Here we have taken two examples. One is the parental cross. Just look at this yellow and white color. Look at this wild type. If you will focus on this yellow and white, they are close to each other, yes or no? They are close to each other. They are close to each other, guys. What about your energy? What about, we started the session 2. I think 2 hours ago we have started the session, yaar. What is happening? We are about to finish class 12th. You know that after that the chapters are very easy. Too many diagrams are not there in the next chapters. So we can complete it. We can complete it very quickly. So be focused, guys. Be focused. Right, ma'am, they give some in PYQs like they ask distance between. Guys, Rexenite, attend tomorrow's session. Everything will be covered. Don't worry about that. I have planned accordingly. Right, we have shared, me and Wasim sir today, we have shared one video now that how can you people boost your marks from 300 to 600. In that video, we have shared our plan. You guys can check our plan. You will get to know what are we going to do for physics, for chemistry, for biology. So we have a full proof plan for the revision. So from tomorrow, right, you will get amazing session. Even this session is also amazing, huh? So tomorrow, you know that I am going to take the biology question revision. The entire syllabus, the entire 11th and 12th will be covered tomorrow with the help of PYQs. Chemistry, for chemistry, inorganic revision is there that HSP sir and Wasim sir is going to take. Right? Right? For the physics formula revision is there. For the physics formula revision is there. So there is no need to get worried. We will revise everything and in the questions and then top 1000 questions. Top 1000 questions. So please focus here. I'll teach you the gene maps there. Okay? But I want your full support. See, today I'm going to take class 12 diagrams. I will take class 11 diagrams only if you people will stay till the end. Only if you will show that energy to me that yes ma'am, we are ready for the revision. Okay? Okay? And today by the end of my session, you have to make the subscriber number above 26K, isn't it? Okay, now focus here. Focus here. So cross A, cross B. Just look at the distance. If on a single chromosome, two genes are present, and if they are very close to each other, definitely they will go together. In the next generation, they will go together. Now, if you will look at this cross B, here white miniature and wild type is considered. So here again, the distance between the two genes, it is more than that, right? If you compare cross A and cross B, here you will see the genes are having a distance, but very less distance in between these two. But here the distance is more. So obviously there are more chances that when, right, during the gamete formation, there are more chances that these two genes will get separated, and here we have the less chances. So when you look at the gametes, parental type is 98.7%, recombinant type is 1.3% only. Recombinant type is 1.3% only, parental type is 98.17% only. So it is showing the distance. So linkage and distance, they are inversely proportional to each other. Linkage and distance, it is inversely proportional to each other, right? More distance, less linkage, less distance, more linkage. Is that clear? Is that clear? Now here the distance between two genes, it is more. So here you guys can see parental types, basically recombinant types are more. Here, because distance between genes is less, recombinant type is 1.3% only. Here, the distance between two genes is more, the recombinant type is 37.2%. This is what you need to remember. 37.2% it is. Right? Right? So, parental type, as I said, 62.8%, 37.2%. That's all. That's all. So, it is clearly explaining the linkage. Right? So, here we have taken the example of two dihybrid crosses conducted by the Morgan. So, A is showing crossing between G, Y and W, B is showing the crossing between W and M. So, dominant wild type alleles are represented with plus. So, plus is showing wild type, naturally occurring, dominant. Okay? Okay? So, here you can see the strength of linkage in between Y and W is more than W and M. So, description is important for the diagrams. Now, here we have the sex determination, right? So, you know that in the case of humans, even in the case of Drosophila, humans and Drosophila, it is going to be, yes, bache, type it in the chat section, it is going to be XY, XX. XY is the male here, XX is the female here, XX is the female here, XX is the female here. Now, when you look at this, see, humans and in Drosophila, female is having XX chromosome, female is homogametic, male is XY chromosome, heterogametic. Now, the next example is of birds. B example is of, yes, this is of Drosophila. This example is of birds. So, in the case of birds, you can see females are ZW, right? Females are heterogametic. So, examples are important, bache. Males are homogametic here. Males are homogametic. This is what you need to remember. Males are homogametic here. Clear, bache? Now, the next part, it is very important, honeybee. Right? In the honeybee, you know that in the honeybee, the number of chromosomes are also very important. Female is having 32 chromosome, male is having 16. Male is what? Male is drawn. It has formed parthenogenetically. Remember, bache, parthenogenetically male has formed. Remember, the egg will develop into an adult without fertilization. The egg will develop into an adult without fertilization. So, in the case of females after meiosis during gamete formation, 16 and 16, right? But here, mitosis will occur in the case of males. So, both the points are important. Question will come from this particular part in this year NEET examination. So, yes, it is haplodiplontic. Right? No, go for this word. Just mention that only. So, female is having 32 chromosome, male is having the 16 chromosome. In the case of female, gamete will form by a meiosis, but in the case of males, already 16 chromosomes are there. So, gamete will form by a mitosis. Gamete will form by a mitosis. This is what you need to remember. Okay? Okay, yeah, in the case of insects, it is XO, XX. XO, male. In the case of insects, and XX, females. Done? Okay, the next one is the pedigree analysis. The next one is the pedigree haplodiploidy. Haplontic is not there, haplodiploidy it is. Okay, so right now what is the next part here? Next part is the pedigree analysis. Bache, in one video the top 5 concepts of botany, I have explained the conditions for that. So for pedigree analysis, the very first thing that you need to remember is these symbols, right? For the male it is square, for the female it is circle, right? When we are showing the sign of meeting, there will be a line in between. If 2 lines are there, it is consanguineous meeting, that is mating in between relatives, in between cousins, right? This is showing the next generation. And here when it is dark, now it is showing the affected individual. This is what you need to remember. So let me explain it very quickly. Whenever any trait is dominant, any trait is recessive, the point that you majorly need to focus is, in the case of dominant one, generation will not be skipped, right? Generation will not be skipped. Are you getting it? Generation will not be skipped. But in recessive, generation will be skipped. What is the meaning of this? The meaning is, in the case of recessive, if children are having a particular trait, disorder, it is not mandatory that parents are going to have that, right? Even here in the recessive, because generation will get skipped, so even if children are affected, parents will be normal. It is not mandatory that parents will also be affected. In the dominant trait, what is going to happen? If children are having the trait, if child is having the trait, parents will definitely have that trait. One of the 2 parents will be affected for sure. Okay, generation will not be skipped. This is the key point. And how to differentiate autosome dominant and X-linked dominant? So, in the case of autosomal disorder, male and female are having equal frequency. But if it is the X-linked, right? So, if it is X-linked recessive, males are more likely affected. If it is X-linked dominant, then again, both the sex can get affected equally. That is what you need to remember. Okay, so what you have to do, you guys can check my top 5 important concepts of botany wala video. I have explained the conditions in detail there. Okay kids, now this is the pedigree chart that you need to remember. Now just look at it. See, parents are affected. If you look at the next generation, you can see the trait. Now here parents are normal, their children are normal. Here one of the 2 parents is affected, next generation is also showing the trait. So generation is not skipped here, it is dominant. It is dominant. Generation is not skipped here, it is dominant. Now when you look at it, parents are normal, but still next generation is showing the trait. Parents are normal, but still next generation is showing the trait. Now here, again parents are normal, next generation is showing the trait. Generations are skipped, so it is recessive. How to figure out whether it is autosomal dominant or X-linked dominant? Male and female are equally affected. Autosomal. Right, again autosomal recessive. So examples you need to mark bache. So in autosomal dominant, myotonic dystrophy is the example. Autosomal recessive, sickle cell anemia is the example. So question can come from the example part as well. Question can definitely come from this particular part. They can give you 4 options. They can give you other options. They can ask you out of that which one is the autosomal dominant, which one is the autosomal recessive. So you really need to mark it. So if you will read the NCERT na, the theory part, you will not find myotonic dystrophy, but here in the description it is given. Here in the description it is given. Right, so this is how you need to mark. Next is bache your favorite sickle cell anemia. So remember in sickle cell anemia what is happening? What is happening in the sickle cell anemia? Can you tell me? See, this is the normal hemoglobin. Normal hemoglobin, valine, histidine, leucine, threonine, proline, glutamin. Glutamin is there. This is the normal hemoglobin, the respiratory pigment, the one which is present in our RBC, the one having 4 protein chain and 1 heme part is there, right? And 1 heme part is there, having the central iron. So tell me what is the difference? Guys, please answer it quickly in the chat section. Quickly in the chat section, answer it. Quickly in the chat section, answer it. Quick. quick. Exactly. So kids, whenever we discuss sickle cell anemia, right, whenever we discuss sickle cell anemia, RBC will become sickle shaped, right? It is sickle cell anemia, so RBC will become sickle shaped. Now in the sickle cell anemia, what is happening, right? First of all, the points that you need to remember, please mention that it is autosomal recessive. It is autosomal recessive disorder, plus sickle cell anemia is also showing the pleiotropy, that is multiple phenotypic effect of a gene. What is pleiotropy? It is the multiple phenotypic effects of a gene. A gene is not just controlling one character, a gene is controlling more than one character. Okay, bache? And even in sickle cell anemia, we will see the point mutation. What will we see? We will see the point mutation. Right. So when you talk about the hemoglobin, this topic is important. That's why I'm emphasizing it. So when you talk about the hemoglobin, you know that 4 chains are there. 2 alpha chains are there, 2 beta chains are there. What do we have there? 2 alpha chains, 2 beta chains. 2 alpha chains, 2 beta chains. So now when you talk about the beta chains, at 6th position, right? What is going to happen at 6th position, right? There will be a change. The trick here is good villain. Good villain. This is the trick. So ultimately what is going to happen? At 6th position, glutamine will become valine. Glutamine will become valine. Is it glutamine or glutamic acid? Tell me. What is it? Is it glutamine or glutamic acid? Tell me. Right, what is going to happen in the sickle cell anemia? It is glutamine or glutamic acid. Do let me know in the chat section. What is it? Is it glutamine or glutamic acid? Is it glutamine or glutamic acid? Exactly, you are right, bache. Here it is going to be, yes, everyone in the chat section. So at 6th position, what is going to happen? Good na, glutamic acid it is. Glutamic acid will be converted to valine. So GAG, GAG will become GUG, GUG. GAG will become GUG. GAG will become GUG, GAG, glutamic acid, GUG, valine. So at the place of A, U will come. So there is a change in the position of only one base, one nitrogenous base. So this is the point mutation, example of point mutation, right? So here at the place of glutamic acid, the valine will come, right? So many times students, they make the mistake here, bache, they make the mistake here, they mention glutamine. It is not glutamine, it is glutamic acid. It is glutamic acid. So when it is glutamic acid, it is GLU. It is GLU. And if it is glutamine, it is GLN. Always remember this. It is GLN. Right, Avantika, you can check my top 5 concepts wala video. Now next thing, bache, for sure question will come from disorders. For sure question will come from disorders. So here you can see, if you look at it, you can see what can we see? The extra chromosome. Isn't it? One extra chromosome, right? This is the karyotype basically. So here we know that there is the example of trisomy 21. Trisomy 21 means 21 chromosome is having one extra copy. So total number of chromosome will be 47, and here we are talking about the Down syndrome. We are talking about the Down syndrome. So chromosome number 21 will have one extra copy. Chromosome number 21 will have one extra copy. Chromosome number 21 will have one extra copy. Are you getting my point? Down's syndrome. Trisomy 21 it is. So whenever it is trisomy, trisomy means 2n plus 1. One extra. It is the example of aneuploidy. It is the example of aneuploidy. Right? Very good, bache. Aneuploidy it is. Done, bache. So you have to remember the symptoms as well. So whenever it is the Down syndrome, flat back of the head will be there. Broad flat face will be there. There will be many loops on the fingertips. Right? Palm crease will be there. Big and wrinkled tongue. Congenital. Congenital means by birth. Heart diseases will be there, but by birth. Is that clear? Heart diseases will be there, but by birth. Any doubt? Any doubt? So you have to remember this. You have to remember this. Now here we are having the example of the Klinefelter syndrome. Bache. So it is also Klinefelter and Turner's syndrome. When it is Klinefelter, it is again 2n plus 1. Right? Klinefelter's syndrome. So again, bache, it is also 2n plus 1. It is also 2n plus 1. Right? So, but here it is the addition of extra X chromosome is there. Triple XY it is. Okay, so it is again the trisomy of X chromosome. And here what do we have? Here we have the monosomy. Monosomy of X chromosome. And what is the meaning of? What is the meaning of monosomy here? Monosomy means 2n minus 1. One chromosome is less. So the total number of chromosome is going to be 45 here. Total number of chromosome is going to be 45 here. So Klinefelter is the example of trisomy of X. Turner syndrome is the example of monosomy. What is monosomy? 2n minus 1. One chromosome is less. Again the example of aneuploidy. Right? So short stature and the underdeveloped feminine character, but here one extra X chromosome is there. So in the case of males, female characters will be there. Here males can even have gynecomastia. Males can even have gynecomastia. Are you getting my point? Males can even have gynecomastia. Okay, gynecomastia. Right? Mammary glands are developed. Right? So now come to the molecular basis of inheritance. So this is the DNA. What? Right? So it is a polynucleotide chain. What is the meaning of polynucleotide chain? Many nucleotides are connected together. Right? Many nucleotides are connected together. So this is what we need to learn next. So up to this part all clear, guys? Up to this part all clear? Krishna, first of all, whatever sessions I have planned, please enjoy that. Please revise the things from that session. Then I will put, another short videos. Don't worry. Done? Qualitative and quantitative. Quantitative obviously related to quantity. Quality with the quality. In sickle cell anemia, your RBC shape is affected. So it is the qualitative disorder. In thalassemia is the quantitative. Anything else? Break. Really? You want break? I don't think that there is a need for break. But karyotype I told you already, na? Guys, do you need break? If it is a yes, type break in the chat section. But I don't think that you people need a break, yaar. Huh? Turner and Klinefelter, they are sex-linked disorders. We also use the word allosomes for that. But Wazeem sir is not going to teach you the biology, na Jaya Prakash? Focus here. Anything else? No break, na? I don't think that you need a break. See, if I'll start class 11th diagrams, na, then I'll give you the break at that time. What say? Tea break is required. Okay, let's finish molecular basis of inheritance, and for the next session, then we'll keep, for the next chapter, before starting that chapter, I'll keep a break. What say? Arey, let's finish it properly, na? You are revising your entire biology. I think it is important. It is important. Isn't it? No break is required. 10 minutes break. Oh my God, 10 minutes. In 10 minutes, we can complete this chapter. Okay, now come to this. So here we are talking about the polynucleotide chain. Poly means many. Nucleotide is the word. So kids, nitrogenous base plus sugar. One is N, another is S. So it is forming nucleoside, right? And when it is nucleotide, from T you have to remember 3. So it's nitrogenous base plus sugar plus phosphate. So it is going to be nucleotide. So it is polynucleotide chain. So if it is a polynucleotide chain, just have a look, bache. 5' end is having free phosphate. Always remember. This is something that you need to revise, right? This is something. that you need to revise. And when you talk about the 3' end, it is the hydroxyl OH group. It is the hydroxyl OH group. So it is the phosphate here, it is the OH there, right? So nucleotide, it is 3 things are there: nitrogenous base, sugar plus phosphate. Nitrogenous base, sugar plus phosphate. So here you can see, right, this part, nitrogenous base, the sugar here, and here you have the phosphate, right bache? So sugar and phosphate, they are connected by a 3-5 phosphodiester bond basically. 3-5 phospho, sorry, 3-5, my bad. Okay, as of now just mark it, right? So sugar and base, it is connected by N-glycosidic bond, and here you are having phosphoester, but it is a polynucleotide chain. Then whenever it is the polynucleotide chain, then it is phosphodiester. See, if it is a single nucleotide, phosphoester bond. If it is a single nucleotide, phosphoester bond. But if it is a polynucleotide chain, phosphodiester. Are you getting my point? Like, let's say I am a single nucleotide, I am having the 3 things, right? I am having the 3 things, 1, 2, 3, right? Then phosphoester bond is there, phosphoester bond is there. But if there will be 2 nucleotides or 3 nucleotides, or if there is a chain, then the bond is phosphodiester. Bond is phosphodiester. Are you getting it? Bond is phosphodiester. So it is a chain. So you can say that sugar is attached to the phosphate here, sugar is attached to the phosphate here. So here also 3' third carbon, and here the phosphate of 5th carbon, here also the 5th carbon and the phosphate here, right? So it is phosphodiester bond, phosphodiester bond. Clear? Clear? The next diagram. So here you can see, so you know that adenine will form 2 hydrogen bond with thymine, cytosine will form 3 hydrogen bond with guanine. Do you remember this? And bache, here we have one more trick: purines, pyrimidines. What do we have? We have purines, we have pyrimidines. So the trick here is PUGA. The trick here is PUGA. What is the trick here? The trick here is PUGA. What is the meaning of this PUGA? Purines. G stands for guanine. A stands for adenine. G stands for guanine. A stands for adenine. Right? Right? And if you look at it, guys, if you look at it, if you look at the spellings, it is the 9 here, it is the 9 here. So basically 9, right? So basically purines are 9 membered. That is how you have to remember it. Purines are 9 membered, right? Just look at the spelling. First trick is PUGA, purines, guanine and adenine. If you look at the spelling, 9 and 9. So purines are 9 membered ring. And when you people talk about the pyrimidine, why it is, right? So the trick, first trick is cut. First trick is cut. What is the first trick here? It is cut. C stands for cytosine, U stands for uracil, and T stands for, guys, type it in the chat section, all of you. Type it in the chat section, all of you. It is cut. Cytosine, uracil, thymine. Cytosine, uracil, thymine. Cytosine, uracil, thymine. So what is the trick that we have? The trick is the PUGA and cut. The trick is PUGA and cut, right? PUGA and cut. So it is the purine, it is the guanine, it is the adenine. When it is cut, so it is going to be cytosine, it is going to be uracil, and as I said, it is going to be thymine. So PUGA is the trick. Purines, look at the spellings here, 9 and 9. So it's a 9 membered ring. It's a 9 membered ring. Is that clear? So pyrimidines, these are the pyrimidines. So pyrimidines are what? They are 6 membered. 6 membered. So out of that, in DNA bache, you will be having C and T, and in the RNA you will be having C and U. Important it is. It is important, right? It is important. Is that clear? Is that clear? right? So this is the favorite reaction of the examiner. Actually, it is the central dogma of information, that how the information flows. So DNA to DNA is the replication, DNA to mRNA is the transcription, mRNA to protein is the translation. It looks simple, but many times question used to come from this part. It was there in NEET 2022, so I am not expecting it to be there in NEET 2023. Okay, I am not expecting it to be there in NEET 2023. But you have to remember one thing. We have one more phenomena that is known as reverse transcription, that we even see in the case of retroviruses. So reverse transcription is possible with the help of reverse transcriptase. It is possible with the help of reverse transcriptase, right? So reverse transcription is also known as bache taminism. Taminism. What is it? Taminism. 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 So it is central dogma reverse. It is central dogma reverse. It is central dogma reverse, possible with the help of reverse transcriptase, also known as taminism. So here the RNA is going to form the complementary DNA. RNA is going to form the complementary DNA. Complementary DNA. Clear, bache? Now, and yes, can I ask you one question just for, okay, as a break, can I ask you one question? As a break, can I ask you one question? Yes, everyone, can I ask you one question as a break? Huh? Tell me quickly. One question as a break. Huh? So where do the transcription in the case of prokaryotes will take place? Where do the transcription in the case of prokaryotes will take place? Let's take a break of 2 minutes. What say? Of 2 minutes. cDNA means complementary DNA. Okay, tell me. Where do the transcription in the case of prokaryotes occur? Answer it, yaar. And guys, if you are new, you have to subscribe our channel and do share the channel link with others also. Let's make it 26K family today only. Let's make it. Tell me, cytoplasm. Okay, so what about the transcription in the case of eukaryotes? Where will it take place? Where will it take place? Tell me, in the case of eukaryotes. In the case of eukaryotes. In the case of eukaryotes, where will be the transcription take place? Guys, I'm going to punch you. This is not right. This is bad. So this is what you need to remember. Okay. Transcription. Cytoplasm. When it is a prokaryote. Transcription. Nucleus. When it is a eukaryote. When it is a eukaryote. Okay, translation will occur in cytoplasm only. So break time is over. My students are making the mistake. Okay, so now next is for the experiments, right? So you know that one is of Griffith's experiment. Remember bache, Griffith's experiment, also known as transforming principle, and the another experiment is of this one, and this experiment is Hershey and Chase experiment. Hershey and Chase experiment, right? Just look at the description. Hershey and Chase experiment, right? Hershey and Chase experiment. So it has provided the proof that DNA, it is the DNA which is the genetic material. It has provided the proof that it is the DNA which is the genetic material. So just look at this diagram. So they have used the bacteriophage. What is a bacteriophage? Bacteriophage is a double-stranded DNA virus. What is it? It's a double-stranded DNA virus. What is a bacteriophage? It is a double-stranded DNA virus. So it is a virus which is going to infect the bacteria. It is the virus which is going to infect the bacteria. This is the first point that you need to remember. Secondly, in this virus, you people are too smart enough now, so you know it very well. In this virus, here we have the protein coat, and within it we have the nucleic material, the DNA. Right, within it we have the nucleic material, that is DNA, genetic material, that is DNA, and here we are having the protein coat. So in this experiment, Hershey and Chase, so what they did, bache, they took two radioactive isotope, right? So it is P32S35, P32S35. So it's P2. This is what you need to remember, P2. So P32S35. So you should know that which radioisotopes has been used here in this experiment. So you know that in this experiment, when they try to infect the bacteria, that is E. coli, with the bacteriophage having radioactive protein coat, having S35 isotope, the radioactivity will not enter in that radioactive isotope will not enter in the E. coli, right? So no radioactivity will be there in the cell, right bache? Radioactivity will be there in the supernatant. So question like that can come in the NEET examination. They can ask you that in the case of Hershey and Chase experiment, when they used S35 isotope, S35 radioactive isotope, so where that radioactivity was there? It was there in the supernatant. And when they will use P32 radioactive isotope, it will be there in the cell, because it is the phosphorus which is the constituent of DNA. So obviously it will pass to the next generation. But when you talk about the sulfur, sulfur is the part of protein coat. Sulfur is making the amino acid. Remember cysteine, methionine, sulfur containing amino acid, that is why. Now the next question, bache, here the semi-conservative model of DNA replication is explained. You know that initially with the help of Messelson and Stahel, they have given this experiment. So this is important. Description is important, kids. Description is important. So Messelson and Stahel, they explained semi-conservative model of DNA replication. They were the one who explained the semi-conservative model of DNA replication. So firstly, they grew the E. coli in 15NH4Cl. That is your ammonium chloride, right? So this is the heavy isotope of nitrogen. 15N is what? It is the heavy isotope of nitrogen. What is it, bache? It is the heavy isotope of nitrogen. Are you getting my point? Are you getting my point? What is it? Heavy isotope of nitrogen. Now in the E. coli, after 20 minutes, you will see the next generation. Generation time is 20 minutes. So you will see that in the first generation, after this, like first of all, E. coli is naturally having 14 N isotope in its DNA, but we are going to grow it in the medium having heavy isotope of nitrogen. So this is what you need to remember. It is 15N. It is not radioactive. It is heavy. It is heavy. It is heavy. Then they will grow it in a culture medium. After 20 minutes, they will check the next generation. So in next generation, they will do the cesium chloride density gradient method will be used, right? DNA will be separated by centrifugation. So cesium chloride density gradient method will be used, and in the first time, they will see the heavy bands. Then in this case, they will find the band somewhere here, not at this place, not at this particular place, not at this particular place. And then we have after 40 minutes, after next 20 minutes, or in totality 40 minutes, when they will check the generation 2, so they will find bands like this, light and the heavy also, semi-conservative, right? Semi-conservative. Okay? Okay? So the next, this diagram is important. Very important it is the replication fork. What is it, bache? It is the replication fork. What is it, bache? Replication fork. So here the template strand is having polarity 3' to 5', guys. The template strand having polarity 3' to 5'. Opposite to it, template strand having polarity 3' to 5', opposite to it, leading strand will form. This is what you need to remember. Opposite to it, leading strand will form. Right? This is what you people need to remember. Opposite to it, continuous strand, the leading strand will form. But when the template strand is having polarity, right, when the template strand is having polarity 5 prime to 3 prime, in that case the lagging strand will form. It is a very important question, right? So opposite to it, what will we get? We will be having the lagging strand. And if you will look at it, can we say that this leading strand is moving towards the replication fork? Can we say that leading strand is moving towards the replication fork? And when you look at this diagram, can we not say that lagging strand, the discontinuous strand, is forming away from replication form? It is away from replication form. It is not going towards the replication fork, it is going away from replication fork. Can we say so? Can we say so? Yes or no? Guys, be quick. Can we say so? Yes or no? Of course we can. Right? It will form first, then this, then this. Again and again RNA primer will be required here. Right? In the case of leading strand, only one RNA primer will be used. But here in the case of lagging strand, we will be having many RNA primers, and these are the Okazaki fragments here. These are the Okazaki fragments here. Is that clear? Is that clear? Now look at this next part. This is the transcription unit basically. Transcription unit. So in transcription unit, we will be having a promoter, the terminator, and in between structural gene will be there. Promoter, terminator, in between structural gene will be there. Promoter, terminator, the structural gene will be there. So it is the site from where the transcription will start. It is the site from where the transcription will start. Is that clear? Is that clear? So guys, here also I'll specify one thing. Right, here also I'll specify one thing, and trust me, that is important too. Kindly focus. Right, kindly focus here. See, one strand having polarity 3 prime to 5 prime, another strand is having polarity 5 prime to 3 prime. Right, but if you will focus on the arrows, right, arrow is always like this, 5 prime to 3 prime direction. Why? Why is it so? Why do we point it like this only? Because bache, synthesis is always in 5 prime to 3 prime direction. Synthesis, it is always in 5 prime to 3 prime direction. So when you look at this part here, you are having the promoter, here you are having the terminator, in between you are having the structural gene, right? So the template strand having polarity 3 prime to 5 prime, but the direction of arrow will be like that only. Direction of arrow will be like that only. So the template strand having polarity 3 prime to 5 prime, this strand is known as, sorry, this strand of, this strand is the template strand. This strand is the non-coding strand. This strand is the antisense strand. This is what you need to remember. Opposite to it, the DNA having 5 prime to 3 prime polarity. This strand is the coding strand. This strand is the non-template strand. That is what you need to remember here. Right? Right? This is the first point that you should mark. This is the first point that you should mark. And what is the another point here, bache? See, let's say this is a point. It's a start point. What is it? It's a start point. What is it? It's a start point. It is a start point. So now, bache, if you will move towards this direction, you will use the word upstream. If you will move towards this direction, you will use the word downstream. Let's say there is one start point. If you are moving to this direction, upstream. If you are moving to this direction, downstream it is. Downstream it is. Now here, when you look at it, this transcription unit, right, bache? If we are taking the reference of coding strand, if then they are, if you are taking the reference of coding strand and then they are asking that promoter, where is promoter present? If they are taking the reference of coding strand and then they are asking where is the promoter present, then you will say towards upstream 5' end, right? Obviously upstream it is 5' end. At 5' end promoter is there. when you are taking the reference of coding strand. In NCERT, it is clearly mentioned that if you take the reference of coding strand, because now we have one strand having polarity 3' to 5'. We are giving importance to this strand. We are using it for the synthesis of mRNA. Now the opposite strand, which is also known as coding strand, it started crying. It started crying that you are only giving preference to this strand only, you are not talking about myself. So in the NCERT, they have clearly mentioned that if you take the reference of coding strand, if you take coding strand to describe where promoter is present, where terminator is present, then what we you have to say that at 5' end of coding strand promoter is there, at 3' end of coding strand terminator is there. If they are asking in reference of template strand, at 3' end of template strand promoter is there, at 5' end of template strand terminator is there. This is what we need to remember. Clear? Clear? So these are few questions that can be asked in the NEET paper. So this template strand is used for the synthesis of mRNA. Clear it is? Clear it is? Yes. So this is the transcription start side. This side will always be the upstream. This side will always be the downstream. So any doubt, kids? Any doubt, kids? Yes. Do you have any doubt here? Now come to the transcription of the eukaryotes. In the case of eukaryotes, you can see, sorry, in the case of prokaryotes, just look at the transcription. Okay, look at the transcription. So which enzyme is used? RNA polymerase. So in the NEET 2020, there was one question that during transcription, which enzyme is used to open up the DNA? What should be the answer, guys? What should be the answer? What should be the answer? But UTRs are nothing, they are the untranslated region. In the mRNA, you talk about the UTRs. Tell me quickly, if there was a question in NEET 2020 that in the case of transcription, which enzyme is used to open up the DNA? Yeah, for the unbinding of the DNA. Quick guys, I want to see the answer in the chat section. Their Josh is now low, hai na? Tell me quickly, everyone, just tell me quickly. See, many of you are giving the incorrect answer. Many of you are giving the incorrect answer. It was a question in NEET 2020, right? When you are talking about the transcription, which enzyme is going to open up the DNA helix? It is the RNA polymerase. When you talk about the DNA replication, at that time it is helicase. At that time it is DNA helicase. But here you are talking about transcription. In the case of transcription, the word was transcription there. The word was transcription there. So in the case of transcription, it was RNA polymerase. So you can see here for the initiation, sigma factor is required. Sigma factor is required, right? Sigma means S for start, but the enzyme is RNA polymerase. So this RNA polymerase will cause the unbinding of DNA when it comes to the transcription. But if it is the DNA replication, then it is going to be the helicase. It is going to be the helicase, the unbindase it is. Got it? Got it, everyone? Sure? Sure. And one more thing is there. This is the sigma factor which helps the RNA polymerase to bind to the start point. Right, bache? And then whenever the transcription will start, sigma factor will say bye-bye. It will say bye-bye. Now see here, further elongation is going on, and for the termination, rho. So R, rho, stop it is. Stop it is done, bache. Then you can see the transcription of the eukaryotes. Eukaryote transcription will take place in nucleus. It is going to be bit different. So here in transcription, 3 enzymes are going to be there in eukaryotes. RNA polymerase 1, RNA polymerase 1, RNA polymerase 2, RNA polymerase 3. So it is the RNA polymerase 2 which will form mRNA, isn't it? Which will form mRNA. 1 is going to form ribosomal RNA. 3 is going to form tRNA. Exceptions are there that you need to check. And here in the case of eukaryotes, you will not talk about no sigma factor. and no rho factor is there. That is what you need to remember. No sigma factor, no rho factor is there. No sigma factor, no rho factor is there. This is what you need to remember. Then comes the RNA processing. RNA processing will be there in the eukaryotes. In the RNA processing, the 2 points are there. One is the splicing and another is the capping and tailing. These are the 3 steps when you talk about the RNA processing in the case of eukaryotes. One is the splicing, another is the capping and tailing. What is the meaning of capping and tailing? To add the cap. Why? Because we want that RNA to get protected from the nucleases. We have to send the RNA to the nucleus. But in the case of eukaryotes, that is the story. Here we will get our mRNA. We have to send this mRNA to the cytoplasm. Now in the cytoplasm, there are many nucleases that can destroy it. So we are going to add a cap, we are going to add a tail. So cap will be added to the 5' end, tail will be added to the 3' end. But all that changes, Mayur Bache, they will take place in the nucleus only. Changes will occur in the nucleus only. So to the 5' end cap, which will include 7-methyl-guanosine triphosphate. 7-methyl-guanosine triphosphate. And when it is the 3' end, what do we have? We have polyadenylated tail, which will be added in a template independent manner. Which will be added in a template independent manner. And what is the splicing here? Splicing here is the removal of introns. So removal of introns means non-coding sequence. So in the case of eukaryotes, the mRNA that will form, that is hnRNA, heterogeneous nuclear RNA, it needs the processing, then it will become mature RNA. Then it will become mature RNA. So removal of introns, that is non-coding sequence, is the splicing. Then exons, the coding sequence will join. Capping will be done. So here this base is unusual, 7-methyl-guanosine triphosphate, and here the 3' end adenyl will be added in a template independent manner. So this is all about the transcription here. So any other doubt, bache? Any other doubt, bache? Yes? Any other doubt? Adenylated residues will be added to the 3' end in template independent manner, Sheikh bache. It will be done with the help of polyadenylate polymerase enzyme. Okay, so now focus here. This is the genetic code. This is the table. This table is so easy to form. Do you know that? There is one trick. There is one trick, right? So you can arrest gangster. Right, this genetic code is telling us about the triplet codon which will form the amino acid. So the trick here is you can arrest gangster. What is the trick here? You can arrest gangster. So uracil, because mRNA is having uracil at the place of thymine. Cytosine, adenine, guanine. Uracil, cytosine, adenine, guanine. And here uracil, cytosine, adenine, guanine is there. Right? Right? I'll not take your much time. Okay. I'm literally not going to take your much time. So you have to write it in this way only, right? You can arrest gangster. You can arrest gangster. You can arrest gangster. You can arrest gangster. This is how you have to write. So this part is going to be the first base here. The first base here is, this is the first base, this is the second, and that one will be the last base. First base U. And here the second base is also U. First base U, second U. First U, second U, first U, second U. Here, the first base is going to be C. Second is going to be U. C, U, C, U, C, U. And here, let me take the example here. Here the first base is going to be C. Second base is going to be A. C, A, C, A, C, A. Here, let's take the example of this part. First base is going to be A. Second is going to be G. A, G, A, G, A, G, like this. Like this we can make it. Like this we can make it. So at the end, you can mention here, you can arrest gangster. U, C, Ag. So that is how we make this table, right? So see, we are running out of time, so I'm not going to put many emphasis on it. I'm not going to emphasize this part basically. Why is it so, bache? Because we are running out of time. Otherwise, I would have given you the tricks to remember this table, right? The tricks for remembering these codons, but as of now, we do not have time. So from this particular table, what you people need to remember, you should remember start codon, that is your AUG, it is for the tryptophan, right? Stop codon, so U, AG, AGA, this is the trick for the stop codon. This is the trick for the stop codon. So this is what you people should revise. From this part, usually you get only one question. So for one question, I don't think right now we should spend a lot of energy here. So whenever I'll start the classes for the NEET 2024 aspirants, then I'll tell you about it. Okay. So remember this. It is the start codon. These three are stop codon. So UUU, AG, AGA. UUU, AG, AGA. UUU, AG, AGA. This is what you need to remember. Done? Done? So here, bache, it is the tRNA, which is the adapter molecule. It is important. tRNA, adapter molecule, the smallest RNA it is. So here you can see this is the mRNA, the codon, and here you will get the anticodon. This is tRNA. So tRNA in three-dimensional form, it looks like inverted L. When it is two-dimensional, 2D, it looks like clover leaf. It looks like, arey, my bad. Yes, you are right. AUG is for the, it is not for the tryptophan, it is for the methionine. Let me rectify this. My mistake. It is for the methionine, the start codon, AUG. AUG. Done? Done? That's all. So this is what you need to remember here. So for serine, yes. Yes. Now, remember. AUG, remember the codons for methionine, for stop codons, and even codons for this serine and tyrosine. You must be thinking that, ma'am, why are you telling this to us? Because once question was there from this part, right? Question is there from this part. Done? So this is what you should remember according to me. Right, this is just simply an advice. It's your wish you want to follow it or not. You should know the codon for methionine, AUG, because methionine is formed by only one codon. Then stop codons I told you already, UUU, AG, AGA. In this way you can remember, or else Furkana is also just suggesting you are annoying, you go away, you are gone. You have to remember it like this. Third thing is the codon for serine and tyrosine. This is what you people should remember. Like see on mRNA, it is AGU for serine, UAC for tyrosine. That is what you should remember because it is given here. It is given here. Yeah, it is inverted L. Clover leaf is for 2D. So this is the part that you should remember. So will you do it? Tell me. Tell me quickly in the chat section. Will you do it? Will you do it? Tell me quickly in the chat section, all of you. Quick, we are about to finish your class 12th syllabus. Done? So this is what you need to remember. You should, because these two diagrams, right? These two diagrams were there in previous year questions also. So you should remember this part. Okay? Okay? So next is translation. We know it very well. One is the smaller unit of ribosome, another is the larger. Larger is having 3 sites, EPA. Larger is having 3 sites, that is EPA. What is it? It is EPA. E for exit. From this side, the chain will go out, the polypeptide chain will go out, and A is for the, it is the, P is for the peptidal transferase, A is for that, what is A? E for exit, P for peptidal transferase. What about A? Mention it in the chat section. Guys, mention it in the chat section, quick. We have 3 sites in the large ribosomes. Now it is EPA, E for exit, P peptidal transferase. Here you will also see the groove from where the polypeptide formed will come out, and here you are having the A, trans acetylase What is the word here for A? If you don't know, just remember EPA. Just remember EPA. So your first tRNA for methionine will come to this P site, and your second tRNA then will come to this A site, and your ribosome will slide over this mRNA in 5' to 3' direction. Then whatever this dipeptide, whenever these amino acids will join, whenever this dipeptide will form, that tRNA will come to P, and there will be an empty space for next tRNA to come at A. So that is how it works, right? That is how it works. Amino acyl site. Okay, done. Okay, so this lac operon I have already explained, but still you know that lac operon is it is the inducible operon, right? And in our syllabus there is just the negative control of inducible operon. In our syllabus only negative control of inducible operon is mentioned. What is the meaning of negative? Why do we say that it is the negative control? Because here the regulatory gene is forming the repressor only. The regulatory gene is forming the repressor only. So it is PIP-O. PIP-O-ZYA, PIP-O-ZYA, PIP-O-ZYA. So operator is the site where the product of regulatory gene will bind. So this repressor will bind here by default. P, promoter is the site where RNA polymerase will bind. So repressor binds to the operator and prevents the RNA polymerase from transcribing the operon, right? And whenever the inducer, which is again the lactose, when it is present in the medium, when we want to switch on this lac operon, so this inducer will not allow this repressor to bind to this operator. So, the space for RNA polymerase will be there, right? It will bind to the P site, and then what is going to happen? What is going to happen? The transcription of this ZYA will occur. So Z will form beta galactosidase, which will break lactose into glucose and galactose. Y will form permease, A will form transacetylase. So this is what you need to remember, okay? This is what you need to remember, lactose. Okay, so next is the evolution. So are you guys ready, bache? Only few diagrams are left. Trust me, only few diagrams are left. We just need half an hour to finish this class 12th syllabus. Literally, we just need half an hour to finish this class 12th syllabus. Okay. So are you guys ready? Yes, Z is for beta galactosidase, Y is for permease, A is for transacetylase. So we need the expression of permease always, right? Even a little expression of permease, because it is the permease which will allow the lactose to come inside the E. coli. No permease means no lactose inside E. coli. Okay. So see, we just need half an hour to finish the 12th syllabus. Right, we just need half an hour to finish the 12th syllabus. So guys, show some energy, huh? Then later on you can enjoy your break. Then I'll give you a break, na, after 12th. After 12th part, I'll give you a break. You can go for the class 11th diagrams. What say? Thanks. Even you guys need to stay hydrated. Ashu, it is the diagram based session mainly. Guys, tell me, ready? Ready? Ready or not? Tell me, are you people ready or not? So this diagram is off. This diagram is off. Are you people ready? Show some energy, na? And number of likes should be more than 2K by the end of session. The number of likes should be more than 2K by the end of session. Done? Okay. So now let's start the evolution chapter again. My favorite chapter, one of the easiest chapter it is, and here we have the Miller's experiment. You know na, Miller's experiment, it is also known as Urey and Miller's experiment. Okay, Urey and Miller's experiment it is. Okay, so bache, you know that Operon and Haldane, they have given a theory, right? They have given a theory, the chemical theory, or you can say that the theory in which they have explained that actually actually that life started from the non-living material. The chemogen is there, the biogen is there, if you remember, Operon and Haldane theory of the organic evolution, Operon and Haldane theory, right? We even call it as chemical theory. Remember? So this Miller's experiment, it explains that. Like as per this theory, it is believed that initially on environment, right, on the primitive earth, the reducing type of atmosphere used to be there. The reducing type of atmosphere used to be there on the initial, on the primitive earth, right? On the early earth, no atmosphere. On the primitive earth, reducing type of atmosphere used to be there, right? And then after that, currently, what type of conditions are there? Oxidizing atmosphere. So they were trying to prove it, that whether it is possible, chemogen is possible or not. So what they did, they created the conditions like the earlier, the primitive earth-like conditions in the lab, right? So this is the setup. Right, this is the setup. So here you can see the boiling water is there, and now it is the gas chamber. So the question in the NEET exam come from this part, right, that which gases are there in gas chamber. One thing that you need to remember, that for sure water vapors are definitely be there. Water vapors are definitely be there. This is what you need to remember. And what is the another part? Which gases are present here? So we have methane, right? We have hydrogen, we have methane, we have hydrogen, and what else do we have here? What else do we have here? We have ammonia as well. So ammonia, hydrogen and methane is present along with the water vapors. So it is not carbon dioxide, be very specific about it. So your CH4, your H2 and your ammonia used to be there. The first type of question. Secondly, they ask the ratio of these gases. So always remember, A for ammonia, ammonia is the first alphabet, isn't it? A for ammonia is the first alphabet, 1. So always remember, here in this gas mixture, one part of ammonia will be used. Only one part of ammonia will be used, right? So if I am writing it like this, methane, ammonia, hydrogen. So obviously I will write the ratio as 2:1:2. 2:1:2. If I am writing it like this, H2, NH3, CH4, then again 2:1:2. 2 parts of hydrogen, 1 part of ammonia, 2 parts of methane. Even if I am writing it like this, ammonia, methane, H2, then the ratio will be 1:2:2. So you really need to focus on this particular part, that it is the ammonia which is taken as 1 part of ammonia is taken. 1 part of ammonia is taken. Done? 1 part of ammonia is taken. Is that clear? So this is present in the gas chamber. And the another important question is the temperature was 800 degrees Celsius. This experiment was taken for 18 days, and in the first attempt, amino acids were obtained from this particular part, like your alanine, aspartic acid and glycine. Done? These amino acids were formed. So yes, they created that conditions in the lab. They created the reducing kind of conditions in the lab. They took the gas which were prevalent on the early atmosphere. So they provided the source of energy. Right, bache, these electrodes were used. The temperature maintained was 800 degrees Celsius, and they got the amino acid. So by which it was clear that yes, in the early conditions, in the primitive conditions, it is possible that the evolution can, start from the chemicals. Okay, chemogeny is possible. Done. The next question, here the famous question, I think NTA and CBSE, they love this. Homologous organ and analogous organ. Homologous organ and the analogous organ. So you know the trick, isn't it? It's HDAC. It's HDAC. Homologous, divergent. Analogous, convergent. Divergent and convergent. To diverge. What is the meaning of divergent? See, there is one common point. Something is diverging. So can we say that from common ancestor, different species will form because they need to adapt to the different conditions. So here in the homologous organs, right, the basic structure will be same, but it is the function that will vary. Basic structure same, but it is the function that will vary. But it is the function that vary. And here in the analogous organ, you know that it is the convergent. So two different species having different ancestors, because they are living in the same condition, so their adaptations are almost same. So different organs are there, right? Different type of basically the basic structure is different, but the function is same. So examples are important. So here you can see the bougainvillea, the thorn of bougainvillea. These are the examples of what? Your homologous organ. So thorns of bougainvillea and the tendrils of cucurbita, homologous. So homologous organs there. And here you can see man, cheetah, whale and bat, their basic structure is there, function is different. Right, bache? So this is the example. Very important it is. Very important it is. Done? Done? So the next part, this. Adaptive radiation, and you need to memorize, you need to revise the examples of analogous organ. Will you do it? Yes, will you do it? Tell me in the chat section, will you do it? Now you can see the next part here, the adaptive radiation. Bache, you know that adaptive radiation very important. We have even seen that in the case of Darwin finches. Remember, one ancestor species from which is vegetarian, seed eating, from that different other finches they arise. So same is the example here. In the case of adaptive radiation, what you have to consider? The geographical area, the same geographical area. What you have to consider? You have to consider same geographical area. What you have to consider? You have to consider same geographical area. Are you getting my point? Are you getting my point? So here from same geographical area, right, marsupial radiation was there. So different marsupials they arise, like sugar gliders, marsupial mole, Tasmanian wolf, tiger cat, banded anteater, marsupial rat, kangaroo, wombat, bandicoot, koala. So this is what you need to remember. So adaptive radiation is just like divergent evolution, right? That there will be the common ancestor, and from that common ancestor, right, in different directions, evolution will be there, new species will form, but main point here is the geographical area. The geographical area is same. The geographical area is same, right? Right? So here we have another example of convergent evolution. Right, we have another example of convergent evolution, to converge, adaptive convergence it is. So here two examples are compared, convergent. What is the meaning of convergent evolution? In convergent evolution, we consider the ancestors are different, but they are adapting in the same conditions. So organs, the function is same, right? So in individually, if I talk about the adaptive radiation, so individually, adaptive radiation is also the adaptive divergence. So individually, you can take number one example as marsupial radiation. You can even take the example of placental mammals, but we even compare them, right? We even compare these Australian marsupials and placental mammals. Do you know that? We even compare these Australian marsupials and placental mammal, and one question was there from this particular part. One question was there from this particular part in the NEET examination, right? So which examples are there? Australian marsupials and the placental mammals. The placental mammals. Okay, the placental mammals. So kids, you can compare like this: mouse, marsupial mouse, lemur, spotted cuscus, flying squirrel, flying phalanger, like this. This is what you need to do. Okay. Next. Yes, the another important question, the natural selection. Can you mention the type of natural selection in the chart section? Yes, everyone. Can you mention the type of natural selection in the chart section? Can you all mention the types of natural selection in the chart section? Then I'll explain these. These graphs. They are literally very important. All of you, speed up, guys. Speed up. Speed up. Oh my God, Harini ma'am, the speed is decreasing. Let's complete it fast. Oh, my speed is too fast. I cannot. As I said, I cannot do. I need to explain as well. Guys, just mention the name of all the types of natural selection in the chart section. Be quick. All of you speed up. Be quick. Quick, quick, quick. Quick. Yes, very good. All of you, quick, speed up. Stabilizing, directional, disruptive. Stabilizing, directional, disruptive. These are the three names. So just look at this particular peak here, bache. So you can see here we are showing the number of individual with phenotype. Right, this y-axis is showing the number of individuals with the phenotype, isn't it? It is showing what? It is showing the number of individuals with the phenotype. This is what you need to remember, guys. So just look at this peak. So when you consider these ends, then we are talking about the homozygous characters here. Let's say you are considering homozygous dominant here, and here you are considering homozygous recessive. Right, and meanwhile here this part is going to be what? This part is the heterozygous dominant. This is what? This is the heterozygous dominant. What is it? It is the heterozygous dominant. Are you getting my point? Now here, see, phenotypes favored by natural selection. It is the medium-sized individuals are favored, right? This is the one example that they are showing. Now, when you talk about the natural selection, as I said, three parts are there. One is your stabilizing, another is directional, another is disruptive. Another is disruptive. So, when it is the stabilizing, the heterozygous dominant, or you can say that average will be preferred, right? Average will be preferred. Are you getting my point? Are you getting my point? When you are talking about this stabilizing selection, when you are talking about this stabilizing selection, at the time what is happening? See, peak is getting higher and narrower. Why is it so? Because the heterozygous dominant phenotype is, the heterozygous dominant is preferred. Heterozygous dominant means average is preferred. We are not preferring homozygous dominant. We are not preferring homozygous recessive. We are preferring the middle thing, the mean. The average is preferred. The average is preferred. Are you getting it? So here, peak gets higher and narrower. This is what you need to remember. Remember, peak means central part means heterozygous dominant. Like you can take 0, 10. In between all that 4, 5, 6 will be there, na? Something like that. Okay, that is what you need to remember. Now, peak will shift in one direction. One character is preferred. Like during evolution, one character, the one which will survive, is preferred. So, the best example of directional selection is, what is the best example of directional selection? Industrial melanism. Industrial melanism. You can take the example of industrial melanism here. In the case of stabilizing selection, you can consider the example of height in the case of humans. Human height can be considered. Are you getting my point? Industrial melanism. Evolution of horse, right? In the case of disruptive, remember, 2 peaks will be observed. 2 peaks will be observed, guys. 2 peaks will be observed. Both the homozygous will be preferred. Homozygous dominant, homozygous recessive. Heterozygous will not be preferred. Mean will not be preferred. Average will not be preferred. So, can I say that disruptive is saying that I will go for the black or for the white, no grey, right? No grey. That is the point. So, this question is very important. Now, come to the next chapter, human health and disease. Malaria caused by Plasmodium, right? Plasmodium, protozoan it is. Primary host is the female Anopheles. Secondary host is the human, right? And here, why are we saying that female Anopheles is the primary host? Because the sexual stages are there in the primary host only, right? Right, very good Priyu bache. Say in secondary host, human is the secondary host because asexual stages are there in human, there is no sexual stage. So you can see when the female Anopheles having the sporozoites in her salivary gland, when she is going to bite the human with the saliva drop, all that sporozoites will enter within the human, right? So after taking a half an hour tour of the body, they will reach into the liver. So the question that used to come is sporozoite. It is the infective stage here. MCQ. It is the sporozoite which is the infective stage. It is the sporozoite which is the infective stage. Now in the liver, all that mosquitoes, they will, all that sporozoite, it will acquire the spherical shape, it will grow, it will divide, binary fission will occur. You can say that multiple fission will occur. Multiple fission will occur. This sporozoite is going to increase its number. The sporozoite will be having different stages here in the liver. So main function here is it wants to increase its size. So can I not say that asexually it is dividing? Asexually it is dividing. Can I not say that? The parasite reproduce asexually in liver cell, bursting the cell and releasing into the blood. So ultimately in liver, it is going to increase its number. It is going to increase its number. It is going to increase its number. That is what you need to remember. Okay? Okay? Hana Mukid, female Anopheles is going to suck the blood because it needs that to nourish the egg. अच्छा श्वेता यादव इज सेइंग मेरा दोस्त बन जाओ यार कोई। श्वेता इतने मिलने हैं लोग, नीट की प्रिपरेशन ना करे, तेरे दोस्त बने बच्चे। हाँ फोकस करो यार। ओके जस्ट फोकस हियर। So in the liver, asexually it is going to divide, asexually it is going to divide, asexually it is going to divide. So whenever there will be too much of stock of that parasite, it will be released in the blood. It is going to affect the blood cells. It is going to affect the RBC. It is going to it is going to digest the hemoglobin present there. And ultimately what is going to happen here? Parasite will reproduce asexually in RBC, bursting the RBC, causing the fevers, because here the poison hemozoin will be released. Hemozoin will be released. That is responsible for causing the fever. That is responsible for causing the fever. So after that, what is going to happen? Now the plasmodium is like, yeah, I cannot just divide and divide. I need to go for the sexual stages as well. So in 2 RBCs, it is not going to destroy that RBCs. That sporozoites will grow. They are going to form the male and the female gametocyte. Male and the female gametocyte is the word. Male and the female gametocyte is the word. Right? Male and female gametocyte is the word. Now this gametocyte cannot grow in the human body because human body is not providing the optimum temperature. So it has to be taken by the female Anopheles. So if female Anopheles will again bite the human having malaria, right, then obviously that gametocytes will enter in its body, they will enter in its digestive system. Then you know that gametocytes, from that gametocytes the gametes will form, you can see that, right. So female mosquito takes up the gametocyte with blood meal. So fertilization and development will be there in the mosquito gut. Remember this, in the mosquito gut. So after that, what is going to happen? If you remember, ookinete will form. The mobile zygote, also known as vermicule, So it is going to invade the stomach, it will reach there, it will acquire the circular form, it will form the oocyst here. Again the division will be there, asexual division will be there. So many sporozoites will form, pass to the proboscis, and again the cycle will be repeated. Any doubt? Any doubt? Any doubt? Guys, be quick. Any doubt? Yes, if you guys are having any doubt, do let me know in the chat section. Do let me know in the chat section. Do let me know in the chat section. Okay? Done? So the next part again, this is the fungal disease, right? Ringworm. So type the name of the fungus in the chat section. Type the name of the fungus in the chat section. Guys, you are not going to get such session where teacher is teaching with such an enthusiasm, plus teacher is covering each and everything, whatever they have promised. Isn't it? Whatever a teacher has promised, we are trying to provide you that. Right? We are providing you that rather. We are providing you that rather. Whatever is important, I am teaching you. Right? And it is the best way to revise your complete syllabus. Right? It is the best way to revise your complete syllabus. So, show some energy, be committed to this session. By the end of the session, do practice the PYQs and you will see the change in scores. You will see that yes, now I am able to answer many more questions. Guys, so whatever I am asking, please answer. Stay tuned. And today the target for the like is 2K plus. Go for it. Answer the question. Ringworm, you know that. Yes, it is the ringworm, fungal infection. Trichoderma microsporum, epidermophyton. Trichoderma microsporum, epidermophyton. Wicheria vencrofti, the askelminth, the nematode. Wicheria vencrofti, elephantiasis it is. Filariasis it is. Right? Now, here, the antibody structure having 2 heavy chains, 2 light chains, 2 heavy chains, 2 light chains. So, when you look at this heavy chain, can you see this? Disulfide linkage is joining this hinge. Disulfide linkage is joining this hinge, and even heavy and light chain is also joined together with the help of this sulfide bonds. Isn't it? Isn't it? So, this part is the part where antigen will bind. This is the variable region of both heavy chain and the light chain, and this is basically the paratop. And over the antigen, let's say this is the antigen. So, antigen is having a site here which will bind to antibody. Let's say antigen is having site here which will bind to antibody. So, this site is known as epitop. Right? Epitop, paratop, epitop, paratop, epitop, paratop. That is how they are connected. So, antibodies they are. So, for antibodies, the trick is GAMD. G-A-M-D-E. It is not gamed, it is GAMD. It is not gamed, it is GAMD. Right, bache? So, immunoglobulin G, A, M, immunoglobulin D, immunoglobulin E. So, the maximum quantity is of J, then A, then M, then D, then E. Okay? Okay, so A is a dimer, M is a pentamer. So, it is the M which will form first whenever any intruder enter in our body. Done, bache. So, next is this bache, retrovirus. Here you are talking about the RNA virus, that is HIV. That is HIV, right? Human immunodeficiency virus. So, you know that it is having the reverse transcriptase. So, what is going to happen here? You can see this is having the viral protein coat, it is having the RNA coat. The virus is going to infect the normal cell. Virus outside the body, it is non-living, it is just the crystalline protein. Inside the body, it is living. Inside the body, it is living. Right, bache? Inside the, bache Mukeed, with the help of these diagrams, I am revising the entire syllabus. So, what do you want me to explain? Do not spam here. Focus here, right? So, retrovirus is the one having RNA as the genetic material, and you know that reverse transcriptase will be there. From RNA, the complementary DNA will form. Now, this viral RNA core, you can see this. So, this RNA, because from this RNA, complementary DNA has been formed with the help of reverse transcriptase. Now, you can say that retrovirus, it is infecting the animal cell. What will happen here? The viral RNA will be introduced into the cell, the RNA. Now, this RNA, right, viral RNA is introduced into the cell. This is what you need to remember. They can ask you, they can put a blank over there. They can ask you, what is present here, RNA or DNA, RNA or DNA, RNA or DNA. This is what you need to know, right? So, viral RNA is introduced in cell. This viral RNA, you can say, from this viral RNA, viral DNA will be produced by reverse transcriptase. So, the first question, RNA virus, retrovirus is going to insert its RNA in the animal cell, then from that RNA DNA will form, from that RNA DNA will form. Now that DNA is formed by the reverse transcriptase, this viral DNA is going to join with the host genome. This viral DNA is going to join with the host genome. It is going to join with the host genome, right? So, because of that, what is going to happen? New viral RNA is produced by infected cell. This will produce more viruses. So, you can see here, new viruses can infect other cell. So, best example is of HIV, and you know that it will use macrophages as the HIV factory. It will use macrophages as the HIV factory. This is what you people need to remember. Now the next diagram, chemical structure of morphine. What is morphine? Pain reliever. We also call it as analgesic, right? Acetylation of morphine will give diacetylation of morphine will give heroin. Then morphine, pain reliever, analgesic it is. Analgesic it is. Right, then comes the opium, poppy, papaver it is, isn't it? Papaver it is. So diagram based question used to come from this part. Diagram based question used to come from this part. So you know that these parts are used for producing that, forming that drugs. Okay. Okay, the next part, here you can see the cannabinoid, which is obtained from cannabis, from the hemp plant. So, if you have to differentiate these two structures, morphine, so see, focus on this part is only there in morphine. Now, in the case of cannabinoid, it will be like this, bus, it will be like this, okay. So, that, the structure like this. It looks like a swing, na? That swing kind of structure is there in morphine. That swing type of structure is there in morphine. And next here you guys can see this type of structure. So cannabis, hemp plant, right? From different parts, different things are obtained. So this is what you need to remember. So a question can come from the structure. So dhatura, which will produce hallucinogens. So diagrams are important. So when it is poppy, it is going to be something like this. When it is dhatura, just look at the shape. Right, just look at the shape. So when it is morphine, some swing like structure is present in morphine. When it is cannabinoid, it will be like this. So question they can ask you is, they can just put the structure, they can ask you this structure is of, this structure is of. So this swing like morphine, this zigzag is your cannabinoid. Now this is the biogas plant, which is typical biogas plant. You know that anaerobic conditions are required, methanogens are there. So biogas is basically the mixture of CH4, CO2 and even H2S is there. So just look at this, the digester, the waste, the dung will be present here. So from this particular tank, dung plus water, which is making the slurry, that will be passed here. The methanogens, the anaerobic bacteria are going to act on it. They will produce the biogas. Whatever is left, that sludge will be taken here. It can be used as a compost. So with the help of this pipe, it will supply further. Okay. Okay. The word here is anaerobic. Next, sticky ends, biotech. Biotech. We are talking about the biotech here. Right, we are talking about the biotechnology. So here we are talking about the formation of your sticky ends and blunt ends. But it's a very famous example of restriction endonuclease, your EcoR1. It used to form sticky ends. Sticky ends means complementary overhangs. What is the meaning of sticky ends? Sticky ends means complementary overhangs. What is it? It is the complementary overhangs. Right, right. So what you have to remember from this particular part, dekho, two type of ends can be formed by restriction endonuclease. Restriction endonuclease is the one which can cut the DNA at specific sites. So it is going to recognize the specific sequence, then it will make the cut. Recognize, cut, recognize, cut, recognize, cut. Type these two words in the chat section, quick all of you. Type these two words in the chat section. Recognize, cut, recognize, cut, recognize, cut. Quick, type it in the chat section. Type these two words in the chat section, be quick. Done. Recognize, cut, recognize, cut, recognize, cut. Right. So, EcoR1 will recognize the palindromic sequence. So, what is the meaning of palindromic sequence? I'll quote one example, like the word is there, na, mom. If you are reading it in this direction, again same spelling. If you are reading it in this direction, again same spelling, mom, dad, radar, words like that, right? Words like that. Now, what is the point here? EcoR1 is going to produce the sticky ends, and which palindromic sequence is recognized by it? It is GATTC, GAATTC. All of you type this GATTC in the chat section. All of you speed up, guys, speed up. GATTC, 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 GAATTC, GAATTC, GAATTC. EcoR1 recognize this. EcoR1 recognize this. GAATTC, GAATTC, right? GAATTC, GAATTC. G, like we have the network now, 3G, 4G, 5G. So this G is towards the 5 dash end. Again, the common mistakes, the common mistake that students used to make. C is towards the 3. So it is GAA TTC, GAA TTC, GAA TTC. So now 5 prime, 3 prime. So here also GAA TTC. See, so there will be a cut, right? So in the case of eco R1, because it will produce the sticky ends, so it is going to break the sugar phosphate backbone. Always remember, your restriction endonucleases, they are going to break the sugar phosphate backbone. It will break the bond in between G and A. In between G and A, because it needs to form the complementary overhang. So what you need to remember here, the 5G, the 5G, this is something that you need to remember, the 5G means this G is towards the 5 dash end. Always remember it. In the exam, you people get confused, because if even they will write it like this, na. This is incorrect, right? This is incorrect. It's 5G, it's 5G, it's 5G that you need to remember. It is the 5G that you need to remember. Okay, okay guys, done. So you can see that what this restriction endonuclease will do, it will recognize cut. What will it cut? Sugar phosphate backbone. What will it cut? Sugar phosphate backbone. So bond in between the sugar and between the G and A will be cut. You can see these complementary overhangs, and the same restriction endonuclease will be used to cut the DNA on the desired segment and on the plasmid as well. Done? Done. Sure everyone? Sure. So eco R1 is going to recognize this particular sequence, right? So I'll quote one more example here. Hind 2, blunt ends. Hind 3, sticky ends. Done? So whatever examples are given in the NCERT on the base of this topic, do remember it. Now the next part, here you can see the diagrammatic representation of rDNA technology. So with the help of restriction enzyme, we are going to make the cut in the foreign DNA and in the plasmid. And we have to use the same restriction enzyme, because if we will use same restriction enzyme, we will get complementary overhangs. We will get complementary sticky ends, which are very important if we want to join any of the foreign DNA to this plasmid to form the recombinant. Right, to form the recombinant DNA. If we want to form the recombinant DNA, we need to use the same restriction endonuclease. Is that clear? Same restriction endonuclease. So guys, it is the ligase which will join. No doubt they are the complementary overhangs. If G is present here, C should be there, hydrogen bond will form. If A is there, T should be there, hydrogen bond will form. No doubt they are complementary to each other. When we will bring them together, then obviously bond will form, hydrogen bond will form. But ultimately, which enzyme is going to join the sugar phosphate backbone? Which enzyme is going to join the sugar phosphate backbone? It is the ligase. Ligase will join sugar phosphate backbone. It is the ligase which will join sugar phosphate backbone. Ligase is the molecular glue. What is it? It is the molecular glue. So it is the one which will join the sugar phosphate backbone. Any doubt? Any doubt? Any doubt? Any doubt? Sure? Sure. Okay. So here you can see, then this recombinant, it will be transformation will be done. So it will be taken up by this cell, and then it will be passed to the cloning host. So again, the question was there from this particular diagram. Now what is the next part? This. This is the most important thing. The PBr322. Right? I challenge you to remember it. Kids. I literally challenge you people to remember it. So it is most important. So PBr322. 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 Remember it. I'll give you a trick. Not today, in a short video, I'll give you a trick how to remember this. PBr322. 3 to 2. So E. coli, the cloning vector it is the cloning vector in the case of E. coli. So here you can say that it is showing the restriction sites. So the type of question that can come from this part, they can ask you how many restriction sites are present on this PBR 3 to 2. How many restriction sites are present? So you can say that restriction site for Hind 3, Eco R1, BAMH1, SUL1 and PVU2, PST1, CLAT1. So ultimately 1, 2, 3, 4, 5, 6, 7. So how many restriction sites are present? 7. 7. You should remember the name also. You should remember the name also. Then it is having the origin of replication. It is very important. That is why it is a plasmid. Plus it is having this ROP. ROP is for the proteins which are required for the replication. It codes for the proteins which are required for the replication. So you should know what is the meaning of ROP here. You should know what is the meaning of ROP here. And yes, Sarah, you are right. P stands for plasmid, B and R. It is Bolivar Rodriguez. This is what you need to remember. Right? Right? So how many restriction sites are there? 7. Right? So ROP stands for proteins for the replication of this plasmid. ORI, origin of replication. How many antibiotic resistant genes are there? 2. Ampicillin resistance, tetracycline resistance. Ampicillin resistance, tetracycline resistance. Is that clear? Is that clear? So this is what you need to remember. So tomorrow I'll give you the trick for that. Okay. Done? Yeah, I'll share these new notes in the Telegram group. Don't you people worry. Okay. The next part, here we have the PCR. So in the PCR, again the trick is dye. All of you, the trick is dye. What is the trick here? Dye, denaturation, annealing, extension. This is the sequence of that trick. Dye it is DAE, 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 denaturation, annealing, extension, denaturation, annealing, extension, denaturation, annealing, extension. Isn't it? Isn't it? It's dye. What is it? It's dye. Done. So first step is denaturation, where the temperature is going to be high. You can say that above 90 degrees Celsius it will be. Then there will be the annealing. Annealing means joining. Primers will join. So which primers are there in PCR? These are the oligonucleotide primers, means these are the DNA primers. These are the oligonucleotide primers. These are the DNA primers basically. Then there will be the extension. And at the time of annealing, the temperature will be low because we want that primer to join to these single strands. So here what is going to happen? The temperature will be low, somewhere in between 50 to 60 degrees Celsius or 65 degrees Celsius. Then in the extension, Taq polymerase, which is obtained from Archaebacteria thermus aquaticus or Thermophilus aquaticus. From the Archaebacteria thermus aquaticus or Thermophilus aquaticus, this Taq polymerase will be formed, right? TAQ. T stands for thermus, AQ stands for aquaticus. The Taq polymerase will be obtained. This enzyme can withstand the high temperature. That is why it is used in PCR. In the PCR, very first point that you need to keep in your head, in the PCR, there will be, in the PCR, in the polymerase chain reaction, the continuous DNA synthesis will be there. The continuous DNA synthesis will be there. The continuous DNA synthesis will be there, the first point. Secondly, no lagging strand formation will occur. No lagging strand formation will occur. Third, Taq polymerase will be used. Taq polymerase will be used. This is what you need to remember. So this cycle will be repeated, right? And we will get the DNA. Okay? Okay. The next part, bioreactors. The most common type, stirred tank bioreactor. So this diagram is of simple stirred and this one is of sparse stirred tank bioreactor. Simple stirred, stirrer is present for the uniform availability to the oxygen to this particular medium which is present here. And in sparse tank bioreactor, surface area increase for the oxygen transfer here. Gas entrainment is present. Bubbles are going to increase the oxygen transfer area. Can you see the bubbles here? It is also the sparse tank bioreactor. You will see the bubbles, and these bubbles, they dramatically increase the oxygen transfer area, and here increased surface area for oxygen transfer is there. This is what you need to remember. Again important. बच्चे 30 cycles will be taken, 90 बच्चे which will produce 1 billion, which will produce billion of copies. Means these cycles will be repeated again and again. Ultimately, in polymerase chain reaction, amplification of the DNA will be done. Guys, there will be no chemistry class today. Please focus here. Okay? Done? Now, the next part, the cotton, the BT cotton. The BT cotton. Right? So, from Bacillus thuringiensis, we will get some genes, the cry genes. You have to write all the letters in small case, cry genes. And that cry genes will give cry proteins, capital C, R, Y. So, there are different cry genes which will, which are going to kill different pathogens, or you can say that pests. Okay? Okay? So, any doubt up to this part? So, see, biotech and then ecology is about to come. Ecology is about to come, guys. What about your energy? My energy is still high, right? My energy is still high. What about your energy? Tell me quickly. And let's make this family 26K subscriber family. We'll be very happy. Right? So, guys, if you're new to this channel, do subscribe it. And if you're not new to this channel, then share this channel with your juniors, with your classmates, with your friends. So, the question will come from this part, cry-gene, cry-proteins. And yes, I have taken a marathon on human physiology. Keep it on 2x, check it. I have taken the marathon on plant physiology. Again, increase the speed, keep it to 2x and then check. But do revise that topics. You need break after finishing the 12th. You might get, you'll get break after 12th. But as of now, let's study that. आग लगा देंगे पेपर में, मत आग लगा दियो बच्चे, फिर नंबर कहाँ मिलेंगे पेपर में आग लगा दी तो. हाँ, little break you'll get. Let's finish the 12th part now. What say? Let's finish the 12th part. Done? My tea will not come. My friends are like that only. They are not going to bring any tea or something. I was not even expecting from them, and now they should not come here, otherwise. If Taq polymerase Dhanushri, it will not work, then extension will not be there, the new strands will not form. Okay? Done? So, let's continue. So, when you talk about the BT stands for Bacillus thuringiensis. It is a bacteria. It is having the genes that used to form the proteins. But the toxin that it forms, it used to be in inactive form. So, we use the word prototoxin for that. If you remember, the insects are going to inject that toxin within the body of the insect, in the digestive system, in the midgut epithelium. It will create some pores, right? Because of starvation, that particular larva will die. Now here, the topic that we need to focus is BT cotton, the genes. For the genes, the word is cry. You have to write it in small case. But for the protein, the first alphabet should be capital. So, it should be cry protein. It should be cry protein. Right. So, what do we have here? We have the cry2AC, cry2AC, cry2AB. It is going to control the cotton bollworm. Cry2AC, cry1AC, cry2AB, cry1AC, cry2AB, cotton bollworms, right here. And when it is cry1AB, corn borer. Cry1AB, corn borer. Very important. Very, very, very important. The most important part of this chapter. Okay. Now the next part. So here we are having the example of what? Melodygyne incognita. Right. So you know that Melodygyne incognita. So it's a nematode. It's a nematode. It affects the roots of tobacco plant. Roots of tobacco plant. Right. So which will result in less yield. Right. So how to make the transgenic tobacco plant to cope up with that? If we want to make transgenic tobacco plant to cope up with that, which technique will be preferred? RNAi. What is the meaning of RNAi? Everyone in the chat section, what is the meaning of RNAi? What is the meaning of RNAi? All of you in the chat section. All of you in the chat section, what is the meaning of RNAi? RNAi is, what is this RNAi? RNA interference it is. It is RNA interference it is. Right, RNA interference it is. Here what will we do? We are going to switch off, yeah, we are going to inhibit the translation of that particular mRNA which can cause harm to the transgenic tobacco plant. See, it's a very basic story. Let's say this is a particular plant. Okay, don't judge my diagram. Now, don't judge my diagram, just focus here. Let's say this particular nematode is coming to infect this particular plant. Okay, so obviously this nematode must have some genes that are going to produce some proteins that will affect this tobacco plant, isn't it? Right, there must be some genes that are going to produce some proteins, and that protein of nematode is going to affect the yield of this tobacco plant. So now if I want to protect my transgenic tobacco plant, what I have to do, I just need to use any mechanism which will not allow the gene of that nematode to get transcribed, right, and to produce that protein that can damage the roots of my tobacco plant. This is the key. So we have selected one mechanism for that is RNA interference. This is a cellular defense mechanism in the case of eukaryotes. It's a cellular defense mechanism, but in the case of what? In the case of eukaryotes. So what is happening here? Whatever is the target mRNA, we will not let the target mRNA to form the protein. So what are we going to do here? The nematode specific genes will be inserted in this tobacco plant. The nematode specific genes will be inserted in this tobacco plant. What will be done here? Nematode specific genes will be inserted in tobacco plant with the help of agrobacterium vector. Agrobacterium is having a vector, na? It is having that tDNA, na? Ti plasmid. Agrobacterium is having that Ti plasmid, na? Tumor inducing plasmid. So with the help of tumor inducing plasmid, nematode specific genes will be inserted here, right? They will be inserted here, and that nematode specific genes, they are going to produce, let's say this is a gene. So both the strand of this gene, basically DNA gene is present on DNA, na? So both the strands will be transcribed. It will produce sense RNA and antisense RNA. Both the strands will get transcribed. 2 mRNAs will form. These mRNAs are complementary. They will form double-stranded RNA. So that double-stranded RNA to this double-stranded RNA, your enzyme dicer. Do you know dicer is used here? Dicer, which is RNase. It is an endonuclease. This dicer is what? It is an RNase. It is endonuclease. This dicer will break this double-stranded RNA. It will break it into small fragments. Even it will get single-stranded. Now that single-stranded with some risk protein, with some RNA-induced splicing complex, it will target the mRNA and will destroy it. It will target the mRNA and then will destroy it. So this technique will be used here in producing the transgenic tobacco plant. Okay, so here you can see host plant generated double-stranded RNA triggers protection against nematode infestation. These are the roots of a typical control plants, and that is the transgenic plant. That's all. Right, bache? So next is this. See, after this we will start the ecology. Let's be very quick. So here you know that pro-insulin, pro-hormone it is, inactive insulin it is. Why is it so? Because it is having the 3 chains, the chain A, the B, the C, right? Always remember, A chain is having 21 amino acid. See, A is the first alphabet, na? So remember this one. And B, from B pick up the 30 amino acid. So total in a functional insulin, 51 amino acid will be there. And in C, in some books 33, in some books 34 is written. In some books 33, in some books 34 is written. Okay. So what we have to do, how can we active this pro-insulin? We have to cut the C peptide. We have to remove the C peptide, right? What we have to do? we have to remove this C peptide and then it will become active. So in active insulin, A peptide and B peptide will be there. Both of them are connected together with the help of disulfide bridge. With the help of disulfide bridge. Are you getting it? With the help of disulfide bridge, they will be connected together. Okay. And the free C peptide will be released. Done, bache. Now next is from which chapter? Bache, transposons are, you know, the junk DNA which is present. The jumping elements they are, Vishnu. Tell me, this diagram is from? This diagram is from? This diagram is for organism and population. So you can see here they are showing us the biome distribution with respect to the annual temperature and precipitation. So here, right, towards this x-axis, the annual precipitation is there. The annual precipitation is there, and here you will talk about the annual temperature. So you guys can see here, see, when the temperature is very low, it is in negatives. Obviously, snowfall will be there. So Arctic and alpine tundra. This is what you need to remember. So you have to keep it in your head like this. Temperature is low, temperature is too low, Arctic and alpine, tropical forest. The temperature is high, the rainfall is too much. So everything is in between, Arctic and alpine tundra and tropical rainforest. Arctic and alpine tundra, tropical rainforest. So everything is present in between, the first point. Now when the temperature, like see, it is in negatives. Okay, then after that, see, just imagine snow and snow and snow is there everywhere. So now Arctic and alpine is done. Now you know that when it is the desert, come here. Now focus on this part, desert. Initially it was snow, Arctic and alpine, then desert is there. So slowly on that desert, grass will grow, so grassland. Then now after grass, obviously trees will grow. So coniferous, right? That conifers will grow, coniferous forest will form, or the temperate forest, and then comes the tropical. So desert, grassland, forest. Desert, grassland, forest. Desert, grassland, forest. And when it comes to the forest, coniferous, because they are xerophytic, can adapt to that extreme conditions. Then temperate, tropical. So tropical is having maximum rainfall, very high temperature. This is how you need to remember it. So do draw it, right? Draw it. Then here we have bache conformers, regulators and partial regulators. So you know that regulators which can regulate their internal condition, which can maintain the constant internal condition. They can regulate their internal condition, isn't it? Isn't it? So obviously they can survive everywhere. Just we have the property of homeostasis. We can maintain the constant internal condition. Our kidney is playing the role there, isn't it? Partial regulators, like see, if up to a level they can, you know, they can regulate the, they can maintain the internal condition constant whenever there is a change in the external condition. Up to a certain level they can maintain it, but not after that. So V comes under the regulator. So whenever you feel demotivated, just remember one thing, only 1%, less than 1% animals are regulators, right? Less than 1% animals are regulator. At least we are in that less than 1%, right? Like birds and mammals, what are they? Warm-blooded, homeotherms, right? Endothermic, right? So we can maintain constant internal condition. Our internal conditions will not change with the ambient conditions, with the surroundings. And conformer, like your plants are conformers. Majority of animals are conformers. They cannot maintain their constant internal condition. They cannot maintain the conditions inside constant. Okay? Okay? Now, important age pyramids. When the population is expanding, see, we have three things here. Pre-reproductive phase, reproductive phase, post-reproductive phase. At base, we will be having pre-reproductive, then reproductive, then post-reproductive. So, if it is like that, means it is expanding, means population growth is positive. Positive population growth is there if pre-reproductive population is more, right? It is triangular. It is triangular. Again important बच्चे. Then stable. In the case of stable, there is no pre-reproductive and reproductive will almost be same, right? Then post-reproductive. So you can say here it is stable. So population growth is 0. No growth is there. No growth is there, right? No growth is there. So it is just like bell shaped, right? And here in declining, pre-reproductive population will be less, then the reproductive, then post. Is that clear? Is that clear? Done? Bachcho, even biology is important, Pranav. So please focus here. Right? So triangular it is, positive growth is there, 0 growth is there. So declining means negative growth is there. Right? The reproductive, pre-reproductive phase, the number of individuals in pre-reproductive phase is very less. It is very less. So this is what you need to recognize. Then bache, here you know that natality, the birth rate, even the immigration, it contributes in population density in a positive way, right? And this immigration and mortality, it is decreasing. Let's say here I have 100 people. If there is the birth of 10 new people plus 10 immigrants are there, the population will become 120. So obviously it is increasing the population. So plus sign is there. And let's say if there is a death of 10 people, obviously 90, and let's say 20 are going to move. So obviously 70 it will decrease. That is it. So if you want to check the population density at time t plus 1, then it will be nt plus I, because nt plus b plus I minus m plus e. That is how you can calculate. So it is the basic mathematics. It is the basic mathematics, right? It is the basic mathematics, right? So here bache, you can see the population growth curve. One is the S-shaped, right? One is the S-shaped sigmoid, also known as Verhulst-Pearl logistic growth curve. Verhulst-Pearl logistic growth curve. Done? S-shaped. And another is J-shaped, which is exponential. So in J-shaped, there is no, right? In the J-shaped growth curve, unlimited food and space is there. Unlimited food and space is there. But here it is going to be limited. So when it is exponential, because no carrying capacity, no environmental resistance, so it will grow like this. Right? So it is going to be dn over dt, that is change in the number of population density, is equals to Rn. So what is the R here, bache? Question. This question was there in the previous year paper. What is the R? R is the intrinsic rate of natural increase. Yes or no? Intrinsic rate of natural increase. Even it is known as biotic potential R. Even it is known as biotic potential. What is this R? This R is equals to B minus D. It is equals to birth minus death. So R is also considered as biotic potential and intrinsic rate of natural increase. Because after birth and death, we will get to know if we are subtracting the birth and the birth rate and the death, then only we'll be able to check what actually is the what is the increase actually in the population size. So it is like that. Okay. So dn over dt is equals to Rn is the J-shaped growth curve, exponential growth curve it is, right? There is no carrying capacity concept here because there is no environmental resistance here. But when it is the S-shaped growth curve, so it is going to be, see, initially the lag phase, then log phase. Log phase means exponential rise will be there. Then comes the stationary phase. Then comes the stationary phase, the stable phase. Right? So here you have to remember when k is equals to n, it is the asymptote. There is no further growth in the population after that. When k is equals to n, when population size and the carrying capacity is same, there is no further increase. It is the asymptote. Now the population size will not increase. Now the population size will not increase. So now when it is the sigmoid growth curve, then we have to even consider the environmental resistant, that is k minus n over k. K, right? It is k minus n over k. So here this k minus n over k, it is showing the environmental resistance. Environmental resistance, right? So in the paper they can simply ask you K minus N over K, environmental resistance. R is the biotic potential or intrinsic rate in the natural increase. R is equals to B minus D. It is B minus D. Clear bachche? It is B minus D. Then bachche, the question is there from population interactions. We are about to finish it. Be happy. So now you can see here population interaction, one of the most important species. If both the species are getting benefited, mutualism, symbiotic association. Negative means both of them are not having the benefit, right? So competition, one is getting benefit, another is not. Plus is for the benefited, minus not benefited. Okay, 0 is means neutral, no change. So plus and minus is for the predation, where predator is going to get the benefit and the prey population will decrease. Again, same is for the parasitism bachche, and for commensalism, one will be benefited and another will be neutral, no change. And in amensalism, one will be harmed and another will be no change. This is what you need to remember. So this is your homework. You have to revise the example of these interactions and you will mention it in the comment section. You will mention it in the comment section. Okay? Okay, this topic is very easy. You just need to focus on the example. Mutualism, both are getting competition. If there is a competition, minus. Predation, mein predator will get the benefit, prey will not get the. Same is the case of the parasitism. And when it comes to the commensalism, plus 0. Amensalism, minus 0. Right? Plus 0. So keep it like this now. Right? Keep it like this. You can keep it talk. You can keep it talk. What you can do? You can keep it talk. Talk. T stands, it is not the T, it is the plus sign here. O, neutral. C means commensalism. So the trick here will be talk. Talk. T is showing plus sign. O is showing that plus sign that where one species is getting the benefit. O is showing that another species is neither benefited nor harmed. C is commensalism. That's all. So if you know the commensalism, then you can put the amensalism example. Right? Then you can put the amensalism example. Isn't it? Isn't it? If for commensalism it is talk, then obviously in the amensalism you just need to know one thing, that there will be the minus. That's all. Done? Yes, mutualism mein we have many examples. Na? See, fig tree and the wasp. Remember Pronuba moth, and even one more example is there. Pronuba moth and I forgot the name. Pronuba moth and yucca plant. Mutualism. Mutualism, and here the fig flower is pollinated by the wasp laying egg in the fig fruit. One more example, Pronuba moth and that yucca plant in the chapter sexual reproduction in flowering plants. And here bache, these are the different trophic levels. This is the example of the food chain. So you know that the first trophic level will include the primary producers, right bache? Here we are going to have that plants and all. Here the second trophic level will have herbivores. Herbivores are what? They are even the primary consumers. They are even the primary consumers. Second trophic level it is, but they are the primary. Then third trophic level carnivore, you can call them as secondary consumers. Secondary consumer, and here we have the top carnivore, the fourth trophic level, or the tertiary consumers they are. So question can come from this food chain. And yes, when from one trophic level to another trophic level, whenever there is the flow of energy, only 10% energy will pass. Rest all will be wasted. Only 10% energy will be passed. Rest all will be wasted. Right, bache? So same as the case here. Remember 10% law of energy. 10% law of energy. 10% law of energy. Only 10% energy will be passed to the next trophic level. So that is why when you talk about the energy pyramid, na, it is always upright. Right? Pyramid for energy. It is always upright without any exception. Without any exception, it is always upright, because only 10% energy will pass to the next trophic level. So the first trophic level will have more energy, second one will have less, and the last one will have obviously less. So here you can see the different pyramids. So pyramid for age pyramids and these pyramids. These are the ecological pyramids, Alentonian pyramids, they are important. Both of them are important, right? Both of them are important, bache. So here you guys can see, so P for producers, then primary consumer, secondary, tertiary. So it is for the number. So when you talk about the grassland ecosystem, so grass more, then consumers are less. So it is going to be upright. So you guys can write it down. The question can come from this part for sure. So pyramid of number in the grassland ecosystem is going to be upright. Pyramid of number in the grassland ecosystem is going to be upright. Pyramid of number in the grassland ecosystem is going to be upright, isn't it? Now, see here, again, most important one. Now, when you talk about the biomass, biomass means organic matter. So, biomass means organic matter. So, here you can see, bache, again you can see there is a sharp decrease in biomass at higher trophic level. Normally it is like that. But yes, but if you talk about the biomass in the case of aquatic ecosystem, na? If you take the example of aquatic ecosystem and if you check the pyramid of biomass in aquatic ecosystem, then you can say that yes, it is inverted. See, inverted pyramid of biomass, small standing crop of phytoplankton which supports the standing crop of zooplankton. So both of them are important, right? So whenever the word is standing crop, so here we are talking about the biomass, right? We are talking about the organic things here. If we are saying standing state, inorganic things. So pyramid of number is always upright when you talk about the grassland ecosystem. But if you talk about the tree ecosystem where there is one tree, then so many birds are there, that birds are having so many parasites, then you can consider it as inverted, right? Pyramid of number, when it comes to the tree ecosystem, then in that scenario you can take it as inverted, otherwise it will be like that. And here this example is important. So what you have to remember? Bache? You should remember the inverted pyramids only. So which one will be inverted? Number 1, pyramid of biomass in the case of aquatic. See, in the case of aquatic ecosystem, where the biomass of phytoplankton is less and the biomass of your zooplankton is more and it is supporting it. Next, which one is inverted? Pyramid of number in the case of tree ecosystem. Even it is inverted. So rest everything is upright. So you should focus on the inverted pyramids only. Right, bache? So see here the sunlight for the energy, it is always upright. Right? So 10,000 joule to 1000 to 100 to 10. So 10% flow of energy will be there. Done, bache? So this data is from the biodiversity. Okay. So in the biodiversity, I have a trick. That is fungi farm. There is a trick for you. Do you remember it is mentioned that species richness is more in the case of fungi. Fungi are having more number of species if you compare it with the species richness in the case of fishes, amphibian, reptiles and mammals. Remember fishes, fungi, farm. The number of species. Bache, in the case of Kavya, pyramid of number in the case of tree ecosystem, one tree. Then so many birds are there. That so many birds can have so many parasites. That is what I am saying. Right? So fungi farm is the trick. Do you remember this line that species richness means the number of species if we see in the case of fungus, it is more than the combined number of species in the case of fishes, amphibian, reptiles and mammals. So the trick here is fungi farm, and this trick is explaining one line from the NCERT. In the NCERT there is a line now. In the NCERT, Sanjay, this session, right, Sanjay, the number of diagram based questions can vary in the NEET 2023 exam, right? It is not fixed, but with the help of diagrams we have revised the entire class 12 syllabus. You should focus there. Your PCR, transcription, topics like that we have revised. Done? So here this fungi farm, this line is from NCERT, this is what you need to focus. Rest you can see the global diversity representing here. So proportionate number of species of major taxa. So here you can just focus here. See, insects are more, we already know that. Then mollusca, then other animal groups and crustaceans. In the case of vertebrates, so you can see the fishes, look at their numbers. Then comes the mammals, birds, reptiles and amphibians. And here fungi, mosses, ferns and allies and angiosperms. So sometimes, you know, they ask questions from this part. So according to me, right, this is my opinion, if they will ask you this question, they will ask you such type of question in B section. So in B section, you people used to have options as well, right? So if you find any such question na, and if you are not sure about the answer, skip it, go for another question. Okay, skip it and then go for another question. Is that okay? Is that okay? Then this is that S is equals to CAZ, species area relationship, right? Alexander Humboldt, he has given that S stands for species richness, C is what? A is for area, Z is for the regression coefficient and C is for the slope on y-intercept. Y-intercept, C is basically the y-intercept. So here you have to remember that species area relationship. This is basically rectangular hyperbola. And when we take it on a log scale, we get a straight line. On log scale, we get a straight line. Then it becomes a log S is equals to log C plus Z log A. So what is Z here? It is the regression coefficient. It shows the relationship between two variables, regression coefficient. So this species area relationship is saying that when we increase the area that we want to explore, then initially the species richness is there, but only up to a certain limit. Only up to a certain limit. Like from A to B you are moving, like initially you have decided you will go for the 5 kilometer, you started for the 10 kilometer, okay, species richness will increase. Then for 15 maybe all species richness will increase, but later on it is not going to change more. Right, but if you will take the entire continent, then obviously you will see the difference. Then the slope will get steeper. Then this line will get steeper if you will select the entire continent. Otherwise, for different taxa, it is going to be same. So we take the value, remember, 0.62, 1 point something, remember? So this is what you need to revise from NCERT. So the next part here is, bache, this electrostatic precipitator. You can say that dirty air is coming. This is the example of a scrubber. So it is the electrostatic precipitator, ESP, electrostatic precipitator. So from this scrubber, dirty air is coming, particulate matter is present. So here we have watery lime spray and the clean air will go. But you have to focus here on this part. This is the scrubber only, as for scrubber, right, dirty air. But here it is for the electrostatic precipitator, that is ESP. So in electrostatic precipitator, we will talk about the corona. The dust particle will be charged. The dust particle will get electrons in the surrounding. Here we will be having some plates. That plates are going to capture that dirt particle if we want to purify the air. So dirty air, it will pass here from these two roads. You can see here the dust particles will get charged, the discharge corona is there. Now when it will pass from this collection plate grounded, so dust particles will be captured. This is what you need to do. Okay? Okay? Bache, whatever is important I have covered here. And this is for the dissolved oxygen. Remember again from environmental pollution, dissolved oxygen. So remember one thing, if BOD is high, high BOD is indicating high water pollution, and when BOD is high, water pollution is high, at that time dissolved oxygen is less, right? Dissolved oxygen is less. High BOD means aerobic bacteria is using that oxygen to, decompose the organic matter present. So here you can see concentration, the sewage will be discharged. This is the flow of the direction. So when, just look at this, this is important please. So when the sewage will be discharged, if sewage will be discharged in the water, bache, if sewage will be discharged in the water, what is going to happen? The BOD will increase all of a sudden, yes or no? So here you can see, when the sewage discharge is there, BOD will increase because the organic matter has increased. So if BOD is high, the dissolved oxygen will suddenly come down. And slowly when dissolved oxygen will increase, BOD will come out. This is what you need to understand. So when BOD is high and DO is come, fish kill, there will be the disappearance of clean water organism, and when again dissolved oxygen will high, reappearance. Very easy, very simple. So ultimately this is what you need to focus: high BOD, high water pollution, less DO, less dissolved oxygen. Okay, then biomagnification. With each trophic level, the toxic material that has accumulated, its concentration will increase. Biomagnification. Biomagnification, the best example is of DDT, right? So you can say that in water DDT is 0.003 ppb, parts per billion. Important it is, parts per billion. Question will come from this part for sure in the NEET examination. Then zooplankton DDT 0.04 parts per million. Here parts per billion, then parts per million. Then next is small fish 0.5 parts per million. Large fish 2 per million parts per million, and then fish eating bird 25 parts per million, because it will get accumulated, it will not be the part of metabolism, it will not be destroyed. So this is done. Okay, so this is the contribution of greenhouse gases. The maximum is CO2, then comes the methane, then comes the chlorofluorocarbons, and finally the N2O. Obvious questions of NEET examination. Obvious questions of NEET examination, right? And yes, one more thing I would like to quote from this part, right? Once a question was there from this description, like here, ozone hole is the area above Antarctica shown in the purple color, where the ozone is the thinnest. So ozone thickness is given as Dobson unit. So this, about these Dobson unit, you will find nothing in the theory. You will find nothing in the theory, right? Dobson unit, it is given here only. So Dobson unit is used to measure the thickness of ozone. Measure the thickness of ozone. Right, bache? Right, thickness of ozone. So this is what you need to focus. This is what you need to focus. So I have covered all the diagram, and the diagram, the flowchart of that animals that you are asking from evolution, not that important. Okay, it is mentioned in chemistry but not here in biology. Okay, so do you want break or what do you want? Tell me. Tell me. Tell me. Dobson unit, it is a PYQ. No break. 'Huh, I need a break. I need a break for 15 to 20 minutes. You tell me about yourself. What do you want? So the session was beneficial, na? It is beneficial. Isn't it? It is beneficial. $30 break, okay. Then 11th, or you want a separate session for class 11th? Do you want a separate session for class 11th, or it's fine if I continue? Other than break, tell me na. Class 12th, all the topics are covered. For strategy for enhancement in food production, you just need to check that tables, you just need to revise that examples. Okay, let's take a break for separate, continue, chalo, we'll take the poll, we'll decide accordingly. So as of now, you can enjoy your break time till 8:30 p.m. okay. Enjoy your break. Bye bye. everyone. Hello. How are you? How are you everyone? Welcome back again. How are you doing? Fine. So you people are done with your dinner and all? Huh? I hope now you don't need the break. Now we have to finish the class 11 diagrams in one shot, right? And I'll be very quick. Okay. And we'll cater the most important chapters. Okay? Okay? Okay. But before that, I need to tell you something important, of course. Just allow me a minute. So, yes, we have already completed the class 12 diagram. Now, I am going to start the class 11 diagram. But before that, I need to tell you something very, very, very important. See, I hope you all have checked this particular video. That we have, me and Wasim sir, we have posted at 1. Do check this video, bache. In this video, we told you that how can you guys, can get 600 marks. If you are scoring 300 marks, how you people can score 600 marks, that we have explained here in this particular video. And the most important thing is, bache, just look at this. Just look at this particular session. Just a minute. See. Just check this particular session. Here in this session, we will take a session on top 1000 questions, right? Top 1000 questions we are going to discuss here, bache, in this particular session. And you know what? From these 1000 questions, you people can easily expect 100 plus questions. 100 plus questions in the same way you guys can expect in your final NEET examination. Do you know about this session? The top 1000 questions. So first of all, just go and like this video. Like this video if you want us to take this particular session. Top 1000 questions, bache. Imagine top 1000 question, nearly 50% question of biology we are going to practice here. You can say that 300, 400 questions from chemistry, then from the physics. So can you think that out of these questions, do you think that any question can come in your final exam? Right? We are going to cover the entire syllabus in this particular session. Entire syllabus we are going to cover in this particular session, right? So first of all, just go to this session and just like the video. I don't know what I have done. See, just go to this video and like the video. Quick, go and just like this particular video. I want to see the likes here. All of you, just go and like this particular video, that yes, we want these top 1000 questions wala session. We want to make sure that we want to ensure our 100 plus guaranteed questions. So go and just like the video. See, only 120 likes are here. The number should be 600. 600 students are watching my session. So here also the number should be 600. All of you just like this particular session, guys. Like this particular session. And I know you want us to take this particular session. I think you all have seen our most predicted paper, right? Most predicted paper. In that paper, very good questions were there from the previous year NEET papers. And same type of questions will be there in this particular session. We will include assertion and reason. We will include statement-based question. Diagram-based question will be there in the biology. Right, bache? As per the NEET pattern, we are going to ask the question in this session. So increase, the likes should be more here. Just 200, yeah, just 200. Nahi, it should be more than 600. It should be more than 600. See, all of you, just go and like the session first. Go and like the session, quick. Formula revision session will be there for sure. But firstly, like the session, then I'll start the class. Right, then I'll start the diagram revision. Firstly, like this particular session, all of you, many students are here in my session, right? They are waiting to start the session now. So I'll start it, but before that, just like this session. Go. The duration of the session will be 3 hours or 4 hours. Okay. Thank you so much for that, Nishant. Just a minute. Done? Done? Sure? So just click that notify wala bell. Yes, just click here. Click here. Right? Click here, bache. This session is going to be very amazing. See, top 1000 questions from your entire syllabus. It will be just like a final shot of revision. Final shot of revision. Right? From physics, from chemistry, from biology, the entire syllabus will be covered here. So if you are feeling bored, just open this channel, just check out this session and just start solving the question. In this way, you will utilize your time in a better way. Right? So this session is going to be very, very, very important. Wazeem sir, HSP sir, and even your Shreyas sir, they are, till now they are sitting in the office and they are planning the question for this particular session. That what type of questions we can keep. As per their experience, they are adding the question in this particular session. So that is what you have to do. Okay. Okay. So do like this, do share this session with other friends also, and click here, notify me, click here on this button. Okay. So now I am going to start the session. Okay, let's start the diagrams again. Let's start the diagrams again. So tell me in the chart section from class 11th, which one is your favorite chapter? Firstly, tell me in the chat section. Okay, so till then the PDF will even the PDF will upload here till then. So you guys can tell me your favorite chapter from class 11th. Just tell me your favorite chapter from class 11th. Ma'am, is that each subject carries 250 marks? No, it's not like that, Monisha, but we have distributed the number of questions in such a way. Can I get 500 plus marks if I continue your channel? Definitely you can, but along with that, you need to solve the PYQs. Acha, animal kingdom is your favorite chapter. Human physiology. I have completed the human physiology. What else? Cockroach. Seriously, cockroach is your favorite. From cockroach, only one question used to come in the exam. So if you have completed it earlier, then it is fine. You should revise the cockroach. Otherwise it is my suggestion, you can skip that topic. If you have revised it earlier, then it is very good. But if not, then you guys can skip it. The living word. Seriously, Gokulan, living word, very easy chapter. Very, very, very easy chapter. What else? Human physiology. What about the plant physiology? Don't you people like plant physiology? Last year, 13 questions were there from plant physiology and 12 questions were there from human physiology. Guys, what is happening? Okay. I don't know now what is happening. Finally, we got the diagrams. Done? Human physiology. I know human physiology, cell cycle and cell division, one of my favorite chapters. Biomolecule. Biomolecule is my favorite chapter. Genetics, though, it's fine. I'm asking the topics from the class 11th only. From the class 11th only. Okay. So, now let's start the revision of class 11th syllabus with the help of diagrams. Okay, with the help of diagrams, we are going to revise the class 11th. Okay, so now see guys, many of you are thinking that ma'am is only teaching the diagram based question. It is not like that. Diagrams are the best way to revise the biology. This is what I believe. Same type of things are in the case of your chemistry, especially in the case of inorganic chemistry, even in the case of biology, mind maps they help. Mind maps they help for the revision. So similar type of session will be taken by HSP sir tomorrow morning at 11, in which he is going to teach you he is going to revise the entire inorganic chemistry. So do check that video, right? Me and Wasim sir, we have posted it at 1 p.m. Do check that video. In that video, we have shared the plan. We have even mentioned the details of the test series as well. So definitely, if you follow our channel, definitely you are going to score good marks. But one condition is applied. You need to apply all that info in the final NEET exam also. Okay. So initially when I came back now after the break, so at the time I was a bit anxious. I was just planning that how to continue the session, this and that. So now I'm totally calm and I'm going to proceed. Okay. So I'm expecting same thing from you people. Okay. So I will not stretch this session much. I will try to finish it in 2 hours. I need your 2 hours. I need dedication for that particular time. Are you guys in? Jay Shri, ma'am, is it only biology? No, top 1000 questions from physics, from chemistry, from biology, and this session is going to be very, very, very amazing. I hope you guys have checked our most predicted paper wala session. That session was so good. In that session, the questions that we have asked, all the questions are from PYQs or they are the most expected question. Same thing we are going to do in top 1000 questions. Just imagine, in your NEET paper, you have to attempt 180 questions. You people need to attempt 180 questions and we are providing you the question bank of 1000 questions. So don't you think that from that 1000 questions, 180 questions can come? Don't you think so? You tell me, don't you think so, bache? If you are going to practice 1000 questions, the number is very big, 1000 questions. Don't you think that 180 questions can come from that 1000 questions? Definitely they can. Definitely they can. But for that, you really need to like that session. We want that enthusiasm in our students also, right? Right? Seriously, Wasim sir, HSP sir and Shreyas sir, they are still sitting in the office. They are just planning the question, the type of questions they are going to ask in this particular session. Okay? Okay? So, do support us. So, now without wasting the time, already I have wasted your 3 to 4 minutes, but without wasting the time, now let's continue the session, guys. So, I know after the break, we do not have the same flow, but we will make it, definitely. So, I want to see the high chat rate. I want to see the high chat rate. I want to see the energy in the chat section first. Quick, everyone, quick. So, we are going to start with the biological classification. We are going to revise the diagrams of biological classification. But before that, I want to see the energy in the chat section. Guys, be quick. See, plant physiology, I have already taken. Human physiology, I have already taken. Cell cycle and cell division, I have already taken. Whatever chapters are remaining now, firstly, let's cater that chapter. Okay, let's cater that chapter. So, this topic seems very easy. But yes, once a question was there from this particular topic. And I want the same type of question in NEET 2023 because it is the easiest question ever. The shape of the bacteria they are asking. So, coccus, spherical, coccus, the best example, streptococcus. The best example, streptococcus. Then comes the bacillus, bacilli. It is the rod-shaped bacteria. Then comes the spirilla, right? Spirillum. And when it comes to the vibrio, vibrio means comma-shaped. So, yes, this topic is simple, but question can come from this particular part. Now, here we have the next diagram. The next diagram is of the nostoc. So, what is nostoc? You know that it is BGA. It is a blue-green algae. It is the cyanobacteria. What is it? It is the blue-green algae. It is the cyanobacteria. It is the photosynthetic bacteria. And what you have to remember from this particular part, guys, just look at it. Just look at it. See, so many cells are together and it is covered with the mucilaginous sheath. So, the important thing here is this heterocyst, right? It's a different cell. Here, this heterocyst is responsible for the N2 fixation. Remember yesterday I took a session on that plant physiology where we have discussed the biological nitrogen fixation, one of the most important topic. So just look at it. This heterocyst is responsible for nitrogen fixation. In this heterocyst, bache, PS2, photosystem 2 is absent. So photosystem 2 is absent, no oxygen will be produced. No oxygen will be produced. The nitrogenase enzyme will be able to work. Do you know about the enzyme nitrogenase? Do you know about the enzyme nitrogenase? It is the one which is going to fix the atmosphere, which is going to fix the nitrogen. But this enzyme requires anaerobic conditions. So, how will that anaerobic conditions be created? As I said, PS2 is absent here, oxygen will not be there. So, nitrogenase will become active, right? So, nostoc. Now, the next part, the next diagram. So, you know that it is just a dividing bacterium. Okay, and here the examples. Here we have the examples of kingdom protista. Guys, now I'm going to give you the trick. Are you ready for the trick? Are you ready for the trick? Whatever points I'm going to cover, they all are the most important points. So tell me, are you people? Are you people in? Are you people in? All of you guys, be quick. Right, so there is a trick for you. You know that we have 5 kingdoms. We have kingdom Monera, we have kingdom Protista, we have kingdom Fungi, then comes the Plantae, and then comes the Animalia. Then comes what? Then comes the Animalia. This is what we know, isn't it? This is what we know. So when you talk about the Monera, you know that the bacteria will be there in Monera. All the prokaryotes are there in this kingdom Monera, right? And in the Protista, all the unicellular eukaryotes are present. All the unicellular eukaryotes are present when we talk about the kingdom Protista. So in kingdom Protista, there is a trick. In kingdom Protista, what do we have? We have a trick here. The trick is CDESP. All of you just repeat it in the chat section. It is CDESP. It is CEDESP. It is CDESP. Just repeat it in the chat section and be quick, guys. CDESP. 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 Just repeat it in the chat section. C stands for chrysophytes. D stands for dinoflagellates. E stands for euglenoids. S stands for slime molds. P stands for protozoa. So here you guys can see the dinoflagellate. The dinoflagellate is having what? It is having the obviously flagellum. Obviously flagellum. Right. So dinoflagellates, they are having the flagellants. Dinoflagellates, they are having the heterocont flagella. Right, they are also known as whirling whips. Their one flagella is transverse, the another flagella is longitudinal. Right, but dinoflagellates they are. Dinoflagellates they are. Here you guys can see B. Right, what is happening here? Okay, here you guys can see the B, euglena. And euglena, you know that. Euglena is a connecting link in between plants and animals. It is a connecting link in between plants and animals. This is having the chloroplast as well and a mouth as well. And here we are having the slippers organism, and that is paramecium. What is it? It is the slippers organism. It is the paramecium, and obviously without any doubt it is the amoeba. So examples are important. So what you have to remember, CDESP. It is a flow. Chrysophyte include diatoms and desmids. Then your dinoflagellates, then euglenoids, slime mold, protozoa. Is that clear? Is that clear? Revant, ma'am, are you, first of all, are you married? And I think that type of questions are not going to come in the NEET examination, Revant. Hai na? Okay. So here we have the example of fungi, the mucor, the dung mold it is. The dung mold it is. Are you getting it? Then comes the aspergillus. Aspergillus is what, bache? Aspergillus, Ascomycetes. Aspergillus it is. Right, it is also known as the weed of the lab. Aspergillus. Citric acid is obtained from it. Do you remember this? Citric acid is obtained from it. And then comes this mushroom, agaricus. Now again, I have one trick for the kingdom fungi. Right, for the kingdom fungi also I have one trick, bache. Pineapple with dates. What is the trick? Pineapple with dates. What is the trick? Pineapple with dates. Now guys, are you now experiencing the same flow or not? Are you people experiencing the same flow or not? Hannah? Some students were saying that, ma'am, after the break, we do not feel that the same class is going on. We don't feel that energetic. Now tell me. Now tell me. Are you people experiencing the same energy, the same flow? Thoda flow is back. No. Pura flow is back. Physical chemistry, I think it's already done. Huh? Guys, quick. See, you have to be active in the chat because I'm asking the question. So I want to see that energy in the chat section. You know, I really want to appreciate one thing here, that students, they do not spam, they answer the questions here. I really like it. Only few spammers are there, otherwise all the students, they answer here. I'm happy that whosoever is attending our session, they are here to learn something, right? They are here to learn something. This is what I appreciate about you people. So very good. I am so proud of you. Right, I'm literally proud of you, and I really wish you all the best, guys, and I know you will make it. For sure you will make it. Right, just give your best. Now come to this particular trick. Here we are talking about the kingdom fungi, and the trick here is pineapple with dates. Pineapple with dates. So here this P stands for Phycomycetes. A stands for Ascomycetes. right bache? B stands for Basidiomycetes, and here we have the D. D stands for Deuteromycetes, and you know that it is the fungi imperfecti, imperfect fungi, because no sexual stages are present here in the case of Deuteromycetes. Are you getting my point? So it is the algal fungi, Ascomycetes. Yeast belongs to Ascomycetes, right bache? And this is the Basidiomycetes, Basidiomycetes. Okay, okay. Now this part, this diagram, you know that it is TMV, that is tobacco mosaic virus. So what you have to remember here, it is the RNA virus. What is it? It is the RNA virus. And here in this virus also, see, many capsomeres. Do you know that many capsomeres together, they form the capsid. There is a protein coat in the case of viruses. Viruses are having the genetic material, right? It can be RNA or it can be DNA. It can be RNA, it can be DNA. Yes. I just got one thing. Do you know that in the NCERT it is mentioned that we have that either we have the DNA virus or we have the RNA virus. Do you know about it? Either we have the DNA virus or we have the RNA virus. Do you know about it? Tell me quickly. I am going to ask one question from you people. Right? I am going to ask one question from you people. Tell me. Tell me. Tell me. Right? In the NCERT it is mentioned, either the DNA virus is there or the RNA virus is there. Right? Either the genetic material will be DNA or there will be the RNA. But you know there is one exception, and that exception is leucovirus. Leucovirus is an exception to it. Right? It is having both DNA as well as RNA. Okay, it is an exception having both DNA as well as RNA. So this is something important. I thought I should share it with you. Right? Right? So guys, quickly like the session and subscribe the channel if you are new to our channel. Okay? Okay, it can never be both, but there is one exception. There is one exception, and it is a PYQ. It's a previous year question, guys. Okay? So I was talking about the capsomere, right? I was talking about the capsomere, right? So capsomeres are just like monomers. So many capsomere together, they will join and they are going to form the capsid. They are going to form the capsid. This is what you need to remember. And here you guys can see the bacteriophage, the double-stranded DNA virus. It is having this protein coat, the head part, the collar, and these are the tail fibers, right? Diagrams are important. Now let's move to our favorite chapter, that is the plant kingdom. That is the plant kingdom. And guys, have you checked that video in which I have posted the tricks to revise the plant kingdom in less than 10 minutes? Right? Did you check that? The video in which I have mentioned that revise the plant kingdom in less than 10 minutes. Revise the plant kingdom in less than 10 minutes. Right? So, if you remember the trick, SUV, Chal, Kara. Right? S stands for Spirogyra. U stands for Ulothrix. Right? V stands for Volvox. Do you remember that? CHL stands for Chlamydomonas. And then we have the Kara, which is itself is a green algae. So if you are watching this session from the starting, in the reproduction in organism chapter, I have mentioned all that things, isn't it? I have mentioned all that things, Nirmala. Nirmala, do check that video, Plant Kingdom in less than 10 minutes. Trust me, all your doubts related to the life cycle, related to the examples will be cleared. Okay, so these are the example. This is the trick for revising the green algae. So here we have the Volvox. Volvox is the colonial algae. In between it is having the daughter. Daughter colonies. We use the word synobium for that. And again, it is the filamentous one, bache. You can see it is the Ulothrix. Right, Ulothrix. Now look at this brown algae. For brown algae, do you remember the trick? Do you remember the trick for the brown algae? Do you remember the trick for the brown algae? Anyone in the class? Trick for the brown algae? Anyone in the class? I have shared one trick related to this also now. Seriously, don't you remember that? Guys, you should seriously check that video. The trick was self-DP. So S stands for, yes, S stands for sargassum, isn't it? E stands for Ectocarpus. L stands for laminaria. F stands for fucus. D stands for dictyota. And P stands for the brown algae, for the Phaeophyceae. It is for the Phaeophyceae. So the trick here is self-DP, self-DP. So you can just have a look of this brown algae. The brown color is because of the pigment fucoxanthin. So here in brown algae, you will see this hold fast for the attachment. You will see this strip stipe. You will see this frond, right? It looks like a leaf. So you can see this. This is the laminaria, this is the fucus, and this is the dictyota. So what you need to focus here, bache, this fucus is the one having the air bladder, right? So if air bladders are present, means buoyancy is there. If air bladders are present, means buoyancy is there, isn't it? Buoyancy is there. Moreover, fucus is an exception. Usually algae is having the haplontic life cycle, but here it is diplontic. Here it is diplontic. Then dictyota, dichotomously branched. Dichotomously branched it is. So this is what you people need to remember. It is the brown algae and the chlorophyll present is A and C. Brown color is because of fucoxanthin. Is that clear? Brown color is because of fucoxanthin. Is that clear? Done, bache? So now let's have a look of this red algae. For red algae, the trick is P2G2. Right, it is P2G2. Type this in the chat section. The trick for brown algae is P2G2. Just type it in the chat section, all of you. P2G2, P2G2, P2G2. Porphyra and Polysiphonia. Right, Geladium and Gracilaria. Geladium and Gracilaria. So red algae is the one in which A and D pigment is there. A and D chlorophyll is there. Red color is because of phycoerythrin. Right, stored food present is Floridian starch. It is Floridian starch. Red, rhodophyceae. So Floridian starch. Okay, is that clear? Is that clear? So next is the bryophyte. My first place secure. Okay, my first place secure. So M stands for Marcasia here. Marcasia here. Right, bache. F stands for Funaria here. Right, this is for the examples. P stands for Polytrichum here. Right. So S stands for, I just forgot, S stands for, guys, S stands for M Marcasia, F Funaria, P is the Polytrichum, and then S stands for, I just forgot, you know the answer, some peat moss or something. Some peat moss, very good Rexenite. Excellent, bache. It is sphagnum, the peat moss. And Marcasia, we have already discussed in the reproduction in organism. You know that male and female are having the different thallus. So we can say that it is dioecious, right, bache. Rhizoids are there which will help in the attachment. Gemma cup is there for the asexual reproduction. So this is what we have studied so far. So any doubt from this part? Any doubt from this part? So after the class, do check that plant kingdom revision in less than 10 minutes wala video. Okay, do check it out. Done, bache. So now next is what? Again, the Funaria, I told you about it. Right, so you can see here, this is the peat moss. So when it comes to the peat moss, anthradial, archegonial. So basically it is monoecious, it is bisexual. Right, so sphagnum used to form, it is also known as peat moss, it used to form peat. Peat acts like a fuel, peat is meant for the water retention as well. Okay, it is meant for the water retention as well. And here we have the Funaria, gametophyte, sporophyte. So here in the case of bryophytes, you know that haplodiplontic life cycle is there, bache. Haplodiplontic life cycle is there. And here the gametophyte is the dominant phase. The gametophyte is the dominant phase. It is dominant, photosynthetic, right, and sporophyte is dependent. It is dependent on gametophyte. Is that clear? Any doubt from this part? So whatever points I have mentioned now, bache, so that points are important from examination point of views, right? Right? That points are important from examination point of view. So do mention it. So again you can see the pteridophytes. So pteridophyte mein the trick is please tero. Please tero. Okay, xylotum is there, Lycopodium, selaginella is there, right, bache. The pteris, Dryoteris, edientum is there. Okay, edientum is there. Okay. Okay. So here you guys can see pteridophytes. So you know that they are the first successful land plants. What are they? They are the first successful land plants. Okay. So we consider them as tracheophytes. We consider them as tracheophytes, right? In their case also, the life cycle is haplodiplontic. But here, the beautiful thing is that sporophyte and gametophyte both are independent. Sporophyte is the dominant phase, but gametophyte is also independent. It is not dependent on sporophyte. This is what you need to remember, right? So if I am mentioning the word tracheophyte, it is showing that it is having the vascular tissue, it is having the xylem and phloem. Is that okay, guys? Is that okay? Is that okay? So here you can see the equisetum, horsetail, and here so many sporophylls together, they are making the strobilus, also known as cone, right? They are condensed, they are forming a condensed structure. Very good, alum bache. So it's a tracheophytes, but it is not showing the steed habit. So we can say that it's a cryptogam. Okay, cryptogam. Cryptogams having vascular tissue. Cryptogams having vascular tissue. Is that clear, bache? So now here you can see the fern, the salvinia is there. And do you remember one more trick? He, see, saw. He, see, saw. Do you remember this trick? He, see, saw. Guys, chemistry formula revision will be there soon. Now we are revising the biology. Biology is making 50% of the syllabus. So we really need to revise it again and again. And you know that it is a theory based topic, right? Right, we have so many things that we need to mug up. So many things are there that we need to revise. Examples are there. Of course, examples are there, right? So guys, please show some energy and do check our top 1000 questions, wala session, right? Do check that 1000 questions wala session. Let me check the number of likes in that session. Number of likes are still less, right? It should be more than 500. See, more than 500 students are watching my session. So please go and like that video. Top 1000 questions in which your entire syllabus will be covered, and we believe that from that 1000 questions, definitely 180 question will come in your NEET examination. Right? Go and like that video, bache. Top 1000 question. Go and like that video. Okay? Okay. So now come to this topic. He, see, saw. So he, H, heterosporous. It is heterosporous. S stands for Selaginella. S stands for Salvinia. So these are the example of these are the example of pteridophytes in which different type of spores are there. Right, bache? Done, bache? So the next session, next topic is gymnosperm. So here we have the example of Cycas, Pinus, Ginkgo. Cycas, Pinus, Ginkgo. So when you talk about the Cycas, bache, so Cycas is what? When you talk about the Cycas is what? Living fossil. Right, Cycas is what? Living fossil. And in the case of Cycas, remember this thing. Cycas is what? Cycas is dioecious. It's a living fossil, dioecious. C for Cycas, C for coralloid roots are there. Coralloid roots are there. Right, bache, it's a good way to revise, isn't it? It's a very good way to revise, isn't it? Isn't it? So coralloid roots are there, dioecious it is the living fossil. In coralloid roots, the photosynthetic bacteria is there in the symbiotic association. Now, the next is what? The next is the Pinus. So in the case of Pinus, remember it is monoecious. Male and female cone is present on the same plant body. Right, so it's a xerophyte, it is having the needle-like leaves, thick cuticle is there, sunken stomata is there, such xerophytic adaptations are present. And again, this is bache Ginkgo biloba. Ginkgo biloba is again the living fossil. Ginkgo biloba is again the living fossil. Is that clear? Is that clear? Now just look at this angiosperms, a dicot and the monocot. Dicot having two cotyledons, monocots having single cotyledon. We have already revised it in sexual reproduction in flowering plants. Now come to the life cycle of an angiosperms. I really don't think now you will find it difficult. Right? We started the today's session from sexual reproduction in flowering plants, and I told you each and everything there. But still, let's have a quick revision of it. But in gymnosperms and in angiosperms, diplontic life cycle is there. Like main plant body is diploid. Main plant body is sporophytic. Main plant body is diploid. Main plant body is sporophytic there. So you can see the sporophyte plant, right? Now you know that flower is present there. So flower will have the male part and the female part. So this stigma style ovary, pistil, also known as carpel, female part, megasporophyll, and that anther and filament, the stamen, the male part, microsporophyll. So obviously within the ovary, ovule is there, within the ovule, development will be there, embryo sac will form, all the details we have already covered, right? Okay, now focus here. Acha ma'am, I saw the video of Shreyas sir, Wazeem sir and yours childhood. Okay, fine. But now guys, focus here. Let's not waste the time. Otherwise, even I will be distracted. Okay. Guys, number of likes are still less on that top 1000 videos wala session, right? In that session, the number of likes, they are too less. Go and like that video, top 1000 questions. Go and like that video. And please tell me in the comment section that you have liked it. Okay. So, now come to this part. So, here you can see megasporangium is ovule. Again, a PYQ. Microsporangium, right, bache? Microsporangium is there. Right, so here further the microspores will form, the pollen grain will form. So the pollen grain is what? It is the male gametophyte. Pollen grain is what? It is the male gametophyte. Are you getting it? Are you getting it? And then here you guys can see the male gametophyte, the gametes, all that process. So do you have any doubt in this topic? Do you have? My one shot is released. Which one shot? No, I didn't post that. I'm just saying that day after tomorrow, I'm going to take one session. We are going to take one session for physics, chemistry and biology, top 1000 questions. Go and like that session, guys. Okay. So, I hope it is clear to you. Now come to this part, that is the haplontic life cycle. What is it, bache? It is the haplontic life cycle. See, haplontic is the word. What is the word here? Haplontic life cycle. Haplontic is the word. Haplontic means haploid. Manjunath, all the best, bache. Please focus here. Do not spam here. Please focus here, right? So, haplontic, haploid is the word. What is the word? Haploid is the word. So, here the dominant phase, the dominant photosynthetic phase is the haploid phase. So, if haploid phase is photosynthetic, if it is dominant, means here we are talking about the gametophyte, kids. Here we are talking about what? We are talking about the gametophyte here. We are talking about the gametophyte here. What are we discussing here? We are talking about the gametophyte here. Are you getting my point? Are you getting my point? So, it is the gametophyte which is dominant. It is the gametophyte which is photosynthetic. Done, bache? So, in the case of algae, the main plant body is going to be haploid. That thallus is haploid. This is what you need to remember. And what is the second point here? What is the another point here? The sporophyte, which is a diploid phase. It is just zygote is the only diploid cell, right? It is the zygote which is the only diploid cell of sporophytic generation. Are you getting it? It is the zygote which is the only, right? It is the zygote which is the only diploid, right? It is the only diploid stage of this haplontic life cycle, right? What is it? It is the zygote. What is it? It is the zygote. Is that clear, everyone? Yes, is that clear? Is that clear? Yes or no? Yes or no? So, here you guys can see. So, it is the zygote which is the only cell of the diploid generation. So, this zygote will undergo meiosis. So, we even call it as zygospore. So, when zygote, it is undergoing the meiosis, we even call that zygote as the zygospore, right? As the zygospore. Clear? As the zygospore. Is that clear? So, zygote will undergo meiosis. After that, the spores will form. They will germinate. Gametophyte will be there. And further, mitosis will form the gametes. Then here we have the diplontic life cycle. Right? What do we have here, bache? Just a minute. We have the diplontic life cycle. What do we have here, bache? We have the diplontic life cycle. Are you getting my point? So, in the diplontic, di means diploid. So, here the main plant body, here the main plant body is diploid. It is the sporophyte. It is the sporophyte. Are you getting it? It is the sporophyte. And here the gametophyte is dependent over the sporophyte. Gametophyte is dependent over the sporophyte. Is that clear? It is dependent over the sporophyte. But in this way, you guys can revise your entire syllabus. Right? Be sincere, please. Guys, be sincere. In this way, literally, you can revise your entire syllabus. You will realize that whether you know the things or not. Right? Please focus here. Please focus here. Done. So, next is the haplodiplontic. Next is the haplodiplontic, and in the case of haplodiplontic, it will be there in bio and gymno. I already told you. Next is the animal kingdom, bache. So, now let's revise the things from the animal kingdom. Okay, let's revise the things from the animal kingdom. So, are you ready for that? Yes, animal kingdom. Quick. Sana bache, many PYQs will be covered in the 1000 question wala session. So, obviously, it is obvious. It is obvious that many questions will come like that only. Okay. Done? Yeah, we are studying. Acha, Shreyas sir is here. Oh, Shreyas sir, I told them that you people are still in the office and you guys are preparing the questions. Right, for the top 1000 sessions. And even tomorrow he is going to take the session on the complete formula revision of physics. Again, a very important session. Okay, so next is the animal kingdom. So, in the animal kingdom, what we need to remember, first of all, the name of the phylum should be clear in your head. So, guys, you are going to type the name of the phylums, right? You are going to type the name of the phylum in the chat section just now. Remember, Porifera, Cnidaria, or even if you don't want to type it in the chat section, just revise, just recall it with me. Porifera, Cnidaria, Ctenophora, Platyhelminth, Aschelminth, Annelida, Arthropoda, Mollusca, Echinodermata, Hemichordata, Chordata. The name of the phylum should be there in your head, and it should be in that in a proper sequence. So how are we going to start? We are going to start with the Porifera. Porifera, Cnidaria, Ctenophora, Platyhelminth, Aschelminth, Annelida, Arthropoda, Mollusca, Echinodermata, Hemichordata and the Chordata, right? So the basic, the simplest phylum here is the Porifera. Pore-bearing organisms are there. So there are certain characters which we consider under basis of classification. On the basis of that, we divide it, right? We divide the animals into different phylums. Okay. Okay, like we talk about the germ layers, we talk about the symmetry, we talk about the level of organization. So the basic is level of organization, then symmetry, then germ layers, then coelom, even the segmentation, even the what we used to call it, notochord and all. On the basis of that we divide it. Okay, bache. So here, right, let's revise it with the help of these images. So here the first question is from the symmetry, right? But before that, let me tell you about the level of organization. So in the case of animal kingdom, right, in the case of animal kingdom, you know that cellular level of organization is there, tissue level of organization is there, organ level of organization is there, and organ system. So what you need to remember here, kids, just focus on one thing here. See, its cellular level means we are talking about the Porifera only. Right, phylum Porifera is there when it is the cellular level of organization, because in Porifera only the multicellular body is there, even tissue formation is still not there, right? Then comes the tissue. In tissue, next two phylums, your Cnidaria and Ctenophora will come. Then when it is the organ system, it is the Platyhelminths, right? It is the Platyhelminths, and in organ system, it is going to be the Aschelminths. It is going to be the Aschelminth. Is that clear? Is that clear? So from Aschelminths to your Chordata, all will come under this organ system level of organization. This is the first point, right? Now here we are talking about the symmetry. Guys, symmetry, very easy it is, right? It is very, very, very easy. What you have to do in the symmetry part? See, one is asymmetrical. One is asymmetrical. Guys, 4 questions can come from the animal kingdom. 4 questions, minimum 4 questions you people can expect from the topic animal kingdom. 4 questions means 16 marks. So I think for 16 marks, you guys can focus for next 10 minutes. Yes or no? For 16 marks, I think you should focus for next 10 minutes. Yes or no? Yes or no? Quick. For next 10 minutes, I want you people to be focused, because we are going to revise the entire animal kingdom, right? The entire animal kingdom chapter. Right, bache? Is that clear? Done? Okay. So, we have three words. One is the asymmetrical, one is the radial, and then comes the bilateral. Right? Then comes the bilateral. Asymmetrical is there, radial is there, bisymmetrical is there. Asymmetrical means no symmetry. Like you cannot divide that body into equal halves. The best example is of porifera. But what is the point that you need to take care here, bache? Mostly poriferans, they are asymmetrical. You cannot say that all the poriferans are asymmetrical. Mostly poriferans are asymmetrical. Right, bache? Mostly poriferans are asymmetrical. So here we have two examples, like the cycon is there. One extra example, leucosolenia is there. So these are the poriferans which are having the radial symmetry. So I am even telling you the exceptions also. So no doubt, mostly poriferans, they are having no symmetry at all, mostly, but yes, we have the exceptions, the cycon and leucosolenia having the radial symmetry, right, bache? Now, when you talk about the radial symmetry, the phylum Cnidaria, the phylum Ctenophora, examples are important, kids, and then adult echinoderms. So if adult echinoderms are having radial symmetry, so we consider that entire phylum is having radial symmetry. In the echinoderms, we have that thing, we have that exception that adults are having radial symmetry, larvae is having the bilateral symmetry. So if adults are having the radial symmetry, so we will consider that entire phylum is having radial symmetry. This is what you need to remember. Okay, this is what you need to remember. So, and what about bilateral symmetry? So from your platyhelminths to that chordata part, bilateral symmetry will be there, right? Bilateral symmetry will be there. So what is the meaning of bache radial symmetry? Radial symmetry is the symmetry in which we can divide the body, right? The body can be divided into equal halves, right? Any plane which is passing from the center can divide the body into equal halves. Any plane which is passing from the center can divide the body into equal halves. This is the meaning of radial symmetry. And when you talk about the bilateral, bi means two, lateral means sides. So only one plane can divide the body into two halves, that is left and right. Only one plane. And when it is asymmetrical, no plane can divide the body. Okay. So next here is the germ layers, right? Germ layers. So bacha, you know it very well, the zygote. The zygote, the totipotent cell, it will grow, it will become multicellular. Then obviously the morula, the blastula, the gastrula will be there. So gastrula is the structure in which we will be having the germ layers. Actually, initially only cells are present, but that cells will undergo some movements, they are going to form some layers. That germ layers, right, that germ layers are going to give rise to the different organs. Are you getting my point? So when you people talk about the germ layers, we have three things. One is the diploblastic organism, another is the triploblastic organism. One is the diploblastic organism, another is the triploblastic organism. So kids, when the word is diplo, di, we are talking about the two germ layers here. When the word is tri, three germ layers here. So which two germ layers are there? The ectoderm, the endoderm. Three germ layer means ecto, meso and endo. Right, bache? So when you talk about the phylum Porifera, although as per NCERT we keep it in, right? We keep it in the diploblastic organism, but it is not actually like that. In the case of poriferans, we don't find the proper two germ layers, right? Right? So you can use the word pseudo-diploblastic for them. You can use the word pseudo-diploblastic for them. Are you getting my point, Yuvana? You can use the word pseudo-diploblastic for them. Poriferans are not truly diploblastic, but we have to go as per NCERT, so we are keeping it here. Otherwise, they are, you can say that they do not have even a germ layer. This is what we need to mention. So, porifera, then comes the Cnidaria, then comes the Ctenophora. Okay, these three phylums will come under the diploblastic organism. So, from platyhelminths to chordata, all the phylums will be there in the triploblastic organisms, right? So this is what you just need to remember. Are you getting my point? This is what you people need to remember. So you can put a sign mark over here in the porifera. Whatever explanation I have given, you can mention it. Now, just come to this diagram. So here you can see the outer is ecto, The inner is endo. Now, bache, the point here is, in between acto and endo, there is one more layer, that is mesoglia. Mesoglia is something undifferentiated. It is not even a cell layer. It is a kind of undifferentiated layer. Proper cells are not even there in this layer. It is the undifferentiated layer. Are you getting my point? And here it is triploblastic. 3 germ layers are there. Acto, in between meso, and then endo. So this is what you need to remember. So question is going to come from this part. Right, Abdur? So mesoglia is nothing. It is the undifferentiated layer. It looks like a jelly. It is not even a proper cell layer. And mesoderm is a proper cell layer. That's all. Done. So now here the next question is from the coelom. So what exactly is the coelom? Let's say there is an organism having tube within tube body system. Ramkumar, let's take one example. There is an organism having tube within tube body system. Now here in this organism, what is the scenario? Let's say this part is the digestive system, the alimentary canal. So in the case of triploblastic organisms particularly, let's say here this part is the outer body wall. So it is the outer body wall, it is ectodermal. It is ectodermal, right? So here it is ectodermal. This layer of gut wall, this layer of alimentary canal, this gut wall, it is basically endodermal in origin. It is basically endodermal in origin, right, bache? So now, if in any organism, right, in between this ectoderm and endoderm, in between this body wall and gut wall, if there is a space, plus that space is lined with the mesoderm. If there is a space, plus that space is lined with the mesoderm, like let's say here, this is the mesoderm, there is a space in between. So, in that case, we are going to say the organisms are coelomate. In that case, we are going to say organisms are coelomate. So, now just have a look, coelomate organism. Outer is the ectoderm, inner is the endoderm. So, there is a space in between outer ectoderm and inner endoderm, and that space is lined from both the side with the help of mesoderm. So, they are the coelomates. They are the true coelomates. Right? Here also we divide it into schizo and entero, but I will not go in that depth. And here, see, simple triploblastic. They do not have any space in between. So, they are acoelomates. Right? So, from phylum Porifera to platyhelminths. From phylum Porifera to platyhelminths, they are acoelomates. Right, bache? Now, see, when there are mesodermal pouches in between, here mesoderm is not lining the space properly, just the mesodermal pouches. So, they are the pseudocoelomates, false coelomates. What are they? They are the pseudocoelomates. They are the false coelomates. So, any doubt? Question is definitely going to come from these diagrams or from the examples. I am even covering the examples here, bache. Right? I am even covering the examples here, bache. Done, bache? So, next is this classification. Right? This flow chart. So, you know that we have already explained it. Right? We have already explained it. Done, bache? Without body cavity and all. So, that's all it is covered. So, these are the examples of the poriferans. You can see the cycon here. Right? You can see this euspongia, the bath sponge here. Right? And here it is the spongilla, the freshwater sponge. Remember? It is the spongilla, the freshwater sponge. So, guys, I want you people to type the name of the examples in the chat section and be quick. Right? Be quick. I want you people to write down the name of these phylums in the chat section, and you have to be quick, guys. Please be quick. Speed up, bache. Please speed up. So, we are talking about the phylum Porifera having the water canal system, and these are the diagrams of the example. So, cycon is there, euspongia is there, spongilla is there. Cycon is there, euspongia is there, spongilla is there. Are you getting it? Next is what? Next is the diagrammatic view of nidoblast. What is this nidoblast? Nidoblast is also known as, bache, nematoblast. It is also known as stinging cell. It is also known as stinging cell. So, we used to see this particular cell in the case of, right, in the case of phylum Cnidaria. You know that in the phylum Cnidaria, over the tentacles, we are having these cells. So, now in these cells, and let me tell you one thing, right, this is a discharged nidoblast. This is a discharged nidoblast, right, right. So, here in this stinging cell, there will be a stinging capsule. Just have a look of this part. This part, it is, although it is discharged, It is the stinging capsule. So within these stinging cells, there will be the stinging capsule, and this stinging capsule is basically the nidocyst. It is basically the nidocyst, or we can also call it as nematocyst. Are you getting it? So it is meant for the protection, for the encouragement. Okay, got it? Got it? So next, here the phylum Coelenterata. So if you remember Coelenterata, the TAM is the trick, bache. P stands for polyp, A stands for asexual, M stands for medusa, right? So phylum Coelenterata, also known as Cnidaria, it is the phylum in which you will see metagenesis. What is metagenesis? Metagenesis means alternation of generation. Alternation of generation. Alternation of generation is there, metagenesis is there. So polyp is asexually going to form the medusa. So polyp, P for plant, M for medusa mobile. So this type of structure, like your hydra, it is the polyp. Your jellyfish, it is the medusa. Right, bache? See, done? Done? So this is what you need to remember. Very good, bache, Rexenite. Excellent. So next is from your phylum Ctenophora. Next example is from your phylum Ctenophora. So it is pleurobrachia. Yes, pleurobrachia. Right, so these are the comb jellies basically. Here, right, it is a very, different character. Right, no doubt they are having the tentacles. No doubt they are having the tentacles. But not all the ctenophores they are having the tentacles. Not all the ctenophores they are having the tentacles. Actually, they are having comb plates. Like, let's say, like this. They are having the comb plates. Right, you can see the 8 comb plates here. They are having the cilia in that comb plates. Because of the presence of cilia, it looks like a comb. So that helps in the movement. That helps in the locomotion. That is why comb jellies, they are Ctenophora, they have the property of bioluminescence as well. Are you getting it? So usually the cilia for the locomotion, we used to see this feature in the lower, right, in the lower organism, but here still in animals we used to see it. So tentacles are not helping in the locomotion, it is the comb plates, it is that cilia which is helping in the locomotion. So this is what you people need to remember. So as I said, bioluminescence property is also there. And secondly, bache, they are exclusively marine. Exclusively marine. Okay, exclusively marine. So next example is from the platyhelminths, right? Next example is from the platyhelminths. So here you guys can see the tapeworm, right? The tapeworm Taenia solium, and this is the liver fluke. This is the liver fluke. So bache, when we consider the example of tapeworm, it used to show pseudo-metamerism. Pseudo means false, metamerism means segmentation. Right, so it used to show the pseudo-metamerism, the false segmentation. Here the segments are not embryonic, but from the neck region, the segments they will form. Okay, the segments they will form. Okay, so this is the example, and they are even the endoparasite. So this is the first phylum in which we will see the sexual dimorphism, right? The dioecious organism will be there. Female is long, you know that we are talking about the Aschelminths, we are talking about the Ascaris here. So guys, if you know the basis of classification, then everything is going to be very easy for you, right? If you people know the basis of classification, then trust me, the revision is going to be very, very, very easy for you, okay? Then the revision is going to be very, very easy for you, okay? Okay, got it? Got it? So, I'll mention one exception here. That is your homework. You need to answer the question in the chat section. In the case of platyhelminths, there is one exception, right, where you will see the sexual dimorphism. There is one example where you people are going to see the sexual dimorphism. Right, where you guys are going to see the sexual dimorphism. So you need to mention the name of this particular animal in the chat section after the class. In the chat section after the class, you have to mention the name, right? The name of this particular organism from the phylum Platyhelminths in the chat section, right? So next is bache Annelida. Annelida, the first phylum where you will see the true segmentation. The phylum where you will see the closed circular blood vascular system. So here you are having 3 examples. One is earthworm, one is leech, Hirudinaria, and another is Nereis. So what you need to remember from this part, These two are monoecious. Again, hermaphrodite they are. But when you talk about the Nereus is dioecious. Nereus is dioecious. So here in this Nereus, parapodia is meant for the locomotion. And here leech, in the case of leech, you will find the sucker, and here it is having the natural anti-blood coagulant hirudin. Natural anti-blood coagulant hirudin. Is that clear? Is that clear? So next is bache Arthropoda, the largest phylum of animal kingdom. So you know that here you are having the exoskeleton, right? The exoskeleton is made up of chitin, which is a homopolysaccharide. Jointed appendages are there. Compound eyes are present, okay? Compound eyes are present. So there are different examples. Acha, do you know what type of questions were there in NEET 2022 from this part? Huh? You want to know it or not? Do you want to know it or not? Tell me. And bache, to our session, the number of likes should be more than 500. Quick. Quick. Just a minute. Yes, do you want to know that? What type of questions were there from this particular chapter in NEET 2022? Are you want it or not? Yeah, tell me quickly. Quickly tell me. Bache, the questions were there on the basis of diagram. They were not asking you the direct question. From the animal kingdom, last year the questions were like this. Let's say, in which of the following group of animals the crop and gizzard is present? Right, the crop and gizzard is present. In which of the group of the animals this particular character is present? So you really need to focus on the examples. Okay, you really need to focus on the examples. Right, so see, in today's session was mainly diagram based, but if you have read the title, complete biology revision with the diagrams. So we are touching everything possible. Right, we are revising the entire syllabus. Right, so I know the things already. I know the things already, but you people don't know na. You guys are having an exam na. You people are having an exam na. So for that you need to show the energy. Right? You need to show the energy. You need to respond in the chat section. So whenever I'm asking any question, please revert in the chat section, guys. Kindly revert in the chat section. Okay? Done. And do share the session link with other students also. They should realize that one awesome session is going on. Right? One awesome session is going on. Done, bache? So these are the examples of the phylum Arthropoda without any exception. Open circulatory system is there in Arthropoda. If you remember the example of cockroach, hemolymph is present. Right? Hemolymph is present in the phylum Arthropoda. Remember? Done? Okay, so the next question, the second largest phylum Mollusca, right? The second largest phylum, it is having the shell, it is having the muscular foot, right? But it is having the mental cavity, it is having the radula, the gasping organ, the grating organ. Are you getting it? The grating organ. Are you getting it? So you can see this apple snail, that is pila, right? This is the octopus, the devilfish. So guys, this octopus is an exception. It is having closed circulatory system. Otherwise, this phylum is also having the open circulatory system. Right? Otherwise, this phylum is having the open circulatory system. Right, bache? Next is the Echinodermata. Very interesting phylum it is. It is having the mesodermal skeleton, just like the phylum Chordata, right? And here in this case also, right, the deuterostomous mouth is there. Deuterostomous mouth is there in the case of Echinodermata, Hemichordata and Chordata. So here in the case of Echinodermata, water vascular system is present. What is present? The water vascular system is present, right? Water vascular system is present. So this phylum Echinodermata, they do not have the heart, they do not have the brain, right? Water vascular system is there. Mouth is even on the ventral side. Mouth is even on the dorsal side. Anus is on the dorsal side, mouth is on the ventral side in their case. Okay. So examples are there. Asterius of Urus is there. right? Asterius or Furus is there, and I think you know that the starfish is having the great regeneration power. Okay, great regeneration power. Vaishali, as of now, whatever is mentioned in the chart, whatever is mentioned in the NCERT, just go for that. Okay. Okay, so here it is the balanoglossus, the connecting link in between chordates and hemichordates, right? It is the connecting link in between hemichordate and chordate. Are you getting it? So here you can see the proboscis, which is meant for excretion, Okay, so collar is there, the trunk is there. Done, bache? Done. So now when you talk about the chordates, there are 4 basic characters. How many characters are there, bache? There are 4 basic characters, right? That should be there. If we want to say that any animal is a chordate, the very first character is the presence of notochord, right? So notochord is a mesodermal. It's a mesodermal rod-like structure. It's a stiff structure, bache. It's a rod-like structure which will be converted to the vertebral column. Then there is the presence of dorsal hollow nerve cord, a very important feature that differentiates chordates from non-chordates. It's a very important feature that differentiates chordates from non-chordates. The chordates are having dorsal hollow nerve cord. Dorsal hollow nerve cord. Just have a look of this particular thing. Okay. So here you guys can see the notochord. Here you can see the dorsal hollow nerve cord, right? It is hollow, just like bamboo. It is dorsal hollow. In the case of non-chordates, it is going to be, in the case of non-chordates, it is, if not a nerve cord is there, it will be solid, it will be double. It will be solid, it will be double. Are you getting it? Are you getting it? And here you are having the pharyngeal gill slits. Can you see this? Pharyngeal gill slits, and then comes the post-anal tail, right? Then comes the post-anal tail. So these are the 4 basic characters, right? These are the 4 basic characters. Pharyngeal gill slits are there, and then comes the post-anal tail. Post-anal tail. So these are the 4 basic characters. Okay. Okay. So the comparison in between the chordates and chordates and non-chordates is important. See, notochord present, notochord absent. Central nervous system is dorsal hollow and single. Central nervous system is ventral solid and double. This is a very important feature on the basis of which differentiation can be there. Chordates, the central hollow, it is dorsal hollow and single, dorsal hollow and single. But in the case of non-chordates, it is going to be the ventral solid and double. Ventral solid and double. And here pharynx is perforated by gill slits are absent. Heart is ventral. In the chordates, heart is dorsal if present. So take your example. In our case, the heart is ventral. The heart is ventral. Post-anal tail is present. Clear, bache? Clear, bache? So again, now if you remember, in the case of phylum Chordata, there are 3 subphylums. Do you remember that, bache? There are 3 subphylums. So for that subphylums also we have the trick. The trick is you can win. For that subphylums also we have the trick, and the trick is you can win. What is the trick there, bache? What is the trick there? And speed up, guys, all of you, please speed up. Please answer in the chat section, all of you, very quickly. The trick is you can win. So this U stands for Urochordata. C stands for Cephalochordata. V stands for Vertebrata. V stands for vertebrata. So these are the 3 subphylum when you are talking about the phylum Chordata. So Uro means tail. So here in this particular subphylum, again exclusively marine, right? So tail. So notochord is present. Notochord is present in the tail region only, right? And in the larval stage only. Adult is not going to have the notochord. Tail, in the tail region only notochord is present, or only in the larval stage, right? So this particular subphylum, it used to show retrogressive metamorphosis. Retrogressive metamorphosis, right? It is the retrogressive metamorphosis. Cephalochordata. Cephal word is related to the head. Cephal word is related to the head. So here the notochord is present from head to tail. The notochord is present from head to tail. Are you getting it? Cephalochordata. Cephalochordata. Then comes the vertebrata. So here in vertebrata, what is going to happen? So in cephalochordata, notochord is persistent. It will be in the larval stage also. It will be in the adult stage. From head to tail, it is present. But in urochordata, the advanced character, the chordate-like characters are only there in the tail region. They are not present in the adult. That is why we use the word retrogressive metamorphosis. Okay? Okay? Done, bache. So vertebrata, in the vertebrata I told you already, notochord will be converted to the vertebral column. Notochord will be converted to the vertebral column. That's all. Okay. Now in the phylum vertebrata, as I said, see, agnatha, lax jaw. Only class is cyclostomata, circular mouth. Remember petromyzin, the lamprey, myxin, hagfish is there. Hagfish is an exception. It does not show the migration. Gnathostomata, superclass. It is having two superclasses, Pisces and Tetrapoda. So Pisces, the fishes, chondrichthyes and oxychthyes, cartilaginous fishes, bony fishes. And here it is amphibia, reptile, apes and mammals. So it is Aram. Amphibian, reptiles, apes and mammals. Amphibian, reptile, apes and mammals. So you need to remember it in one sequence. Right, bache? So here you can see the example of petromyzin. You can see the gill slits here. Examples of cartilaginous fishes, Collidin, Pristis. Pristis is the sawfish, also known as sawfish. This is known as dogfish. Okay. The next is hippocampus. Hippocampus is having the brood pouch. You know, it is the only male which gets pregnant. Do you know that hippocampus is the only male which gets pregnant? Do you know that, guys? Hippocampus is the only male which gets pregnant. It is going to, female is going to lay the eggs in the brood pouch, and then it is the hippocampus, the male is going to take care of that babies. The male is going to take care of that babies. And then here comes the catla. Catla, bony fish. Done, bache? So next is amphibia. You know that. In the case of frogs, so many things are there. Buccopharyngeal, from buccopharyngeal cavity, the gaseous exchange can be there. From skin also, lungs are also there. And see, it is the tailless amphibian. It is the tailed amphibian, the salamander. The salamander. Clear? The salamander. So how can you differentiate the salamander and a reptile? Salamander is having the smooth skin. The glands are present. In the case of reptile, the skin is going to be tough without glands. Right? So such examples are present here. The chameleon is there, the crocodile, chelon and snake, Naza. Okay? Okay. So this is for the birds. So examples you really need to revise. So I don't think that we should go in that detail. So bache, and if I talk about this table, already I told you about the features. I have already explained it. So you can use this table for the quick revision. Okay? You people can use this table for the quick revision. Okay? For the quick revision, you people can use it. Done, bache? Done. So next is morphology, and yes, I have made many tricks for the morphology, but I am going to share the tricks in a separate video. Okay, do you want tricks for morphology? If you want the session in which you want me to, share the tricks of morphology, then let me know, quickly let me know in the chat section, then only I'll make a separate video for that. The video dedicated to morphology only. Okay, the video which is dedicated to morphology only, all the examples will be revised with the help of tricks. Huh? Guys, you are running out of energy. You are running out of energy. Seriously, you people are running out of energy. Quick. Quick. Done? Sure. So I'll definitely post a separate video, but not today, obviously tomorrow. Okay, obviously tomorrow. Acha, you people are exhausted. It's okay, guys. After 7th of May, you just need to relax only. Furkana, that you have to check. Yes, there is a difference in crocodile and the alligator, right? But that difference you people need to check. There is a difference, and very interesting it is. Sure? Sure? Are you sure? Okay, done. So, I will post a separate video on the basis of for the morphology, right? With the help of tricks, how can you revise? I'll let you know, guys. Okay. So, this is see here taproot. So, in the case of taproot, the very basic point is, right, in the case of taproot, you should know about it. It is the radicle of the embryo which will form the taproot. It is the radicle of the embryo which will form the taproot. And when it comes to the fibrous root, we used to see this in the case of grasses. And when it is the adventitious roots, any part other than radicle, right, any part other than radicle. It is the any part other than radicle. Are you getting it? Are you getting it? Adventitious roots. Now, what is the next part here? This diagram is very important, and here it includes the regions of the root cap. It includes the regions of the root cap. So, guys, always remember this part is the tip of root, the apex, and here we have the base. This part is the tip of root, the apex, and here we have the base. So, when you look at this tip, obviously firstly you are having the root cap. Question used to come in the paper that tell us the sequence of regions in the root from tip to base or from base to tip. So, you really need to be active there. Crabs are not the insects, crabs are arthropoda. Okay, so focus here. So, when you talk about the tip, right, when you talk about the tip of the root, so this part is the tip region, the root cap is there, right. So, then comes the region of meristematic activity. Actively dividing cells are there, small sized cells are there, dense cytoplasm is there, large nucleus is there. Then comes the region of elongation. Now, these actively dividing cells, they will become, elongated. Then finally, the root hair region, the region of maturation is there. So, in the region of maturation only you will find the root hairs. In the region of maturation only you will find the root hairs. Right, you will find the root here. So, this is what you people need to remember. Okay, so meristematic, elongation, maturation. So, from tip to base, this is the sequence. From tip to base, this is the sequence. Clear, bache? Clear? So, these are the prop root again. The banyan tree, here we have the example of prop root, right? These are the pillar roots. Obviously, these are the adventitious roots. So, some prop roots, they are even hygroscopic in nature. They absorb the moisture. Done, bache? And here we have the asparagus. These are the modification for the storage, right? So, these are the modification of the root. So, here I would like to, specify one thing. It is even very important for the quick revision. Guys, this is the nematophore. This is the nematophore. We even consider it as the respiratory root, right? We found such nematophores in the case of mangrove plants. In the case of mangrove plants, we found these nematophores. Are you getting it? Right? Are you getting it? Now, here in the case of nematophore, the point that you need to remember is it is the tap root modification. What is it? It is the tap root modification. What is it? It is the tap root modification. It is the tap root which will get modified, first thing. And these are negatively geotropic. They are having the pores. We used to call that pores as lenticels or nemathodes, right? Nemathodes or lenticels. Nemathodes or lenticels. Are you getting my point? Are you getting my point? Mangrove plants like Rhizophora, Cenoraceae is there, right? These are the few examples. And now here you can see asparagus root, again the root modification for the storage of food. So, turnip is the example of bache. Please let me know, turnip, what type of root it is? Napiform, fusiform, what is it? Right? Tell me, turnip. It is the example of what type of root? It is the example of what type of root? That is, halophytes are there, na, saline, the one which grow in the saline environment. I am talking about this. I'm talking about this turnip. Turnip. Tell me. Turnip. It is the, what is it? Nepiform, tuberous, fusiform. What type of root it is? Turnip. Guys, speed up. Is it nepiform or fusiform? Guys, one answer. Your exam is there on 7th of May and it is literally important. Be sincere, people. Be sincere. Obviously, turnip it is. Right? It is turnip. So, see, the rounded part, the tip is pointed. Otherwise, it is the rounded part. So, it is the example of nepiform root. Nepiform root. And what about this carrot? Decus carota. Carota. What about the carrot? Carrot is the example of? Mention the answer quickly. Carrot is the example of? Quick. Carrot is the example of? Carrot is the example of? Nepiform is your turnip. What about the carrot? And all of them are tap roots basically. All of them are tap roots basically. But what is it? What is it? Conical, fusiform, nepiform, tuberous. What is it? Quick bachche, carrot we are saying. Carrot. Huh? Exactly. So, the carrot here is the example of conical root, and all of them are the modification of taproot. It is important. And what about sweet potato? And remember, sweet potato root modification, right? And the simple potato is the stem modification. Both of them are analogous organ. Sweet potato root modification, potato stem modification, both of them are analogous organ. So tell me, this this carrot is the Decus carota. Decus carota is conical. See, C for carrot, C for conical. What about sweet potato? Sweet potato is, and what about the radish? Even mention the radish. And what about sweet potato? Mention these example, bache. What about this sweet potato? Quick. Sweet potato. What about sweet potato? Exactly, it is the fusiform. What is it? It is the fusiform. Which one? Your sweet potato. Even radishes. Even if you talk about the radish, radish is also the fusiform, right? Radish is also the fusiform. Okay, the next part here, modification of stem. So ginger, what is it? Rhizome. What is it? Rhizome. So how can you differentiate a stem and root? Stem will have nodes and internodes. Stem will have nodes and internodes. Okay, so here we have the stem modification, like potato is a tuber, it's a stem tuber, right? Sweet potato is a root tuber, and both of them are the analogous organ because their function is same. Their function is the storage of food, but their structure is different. One is root, another is stem. It is important, right? It is important. So now tell me, what about this zamikan and what about this zamikan? So rhizome mein we have the example of ginger, right? We have the example of ginger. And what about this zamikan? Tell me. Elephant foot it is. Tell me any example that you know. Like when you talk about the corm, we have the example of colocasia. Remember, we have the example of colocasia. In the case of rhizome, we have the example of ginger, and other than that, even banana is also the example of rhizome. Even banana is also the example of rhizome. But what about this zamikan? Zamikan is also the example of, yes, it is the example of corm. Right, even colocasia, even the zamikan, both of them are the example of, yes, both of them are the example of, yes, bache, both of them are the example of this corm. Done? Done? So this is what you need to remember. So com is your colocasia also, it is zamikand also. So zamikand is amorphophallus. It is amorphophallus, elephant foot it is. So this is what you need to remember. This is what you need to remember. Okay, so axillary bud is modified into tendril. The examples are important. Roots are arising from the nodes, right? So this is for the vegetative propagation. So in the case of bougainvillea, again the stem modification is there. Stem is modified into spine. So bougainvillea is having the spine. Bougainvillea is having the spine. So this is what you need to remember. Okay, bougainvillea is having the spine. Done, bache. And for phyllotaxy, which is the arrangement of leaves, again I have different examples. You guys can see the examples here. Like in the case of your, I hope you remember the examples. China rose is there. Your mustard is there. The sunflower is there. It is the example of, can you tell me? China rose, mustard, sunflower. So it is the example of alternate phyllotaxy. Like see, one leaf is present at one node, right? This node is having one leaf on this side, this node is having one leaf on another side like this. So it is alternate. It is also known as spiral, right? It is also known as spiral. So it is China rose, mustard, even the sunflower is the example. Okay, even sunflower is the example. And when you talk about the world phyllotaxy, then it is the Allistonia. Then it is the Allistonia. Oh, this is opposite. This is alternate and spiral. This is opposite. Okay, guava, calotropis. So I'll share that video in which all the tricks will be shared. Okay, all the tricks will be shared. So till then you guys can revise it. So leaf modifications are also there. The tendrils, the spine, even the onion is there. Fleshy leaves are there. Right? It is bulb basically. Onion is basically a bulb. So fleshy leaves are forming this. Done, bache? Fleshy leaves are forming this. Now, bache, we have two type of inflorescence. One is the racemose. One is the racemose and another is cymose. Right? Another is cymose. Even this is important. So can you tell me the basic difference in between racemose and cymose? Can you just tell me the basic difference in between the racemose and the cymose inflorescence? Anyone in the class? I am not asking for the examples. For the examples, I will share one video with all of you. But can you tell me the basic difference in between the racemose and cymose inflorescence? Yes? Racemose and cymose inflorescence? Anyone? Anyone? Racemose and cymose inflorescence? See, it's very simple. R for race. R for race. A for acropetal. A for acropetal. You know, how do I remember it? Now, there is a race. Right? There is a race. Right? Life is a race. We are just going and going. There is a race. What is there? There is a race and race. So in that race, obviously there is a race. So young people, those who are active, this is just a trick. This is what we need to remember, because today we cannot follow the same criteria, but this is a way to remember this. So when you talk about the racemose inflorescence, this inflorescence axis, right? You have to remember it's just like a race. So this inflorescence axis is just growing and growing. This inflorescence axis is just growing and growing. First of all, this is what you need to remember. Like, you cannot say that it is terminating. No, it is just growing and growing. It is just growing and growing. This is the first part. Secondly, at base, right? Secondly, at base, you will find the old flowers, and towards the tip, you will find the young flowers, right? So what is my way to remember it? As it is a race, right? It is a race. So we are just running and running. So young people are near to the finishing line. It is not you cannot say that there is any finishing point. No, young people are near to the finishing line. Young people are near to the finishing line. This is my way to remember it, right, bache? So we can say that older flowers at base, older flowers at base, right? Young flowers near to tip. So this type of arrangement where, you know, the older flowers at base, this is basically the acropetal arrangement. So that is how I remember it, right? So it is racemose inflorescence, racemose inflorescence, Ra. So from R, race, from A, acropetal. From R, race, from A, acropetal. Clear, bache? So it is a race, so that axis will keep on growing. So the young flowers will be near to the tip and the old flowers will be present at the base. Old flower will be present at the base. So is that clear? Is that clear? So you tell me about your tricks. How do you remember it? Yes, bache. How do you remember it? Tell me guys, when you will get this question in the final paper, na, then you all will think, yaar, Ambika ma'am was teaching us something. Right, Ambika ma'am was teaching us something. Now we are not able to recall. है ना? है ना? Because now to you guys are distracted. Oh, ma'am, we are feeling sleepy. Ma'am, we are done. But when you will get same question in the final paper, na, then you all will think, arey, she was teaching us something. Now we are not able to recall. Seriously. So now just don't waste your time. Just focus here. Those who are chatting in this comment section, na, they are just here to waste your time and their time. They don't want to qualify the NEET exam. So just focus here. Okay. So racemose. And another is the cymose. So in the cymose, the opposite thing, obviously, the tip is, at the tip the flower will be there. Right, so you can say that this inflorescence axis is terminated. So the arrangement is going to be the basipetal. So the older one will be at the tip and the newer one, the younger one will be there at the base. Basipetal arrangement is there. Okay, so this is about the flowers, bache. The hypogynous, so hypogynous flower, right? Hypo means something low. So here in hypogynous flower, the ovary is superior, bache. The ovary is what? The ovary is superior. The ovary is what? It is superior. Now, so ovary is superior means it is at the top position and other floral parts are down to it. So obviously ovary is not getting that level of protection. And ovary is a structure in which our ovule will be there, in which our ovule is there, in which ovule will form the seed. So it should get more protection. So in the case of hypogynous flower, we used to say ovary is superior, it is at the topmost position, all other floral parts are present at its lower side. So the level of protection to this ovary is not there. So it is hypogynous. It is hypogynous. Got it, bache? Then when you talk about the B and C, see, diagram based question can come from this part. Diagram based question can come from this part. B and C is perigynous. Now when it is perigynous, it is half inferior. The ovary is half inferior. So you can just see that here at the rim of the thalamus, the floral parts are present here. Right? It is not totally fused, but here it is present. Some level of protection is there. And when it is the epigynous, the ovary is going to be inferior. It is present at base. The thalamus is fused here. So all other floral appendages are present above it. So this is how, that is how you need to remember. Right, bache? That is how you need to remember. So here the parts of flower that we have already covered. So K denotes the calyx, C denotes the corolla, right? A is for the androecium, G is for the gynoecium. So calyx is having so many sepals, corolla is having so many petals, androecium is having so many stamens, the group of stamens, and gynoecium is having that pistil or the carpel, right? So any flower which is bisexual, that is the complete flower. Any flower having any of the flora in which the floral parts, these floral whorls are absent, that is going to be the incomplete flower. Basics, quite basics. So next topic is bache estivation. Estivation is arrangement of these petals. So if you look at this velvet estivation, for diagrams I will make separate video with the help of tricks, but till then you all can mention the examples in the chat section. Right, you have to mention the examples in the chat section, bache. Example of all these estivation in the chat section. Guys, be quick, please. Do you want to revise this? Do you want to revise it? Yes? Dhanusha, please focus here. So just mention the name of the plants having velvet estivation in the chat section. Quick, name of the plant having velvet estivation in the chart section. Velvet, where you know these petals are not touching each other. basically they are touching each other, but they are not overlapping each other, velvet estivation. Then comes the twisted, obviously twisted it is, right? So a lady, remember, a lady is having a finger, something, something, ring, cotton, finger, lady finger, something, something, remember? So velvet estivation is in, very good, very good. What about twisted? What about twisted? Bache, perigynous is having a half inferior. The ovary is getting the protection. The other floral appendages are present at the rim of that thalamus. Very good. Very good, Furkana. You should not do it. Very good, very good. So in the case of twisted estivation, the China rose, the cotton, lady finger, the examples, right? Right? Done. And what about this imbricate? In the imbricate, see, one petal is overlapped from both the sides, right? It is overlapped from both the sides and then it is following that normal twisted pattern. Only one petal is there which is overlapped from both the sides. Otherwise, it is following that normal pattern, right? So it is the imbricate. So in the imbricate, the example is, in the imbricate, the example is, in the imbricate, very good Priyo bache, Cassia and Gulmohar. Now bache, this vexillary. In vexillary, this is the standard petal. See, here the arrangement is just like this. The arrangement is just like this, right bache? So here you are having the keel, the carina, remember? Keel, the carina, this large petal, this large overlapping petal is there. This large overlapping petal is there, remember? Large overlapping petal is there. It is covering both the lateral petals, right? So this is the keel, carina, or wings or LA, you can say. This is the keel and carina, wings or LA. They are fused here. So you will find such type of estivation in the case of pea plant. Remember, in the case of pea plant, that type of arrangement. Done? That type of arrangement. Done, bache? It is not Katrina calf, keel and carina it is. Okay, keel and carina it is. So can you tell me about the examples? Pea, bean, the family Fabaceae, you are right. So vexillary is also known as such type of corolla is also known as papilionaceous corolla. It is also known as papilionaceous corolla. Remember, papilionaceous corolla. Just a minute. Done? Sure? So standard, also known as vexillum, keel carina, wings LA. So you need to know such names. So the next here is the placentation. So it is, in the case of pea plant, this is the marginal, right? This is the marginal. So basically these are kind of seeds now, so they are attached to these margins, right? So marginal it is. What is it? It is the marginal. And here you know that it is the axile placentation. So here the ovary is multilocular. So you can say that here the ovules are present. So such type of placentation is there in the citrus family. In the case of citrus, Rutaceae family, citrus family is having that, right? Even your tomato is having the axile placentation, right? So in the case of tomato, even the placenta is edible. It is a PYQ, bache. The placenta is edible. It is a PYQ. What is it? It is a PYQ, right? So this is the parietal. So you can say that the ovary is unilocular. Here you can find the ovules, and this one is the basal, the most advanced placentation, and it is the free central. So here you need to know the diagram and their name. Diagram and their name. Citrus family will include everything now. The orange, the lemon, and A is the marginal. And here in the case of marginal placentation, even, you know, there is a false septum, rapellum also. There is a false septum, rapellum, false it is. It is not a true septum, false septum which divides that ovary into two locules, right, in the marginal. in the marginal. So the next here is bache fruit. So this is the example of drupe. Remember, this is the example of drupe. Here the stony endocarp is there. So now in the case of mango, it is the mesocarp. Outer covering is the pericarp, mesocarp. Inside it is endocarp. So stony endocarp is there. So it is the mesocarp which is fleshy and edible. Which is fleshy and edible. Clear bache? Which is fleshy and edible. Done bache? So it is the example of drupe. And about this dicotyledonous seeds, I have already taught you this part, the cotyledonary node, 2 cotyledons, apicotyle, then plumule, hypocotyle and radicle. We have already covered it. So here in the seed, the micropyle is a aperture from where the gaseous exchange will be done. And hilum is that scar, right? 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 Hilum. It is showing that part ki haan, this seed was attached to this, the seed was attached to ovary at this particular point. Done bache? Done? So the seed also we have discussed bache. So in the case of monocots, especially you can say that in the case of grains, the fruit covering, the outer covering of fruit and the seed covering, they are just like fused. Seed coat and fruit wall is just fused. This is what you need to focus. So alluron layer, proteinaceous it is, right? Proteinaceous it is, and the seed is endospermic. Endosperm here. This is scutellum. The shield shaped, you can say that cotyledon, colutile, coleorhiza is there. We have already covered it in sexual reproduction in flowering plants. We have already covered it in sexual reproduction in flowering plants. But then comes the floral diagram, and here you know that it is of brassicaceae. So here you can see the mother axis and see how sepals, petals, androecium and gynoecium is arranged. So this is what you need to remember. See this sign. This sign is showing actinomorphic flower. Actinomorphic means radial, right? Radial means any part, any plane can divide it into equal halves. Actinomorphic it is, radial it is. Now this sign shows the bisexual, right? So if you will look at these sepals, you are going to denote it with the help of K. Okay, so total sepals are 4, 2 in outer wall, 2 in inner wall. That is why 2 plus 2. Now focus on the petals. So petals, see 1, 2, 3, 4. But here again 2 whorls are present. Then when you talk about this androecium, so again 2 whorls are there. 2 are in outer wall, 4 are in inner wall. So 2 plus 4. Tetradynamis. Now I can see that I am feeling sleepy. What is the word? I just forgot it. What is the word? Didynamis, tetradynamis. Dynamis is the word na? Dynamis is the word na? All of you yaar, please answer in the chat section, quick. Didynamis, tetradynamis. So here it is tetradynamis. 2 are present in the outer wall, 4 are present in the inner wall. Right? 4 are present in the inner wall. Tell me, quick guys, quick. Seriously, it is not the Solanaceae family, guys. I think you are too bad with the morphology, isn't it? Tetradynamis. Hai na? Revise this. Tetradynamis it is. Good. 4 plus 2, total 6 filaments are there, 6 stamens are there, but they are present in different wall. 2 outer, 4 inner. Tetradynamis, it is not tetramerous, tetradynamis is the word. Okay. Yeshu Babu, don't worry, I'll call NTA officials, right? They will call me back and then they will tell me, oh, at this time the admit card is going to be out. Ma'am, you just take a chill pill. Don't worry, chill. City display list is out now, so definitely your admit card will be out too. It is tetradynamis arrangement. Okay, so gynoecium here is bicarpillary and it is fused. Bicarpillary and it is fused. So this is what you people need to revise. The different example, the pisum sativum, all that things. You need to remember. Okay, bache. So I'll share a video in which we will talk about the tricks. Okay, we will be discussing the tricks actually. for the morphology. And now the topic that we need to revise is this anatomy. In the anatomy, the vesicular bundle, the secondary root, the secondary growth in the dicot stem, these two topics are very important. These two topics are very important. So I am not going to take your much time, right? I am not going to take your much time. Let's finish the anatomy, because human physiology is already completed. In the plant physiology, I have already taken the most important topic. So in that topics, we have covered that diagram. So this is the last topic that we are going to do. So I think now you should show some energy. Now you should show some energy, isn't it? Thank you, bache. Isn't it? This is the last topic, anatomy of the flowering plants. So let's revise this chapter now. Let's revise this chapter, and please focus here, guys. Please focus here. How many pages are left? Let's complete anatomy, because already in that marathon session we have used all the diagrams of the human physiology. So I'm not going to touch that again. Even in the plant physiology session, the complete plant physiology one shot, right? We have revised it. So all the important diagrams are revised there. So let's finish this chapter, guys. Speed up. But a dress code video will be shared. Yeah, we'll share it by tomorrow. For sure. We'll share it by tomorrow. So guys, speed up. Ma'am, I'm not feeling well. Even I am not feeling well. Still, I'm taking the class. Ma'am, what is best for now? Now you should practice the questions. As much questions as you guys can. And whatever chapters are not prepared, you can just check out their short notes. Okay? So today after the class, all of you, because it will just take 10 seconds. You are going to put a comment in the comment section, right? You will tell me that you liked this session or not, right? You have to mention it. Right now, no need to put it in the chat, right? Just put it in the comment section. Right now, there is no need to spam. After the class, just mention it in the chat section, in the comment section, that whether you liked the session or not. Okay? So that's a request. It is just going to take 10 seconds. So I want all of you to comment there in the comment section. It's a request. Okay, and the PDF will be shared in the Telegram group. How to boost the score? Solve as much questions as you can. And you know, tomorrow even at 7 p.m. there is one more marathon for the biology, in which we will be covering the important. We'll revise this complete syllabus with the help of PYQs. So that session will be for 2.5 hours. Right? Even tomorrow I am going to take one session, the complete biology revision. But questions will be. But I am going to ask the questions here in this session. Right? So tomorrow 7 p.m. one more session is there, where the entire biology will be revised. Okay? Okay? Done? So now let's talk about the anatomy. Anatomy means the internal structure, right? Cell, tissue, organ, you know about these things. These are very basic things. So here we are going to revise the simple tissue and the complex tissue. So when you talk about the simple tissue, you can see the parenchyma. Parenchyma, the living tissue, right? So here intercellular spaces are present. They can be absent, but here they are present. Now when you talk about the collenchyma, but these diagrams are important. You really need to focus on these diagrams. So when you talk about the collenchyma, here see cell wall. See here, thickening is present at the corners. Thickening is present at the corners, right? Now when you talk about the sclerenchyma, it is dead. Sclerenchyma is dead, and you have the tracheids, and you have the fiber here and the sclereid here. Fiber here and the sclereid. Fiber is this long, pointed, having the lumen, having even these pits. Sclereid, you know that it is kind of circular. So many pit canals are present. So these diagrams are important. Ma'am, I don't, guys, ruko, let me do something with this spammer. We don't want spammer in our classes. So please focus here. So parenchyma, this. So isodiametric cells are there, intercellular spaces are there. These are the living cells. Here in the case of collenchyma, you will find the sides are, thickenings are present here. In the case of sclerenchyma, they are dead, because protoplast, it is dead basically. Living protoplasm is not there. So two things are there, fiber or sclereid. Fiber or sclereid. Fiber or sclereid. Got it? Now it is the xylem and phloem. But xylem and phloem, you know that they are the vascular tissues. They are the vascular tissue, and they are the example of complex tissue, because they are not made up of one type of tissue only. They are made up of many. right? They are made up of many. So when we talk about the xylem, xylem is having the tracheids and vessels. Xylem is having the tracheid, xylem is having the vessels, xylem is having the fibers, and even xylem parenchyma is also there, right? Even xylem parenchyma is also there. So out of that, these tracheids, the vessels, the fibers, they are dead. What are they? They are dead. What are they? They are dead. Are you getting it? Only parenchyma is living in the case of xylem. And here in the case of xylem, these vessels, they are the feature of angiosperms. It is an advanced feature. It is the feature of angiosperms. It is the advanced feature. Are you getting my point? It is the advanced feature. It is the feature of angiosperms. It is the advanced feature. But in the case of gymnosperms, right, there is one exception also. Gymnosperms of order Neetales. Gymnosperms of order Neetales. They are the exception, bache, because they are having the vessels. Even there are some pteridophytes which are also having the vessels. Usually vessels, they are vessels, it is the feature of the angiosperms, but there are some gymnosperms, the gymnosperms that belong to order Neetales, like Neetum is there, Ephedra is there, so they are having the exception, they are having the vessels. There are some pteridophytes also, bache. There are some pteridophytes also which are having the vessels, but that example is not so important. So tracheid, vessels, so they are dead, so water will go up, you know that. Xylem, unidirectional mode of transport is there, right? So negative hydrostatic pressure will be maintained here in the xylem. So you can see it, the tracheids, the vessels. So even the diagrams, so they can ask you the question from the diagrams. You can see the perforations there, right? Right, bache. So now here what do we have? We have the phloem. Here what do we have? We have the phloem. So in the case of phloem, you remember, sieve tube cells are there. The companion cells are there, phloem parenchyma is there, and phloem fibers are there, right? Even phloem fibers are there. Are you getting my point? So here in the case of phloem, all the three are living, but fibers, they are dead. And in the case of phloem fibers, we have the example of bast fibers. Okay? Okay. So here one extra point that you need to remember is कि in the case of gymnosperms, we do not have the companion cells. We do not have the companion cells. In gymnosperms, albuminous cells are there. Albuminous cells are there. Are you getting it? Albuminous cells are there. Okay? Okay. So, bache, sieve tube cells are just like the mature RBCs. They are enucleated, right, bache? Companion cells are just nearby to these sieve tube cells. So, in the plant physiology topic, I told you already, right? The loading of the sucrose, the unloading of the sucrose, both of them need the energy. So, guys, do check that complete plant physiology one shot. You can check it at a speed of 2K also. Okay, you can check it at a speed of 2x also. I am saying 2K, 2x. Okay, so one more question is here. Just look at the stomata. So you know that this is the stomatal opening and these are the guard cells. So guard cells, they are kidney shaped. They are bean shaped in the case of, this dicots. In the case of dicots, what are they? In the case of dicots, they are bean shaped. So here the inner wall is thick. The inner wall is thick. And cellulose microfibrils are there, but they are radial, right? So whenever the turgor pressure of guard cells will increase, it will help in the opening up of the stomatal pores. It will help in the opening up of the stomatal pores. Guys, do not get distracted with the spammer. Chill, chill. Such type of spammer you will even find in your life. So just ignore. Okay, so focus here, right? So stomatal pore is there. So this inner lining, inner membrane is thick, radially placed. Cellulose microfibrils are there. So you know that these are the guard cells, the modified epidermal cells, and in the surrounding subsidiary cells are present. Accessory or subsidiary cells are present. Done, bache? So in the case of monocots, you can see the dumbbell shaped guard cells are present. Done. Dumbbell shaped guard cells are present. So when these guard cells will open, when the turgor pressure here will increase, water will come in, it will open up. Okay, it will open up. So stomatal opening is meant for the gaseous exchange. It is meant for the loss of water in the form of transpiration. That transpiration is going to pull the water up. So all that things we have covered in the plant physiology. Okay. Dumbbell shaped in monocots, dicots. In the case of dicots, it is bean shaped, kidney shaped. Done? Yes. This part is very important, the vascular bundle. In the vascular bundle, we have the xylem and the phloem. In the vascular bundle, we have the xylem and we even have the phloem. We have the xylem, even we have the phloem, right? So now just look at their arrangement. Two type of arrangement we are going to discuss. One is the radial vascular bundle, another is the collateral, or you can say that conjoint. One is the radial, another is the collateral and conjoint, right? Another is the collateral and conjoint. So when you talk about the radial, how can you remember it? Just a minute. So when it is radial, root, conjoint is present in the case of stem, in the case of leaf, right? Stem in the case of leaf, stem and in the case of leaf, right bache? Stem and in the case of leaf, right? In the case of leaf, R for radial, R for root. So here the xylem and phloem is present at, xylem and phloem is present at different radius. They are present at different radius. Like you can take one example, bache. Let's say here you are having the xylem, here you will be having the phloem, here you will have the xylem, here you will be having the phloem. Xylem is there, phloem is there. So here you can see xylem, phloem, xylem, phloem. So it is present at different radius, R for radius, R for radial, right? Radius, root, radius, root. Conjoint, where it is together, right? The xylem and the phloem, the xylem and the phloem, and they are nearby. So we also use the word collateral. So we can say that xylem and phloem is present at same radius, isn't it? Xylem and phloem is present at same radius, isn't it? But you will not even get a single mark. Okay, Joel? You will not even get a single mark. Okay? Done? Done? Is that clear, bache? Done, bache? So it is the collateral. So radial clear, radial clear, radial you will find in the root. So let's say in the paper you are having a section. In that section they are asking whether it is of stem or root. At least by looking at it you can say whether it is of root or it is of stem, right? You just need to check the vascular bundle. So here, if you people focus here, see the xylem, and in between the phloem. Done? The xylem, the phloem, right? So these are the radial in the case of root. So now how to differentiate? How to differentiate monocot and the dicot root? In the dicot root, the arrangement, see these vascular bundle, it can be from diarch to tetrarch, right? 2 to 4 such type of vascular bundles can be there. 2 to 4 such type of vascular bundles can be there. But if you will look at the monocot root, in the case of monocots, they will be polyarch, right? So many xylems will be there. This is what you need to focus. So now, are you clear with the section of the root? Are you clear with the section of the root? So just have a look, right? Right? Now, bache, there are two another points. In the conjoint and collateral, there are two categories. Open, closed. One is open, another is 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 closed. Right? One is open, another is closed. So when it is open, how can you remember this? It is open, open, open for secondary growth. That's how you have to remember it. Right? So it is open for secondary growth. When it is closed, closed for secondary growth. It is closed for secondary growth. right? So definitely it will be there in the case of stem majorly. So open for secondary growth. What is the meaning of this statement? Here bache, open. If it is open means secondary growth is there. So it is only possible because of the cambium. Because of the cambium. So xylem will be there, phloem will be there. In the conjoint collateral open vascular bundle, cambium will be present in between. And here in the closed, there will be no cambium, xylem and phloem is directly present. So this is something again very important. It is again very important. Can you see that? Can you see that? Now when you look at the roots, see radial vascular bundle is there. And here the protoxylem, the smaller, the xylem which is small in size, protoxylem, the xylem which form late. The protoxylem is towards the periphery. It is towards the periphery. So that type of arrangement is exarch. So can I say that in roots the vascular bundle is radial? It is exarch. It is radial. It is exarch. Can I say that? It is radial. It is exarch. Now when you talk about the stem, this protoxylem is towards the pith. So it is going to be endarch. That's all. It is going to be endarch. So you know anatomy is the simplest topic ever. Anatomy is the simplest topic ever. Now just look at this. Right, bache? Just look at the section of the typical dicot. In the case of dicot, a ring-like arrangement is there. So dicot stem. In the dicot stem, there will be the secondary growth. Cambium is present here. The vascular bundle is arranged like a ring. The large pith is there. So here, this is what you need to focus. This is what you need to focus. So you can see the collenchyma, the parenchyma, endodermis, pericycle is there. Phloem, cambium, metaxylem, protoxylem. So the arrangement is endarch. So vascular bundle can help you to identify whether it is the root or it is the stem. Now in the case of monocot stem, vascular bundles are scattered. Small sized vascular bundles are towards the periphery, large sized are towards the pith. That's all. That's all, and there will be no cambium here. Now this is the dicot leaf, that is the monocot. Dicot leaf it is. So dorsoventrally flattened. Dorsoventral leaf it is, and here it is because it is same. Both the sides are same, so it is isobilateral. Right? So in the dicot leaves, you will see this type of, in the mesophyll cells. Mesophyll is basically the cortex of the leaves. So palisade and spongy parenchyma is there, but such differentiation will not be present here. Right? Right, bache? Right, bache? So this is about the secondary growth in the case of dicots. So see, bache, you know that secondary growth is possible because of secondary meristem. Secondary meristem, what is the secondary meristem? Like see, primary meristem which will form during embryonic stages, secondary meristem in which you know the permanent tissue, when again it gets the ability to divide, when again it gets de-differentiated. Right? This is the key word here. De-differentiated. De-differentiated. This is the key word here. De-differentiated. So when permanent tissue it gets de-differentiated, then it will become actively dividing and again it will become re-differentiated. So when it gets de-differentiated, it will become actively dividing, then it is the secondary meristem. So here vascular bundles are already in a ring. So we need to fill up this ring. Right? So here intervesicular cambium will form. These cells will become active again. So if you will see here, intervesicular cambium will start growing. And then you know that towards the inner side, xylem, towards the outer side, phloem will form. Right, this is the intervesicular cambium. Towards the inner side, secondary xylem. Towards the outer side, secondary phloem. So, right, secondary xylem, secondary phloem, secondary xylem, secondary phloem. Slowly, secondary medullary rays will also form, bache. Right, so all that differentiation will occur. Done? So, this is what you need to revise. Okay? Once from NCERT, that's all. That's all, bache. So, rest is all simple. The muscles, the parts we have already discussed. In the case of cockroach also, you know that compound eyes will be there, right? This part is the pronotum, right? The head, thorax and abdomen is present. In the case of males, you can write down this part. Anal style is present. Males, they need to be stylish to impress the females. No offense, but this is how you have to remember. Males, they need to be stylish to impress the females. So in the case of males, anal style is there and anal circus Anal cerci is also there. But in the case of females, you know, na, male and female are having the sexual dimorphism, right? So this is also a point of difference. In the female case, only anal cerci, anal cercus is there, but in the case of males, anal cercus and anal style both are present. Both are present, right? So here you guys can see the thorax is having 3 segments, the prothorax, mesothorax and metathorax is there. Right, prothorax, mesothorax and metathorax is there. Each segment is having that pair of legs, bache. Then these abdominal segments are also there. So total 10 segments are present. Right? Right or wrong? Done. So this is what you need to remember. So about the mouth parts, you can see the ocellus. Ocellus is nothing, it is the simple eye. And here we have the compound eye also, which will provide the mosaic vision. And this compound eye is having the ommatidia. So many ommatidia are present. Right, bache? So maxilla, mandible, labium is there. Hypoglossal is there, which is, hypopharynx is there, bache. Right? So see, mandible is meant for grinding. Incision region is there. Done? So just revise it once. You will get only one question will be there from this part. So total 13 segments are there, even in the heart. And if I have to divide it like this, 3 and 10. 10 in abdomen, 3 in the thorax, total 13. So heart is like this, 13 chambers. You can see this. Alary muscles are present in the heart. These are the chambers of heart. Right, the open type of circulatory system is there. So here in the case of this digestive system, crop and gizzard is also present in the case of this cockroach, bache. And at the junction of foregut and midgut, hepatic CK will be there. Right, so they will release the digestive juices. And at the junction of foregut and hindgut, Malpighian tubules meant for excretion is present. This is important. At the junction of foregut and midgut, the hepatic CK. At the junction of midgut and hindgut, Malpighian tubules are present. Important it is. Right, important it is. And about the male and female diagram, that we have already discussed, bache. Right, that we have already discussed. So cell division, right, the physiology part, we have covered all that things in the individual sessions. So I really don't think that now we should stretch it. So if you guys are having any doubt, you people are free to ask the questions. Right, you guys are free to ask the question. PDF will be shared in the Telegram group. And guys, see you all tomorrow. Tomorrow Shreyas sir is going to take the physics formula revision. Even your HSP sir will start the session. He will start with the inorganic revision. So stay tuned for that session. Even I will take the complete biology marathon once again. But with the help of what? But with the help of PYQs. Right, bache? But with the help of what? PYQs. Done? So, after the class, guys, it's a humble request. Do mention it in the comment section that whether you liked it or not. And do subscribe our channel. Right? Do subscribe our channel. Do mention it in the chat section. Do mention it in the comment section, guys, whether you liked it or not. And we have planned one more session for top 1000 questions. I'm telling you again and again, please click that notify me button so that you will get the notification. That session is literally very important. Right? From the 1000 question, for sure you will get 180 questions. Okay, so do check the schedule for the upcoming days.